Ladies and gentlemen, our show starts in 5 minutes. Ladies and gentlemen, 2 minutes to the start of the show. Please take your seats. The program starts now.
And go for lights, go for sizzle video.
Welcome to Imagine 2022, live from the Computer History Museum in Mountain View, California. To start things off, welcome on stage Zach Shelby, Edge Impulse's CEO and co-founder.
Wait a second. This robotics demo is way too cool. We're going to play a little bit with this first. So, Dom, tell me more about this robot. We've actually embedded AI in the robotic arm.
Yeah, sure. So this is a collaborative robot, and we have Ready Robotics Forge OS running. So that's what you're seeing there on that control pendant. And best thing about it, the same interface can connect to 100 models of different industrial robot.
And we're combining sensors in real time, streaming those to an AI model. Like, how does that actually work to then deploy? And then what do we use that for?
Yeah, so well, typically people running robot tasks want to optimize the performance. They want to make sure they're operating normally and don't experience mechanical failures. And one great usage of Forge OS is to get that data out of these robots. And so we've got joint data coming out of all of these joints. We've got a Balluff sensor with accelerometer and temperature, measuring the condition of the robot, and this is all being streamed into Edge Impulse.
So in real time, we can deploy a model in the factory.
That's correct.
To the robot, and this enables us to do very domain-specific workloads.
Yeah, the beauty of all of this is we can capture data directly from a live robot into an Edge Impulse project, retrain and redeploy very, very quickly.
Amazing. All right. I got a keynote to go to. Thank you, Dom. I'll see you soon.
Thanks, Zach.
I did just de-hand the robot from outside. Seriously, this is the coolest demonstration I've seen in a long time, combining robotics and artificial intelligence all together. And I'm going to tell you a lot more about this robotics application soon. But first, welcome everyone to Imagine 2022 at the Computer History Museum. Amazing to see you all here. We love this venue. When we use this, we're also helping support the great work they do here in conserving all this amazing compute technology that inspired me, at least as a child, with my first Commodore 64 that a friend recently got me again. So I have my own Commodore 64 again at home. So I find that super inspiring. 3 years ago, just over, Jan and I started Edge Impulse. And we could never have imagined the over 100,000 machine learning workloads that people have created using this tooling. All the innovation, all the energy, all the invention that goes into this is really inspiring for us. So Imagine couldn't be a better name for this event. This is all about bringing all the most amazing workloads, solutions, and enterprise applications, nature conservation applications in the world together here. And we're here to help you network and gain the value that you're looking for from data and machine learning. So use today for you. Learn all about the amazing stuff that's being worked on in our community, and we're here to connect you together. Now, the applications of machine learning might be endless, but we have to remember that it's not automatic that we're going to see all that value from machine learning. There's a few things that we need to focus on doing, and they're hard. We need developers, and we need AI workloads. Without these two things, the market that we're in won't blossom. It won't grow. So I'm going to talk a lot today about our ecosystem. How are we connecting developers with money, and eventually money to silicon? Right? So this is a very hard thing to connect, so I'll do my best. But first, I want to talk a little bit more about robotics. So what you saw outside has been many, many months in the making, a partnership between Ready Robotics, Edge Impulse, and industrial sensor maker Balluff. And what we're able to do is insert AI directly in the robotics process. And this is important. It's not just on the top somewhere else. It's in the actual assembly cycle. Every robot has a very specific workload. Depends on what it picks up, how fast. That means that every robot has a very specific sensor signal signature. So what we're able to do here is tune a very precise AI anomaly detection algorithm on the exact sensor usage pattern of that robot sitting out there. We actually had to recalibrate this algorithm when we brought this to the Computer History Museum because we're one floor higher than our office in San Jose. So it's a great example of why you need to be able to do AI tuning, AI modeling right on the robot. And what happens here is anytime we do anything, so when I touch that robot, we get an anomaly just like that. And that enables us to do completely new things with condition monitoring, efficiency monitoring of these robotic cycles, maximizing the speed of the robot before we have an anomaly. Human safety. Is somebody touching the robot? For example, my CMO put his finger in the robot clamper the other day. Do not let the marketing people anywhere near the robot. That's the new rule. But how does this all work? We're able to connect the sensors from inside the robot. So robots come with things like torque sensors, position sensors, current sensors built in, together with external sensors. So we took an industrial Balluff sensor you can use on industrial machinery. We connected that to the arm. That all gets integrated through what's known as Forge OS. And Forge OS is what Ready Robotics does to kind of generalize, like we do in HAL layers in embedded systems. They're doing this for robotics. They've then taken all those sensor streams and made a very simple UI that says, choose these sensors, send it to the AI engine, send it to Edge Impulse. And so we're enabling that very, very simple user experience. Choose the sensors. Now I want to send this to the AI thingy. And this is designed for a technician in the field, at the factory, setting up a new workload. That data goes to Edge Impulse. We train a new anomaly detection model based on that data. And then we very simply build a small Linux package, send that back down to the robot, and boom, that's standalone forever. That model will run on the robot. This afternoon, Jan's going to talk about a new technology that we've been developing called on-device calibration, on-device learning, for the purpose of retraining this model on that robot in the field. Again, no internet connectivity needed, because that robot might be slightly different, like our problem outside. To move the robot to the second floor, we had to recalibrate that robot. This, I think, is going to start a whole new revolution in data and robotics. And we're going to see that in every kind of robot form factor, even these small little vacuum cleaners that you have around your house. These will be enabled with AI-type anomaly detection going forward. You're going to hear a lot more about this morning. So we're going to have Ben, the CEO and founder of Ready Robotics, talk about industrial automation and machine learning. And Hubertus from Balluff talk about industrial and the edge. Really deep into the industrial space, we'll hear a lot more. Now, we're here together for a reason. My motto for the last year since Imagine has been, our job is to put ML in real products. That's what we're here for. That's what drives us day in and day out. How do we use machine learning in real stuff? But it's not just us. It's not just the Edge Impulse folks. It's all of you are here together to put machine learning in real products. And it takes a village, right? We can't do it alone. We're only developing some tools for doing parts of this. So all of us have a role to play in the ecosystem and the value chain for machine learning. But there's three things we need to create that value in ML. Developers, workloads, and then working partnerships. It's not enough that we sell something on our own somewhere and try to get people to do machine learning. No, we have to integrate with silicon. We have to integrate with device OEMs. System engineers have to integrate us in robotic systems. System integrators need to install those robotic systems at the end customer. And eventually, somebody has to figure out how to provide value for the enterprise, because that's where the money is. So that whole value chain has to come together. And I'm going to explain how. Now, the value in this market is massive. I've been sitting on a number for the last 3 years. When we were first starting up Edge Impulse, we looked at what's the market size potential for AI in the enterprise. And it's big. $250 billion. And it's taken me 3 years to understand what this actually means. I've been thinking about this for 3 years. And the only emoji, my design people were kind of like, oh my God, he put a pot of gold on the side. The only emoji I could come up with was a pot of gold because it's such a massive amount of value. And that value isn't just AI for tools, that's everything. Silicon, devices, systems, AI engineering, tooling, cloud infrastructure, and the value that the enterprise itself finds from AI. The money saved, the money gained, where the technology is used. Now, recently, ABI came up with a new report that tiny ML SaaS platforms, that's what that Gimpulse does, will be a $1 billion market by 2030. So, $1 billion away from this market. I'll take that, thank you very much. $1 billion, we'll keep that. But that means there's $249 billion for all of the rest of you. I think that's a fair deal. So, what does that mean in practice? How do we unlock $249 billion? Now, this is a decade-long project, right? This is not going to happen overnight. $249 billion comes from the enterprise. So remember, these are small enterprises, medium-sized enterprises, large enterprises. Everybody is going to have to find that value in the end. And this is kind of a trickle-up, trickle-down economy, if you think about it this way, because this all starts with the developer. And this is where we have to connect this back to the developer every single time. We need developers who can generate useful machine learning AI workloads. Today, our developer ecosystem just hit 50,000 developers. And that's impressive, but it's not nearly enough. Because in the 3 years since we've existed, we've generated over 115,000 machine learning workloads. And that sounds impressive, but that might get us $5 billion out of that 249 if we keep on like this. We need 20x, maybe even 100x the number of workloads that we have here. Let's say 10 million plus workloads. We need probably 1 million developers in our ecosystem in order to get to this level of scale. And that's what drives Jan and I. How do we get to 1 million developers so we can go enable this whole thing to happen, this ecosystem? Now, those workloads are really important because the workloads drive the edge compute. All of those AI workloads, those useful things that we can do with machine learning on all different types of silicon, all different types of edge devices, drives the value through the enterprise and back down to this ecosystem. So I calculate that there's around $149 billion that will go to device OEMs, system manufacturers, infrastructure, system integration, all that work that's needed to go and develop the solutions that include AI. It's a lot of value that will go here. And eventually, that value will also make its way down to silicon. So a lot of us are from the silicon industry. We care a lot about how we see this. We often think about this bottoms up, right? Oh, silicon's going to be a $10 billion market and this. But where does that actually come from? Well, it comes from these device OEMs. So we expect $70 billion to come into AI-specific hardware in this space. But again, it won't without the workloads. So how do we go about scaling ML workloads? Well, that's what we spend a lot of our time thinking about. We've got several big initiatives to help us go even faster in this. We think about this as the challenge of scaling machine learnings at scale. So of course, our goal is to expand to 1 million developers. We've got an exciting announcement later that we're going to be making on one thing we're doing to achieve that. We've got to enable the community to share these workloads. It's not enough that we keep them all private, right? It sounds great that, oh, I developed these AI, I kept it to myself on my own laptop, but that's not going to help us teach a whole generation of people, help other people in our industry to succeed. We have to share. So we're launching a whole series of new features to make the sharing of entire ML workloads very, very easy. Share and clone, just like we do with GitHub. That's what's helped open source proliferate. We're going to do the same with machine learning. But not just workloads, the algorithms themselves. How do we get a new DSP feature extraction algorithm and use that on a specific piece of hardware that has a DSP part that's really good at this? How do we find that and use it? How do we share a pre-trained model? How do we share a transfer learning model? How do we share a new architecture across our ecosystem? We're figuring this out, and we're going to have more and more features to enable that. We also have to work with the data science folks because they have a lot of knowledge to share into our developer ecosystem. So we have a whole new initiative called Bring Your Own Model. Really deep Python SDK tools integrations with things like weights and biases for observability that will now be natively part of Edge Impulse. So you can go directly from data science tooling and go Edge Impulse, import Edge Impulse, pull model, Edge Impulse, push model, Edge Impulse, model performance on this type of silicon, Edge Impulse deploy model to this type of silicon, right from your command line, right from your notebook. And we think that'll be a game changer to kind of bring these two developer communities together. And then finally, we're thinking far ahead. We're not thinking just about, oh, how do we get developers using this today? What about the next generation? I've got my 14-year-old daughter here at Edge Impulse this year because I wanted her to see what I do and what we're doing, the really interesting work we do with AI. And that's about training that next generation with education, something I care deeply about. So this year, we launched a university program that's been very successful. So go to this, anybody that's involved with universities that cares about this technology, have them go to edgeimpulse.com/university. They can sign up for our free program. We provide free hardware, course curriculum that we've developed together with Harvard, and much, much more to help them get their students and their researchers using this technology. So we have already 300 universities active with this. We'll do another 500 next year. So this is how we scale ML workloads. And this is going to take 5 years, 10 years. It's a mission that we're on that's very long term. I want to talk more about machines, but first let's talk about something even more important, the health of humans. I think of this as one of the major challenges and major opportunities for us with machine learning technology, digital health. And there's a lot of challenges that we have. Pandemics are rising at a faster and faster rate. How do we respond to these in a faster and faster way? We've actually been involved with developing COVID-19 rapid response algorithms to detect onset of disease. In just months after the pandemic broke out, we were already developing algorithms for this with partners. How do we do more of that? How do we deal with an aging population? Elderly care is becoming a bigger and bigger problem. We need innovations to help us deal with independent living for elderly people. And then finally, healthcare costs are pretty out of control. For those of you that live here in the US, my wife went to ask a question at the hospital the other week, $8,000. Before insurance, of course, whatever that means. That's out of control, right? How do we use technology to improve the health of reduce the cost of healthcare in a way that lets us access the care we need and stay healthier? And these are all things that we believe digital health and machine learning can be a big part of. And there's several things coming together to make this happen. A few years ago, I would have said that health is not ready, right? The technology is not there, it's difficult, it's so highly regulated, but that's changing. We're going to hear a really interesting keynote today that's going to tell us more about this. Now, I believe this is actually going to be one of the fastest growing spaces in this market. New advances in MEMS sensors and this low power silicon that we're all producing, those are coming together in a big way. And that combination enabled us to do things like the Oura Ring. Really amazing piece of hardware, software engineering that can measure my sleep health for days on end. I don't even think about charging this thing until I'm like, oh, it's out of battery. Was that 5 days ago or a week ago I charged it? I barely remember. That's amazing. Years ago, that would not have been possible. We're then able to use biosensing, ECG, PPG, EEG, skin conductance, skin temperature, audio, how are you breathing, how are you talking, video, how are you behaving, is it normal for an elderly person, for example, normal behavior. We're able to combine all of these sensors together and use data, real data from the field, real data from clinical studies, to then approximate the algorithms that might cost tens of thousands of dollars in the laboratory. We can approximate those with a $150, $200 device on every human being, and that's game-changing. So let's talk some more about some really amazing companies that we're working with in this space. NoWatch, Dutch startup, using this technology to do really interesting things in mental well-being. So they're combining complex sensors that we haven't seen combined before. PPG, but also skin temperature, skin conductance, which enables us to measure cortisol. And if we can measure cortisol, we can understand the stress level of a human being. Combining that all together, we can get deeper into heart rate, blood oxygen, many, many more things. So what this does is it enables someone to wear a watch that doesn't tell you the time. NoWatch is called this because it doesn't actually have a time face. There's no digital interface. It's a crystal. There's 15 different crystal elements that you can put in that. And right away, my daughter was like, oh, that's cool. That's a good sign that this is going to take off. And instead, it concentrates on measuring your well-being, kind of like the Oura Ring doesn't vibrate or tell you anything. It just tells you every once in a while in your app, how are you doing? This is similar. So I think this is going to be really, really interesting for younger generations that don't want digital interruption. They want to know how they're doing, what's their mental well-being, how they minimize their stress level, maximize their performance. Another great example of where this technology is going is Know Labs, a company we've been working with to do the impossible, which is achieve non-invasive glucose monitoring. So Know Labs uses an RF scanning technology, and it's directly from Star Trek. When I saw what this thing does and how it works, it's amazing. It's a little device you put your wrist on. It emits very wideband RF energy, goes through your body tissue, comes back with extremely accurate antennas to measure the absorption of RF energy at different frequencies. And by analyzing this, you see some of what the data looks like here. By analyzing this, we are able to go deep and detect the concentration of specific molecules. In this case, glucose, but it could be anything else. It could be, did an elderly person take their medicine, for example? So this is game-changing. They call it bioradiofrequency identification, bio-RFID. 3 to 5 times less expensive than today's options, like continuous glucose monitors, which involve putting needles through your skin, and over 95% accurate, so more accurate than today's CGMs can achieve. So this will be really game-changing. And I'm going to show you a little video about what does it mean in practice when these guys go into clinical studies and start collecting data for their data sets.
Hi, I'm Steve, Chief Product Officer at Know Labs. Here's what's happening with our human trials in Seattle. First, participants learn about the technology. That's Tasha explaining the process. After entering the room, Nicole shows them how to do the test. She's a pro at this now. Then, they drink 35 milligrams of fast-acting glucose. We're using version 4 of the prototype sensor for the trials. We're currently building generation 1 of the portable KnowU product. It's progressing really well, and we'll be able to share more details once it's in our hands. Now, it's time to do some non-invasive measurements using the Know Labs sensor. Every 5 minutes, the participants just place their arms on the sensors for 60 seconds, and the sensor automatically takes its measurements. And just like that, there's the data. And now they can lift their arms or move around. We're using all of this data to refine the algorithm as we prepare for FDA trials. It's going to take time because breakthrough technology doesn't make itself. But the data science progress Phil shows me on almost a daily basis is amazing. We take a fingerstick reading as a reference with every non-invasive measurement. Seeing the invasive nature of traditional fingersticks up close and personal reminds me how important this work is. And not to mention, the amount of consumables needed. Whoa. As the human trials continue, we'll be collecting thousands of measurements, so the data science team has everything they need to get the algorithms production ready and even better than they are now. Since accuracy and stability are key metrics for an FDA approval, we're taking every step to make sure we get this right. We couldn't be more excited about what we're doing at Know Labs. We hope you enjoyed seeing what we're up to with our human trials in Seattle.
So if you're ever up to Seattle, you can actually participate in this study yourself. You can apply on their website to be in that bench, getting measured for glucose. David and our team is out in the demo area. He's done this himself. It's a lot of fun. Steve Kent, the Chief Product Officer of Know Labs, is here today. You want to track him down and talk to him more about the amazing work that they're doing and what does it mean to really scale up data collection for clinical studies. And that's really the big hook for machine learning and data infrastructure technology in this space, is that it's really hard to go from measuring one person to measuring tens or hundreds or thousands of people in clinical settings. Because when we're collecting data sets for humans, It's a little bit like when we collect data sets from machines. We have to hook up the laboratory with lots of measurement equipment, right? If you've ever been to a sleep study, I've been to a couple sleep studies, you get measured with tons of EEG sensors, ECG sensors, motion detectors, SpO2, and many more medical grade sensors attached to you. We have to collect all that data at the clinical level together with the cheaper sensor data, for example, these rings or the no-lab sensor or any other sensor that we want to measure. And we have to collect all that data together into a pipeline that's not operated by engineering nerds. These pipelines are operated by nurses in medical facilities. So how do we get a nurse to upload a very complex file into a system that can then get processed? And this is the type of thing we're setting up together with partners to make it easier to go from 1 to thousands of patients being measured. The other big challenge we have is that as we create these data sets, the algorithm process is really iterative. This is not just to collect a massive data set on health and all of a sudden you're magically producing an algorithm. Not at all. We have to start pretty small. Let's collect data from 10 people. Let's go derive what algorithms are useful, what derivatives of the sensors are useful, and then we'll go one step deeper, improve that. We might be missing some data, and then we can go to 100 people and then to 1,000. And eventually we get to the quality that we can use for things like FDA approvals. And this is true both on the consumer health side, so non-FDA, and the regulated FDA side of medical devices. So super interesting. The other thing we have to do is this feedback loop. It's not enough to just collect data in the laboratory. Once we get this data out in the field in real wearable devices, we have to be able to collect data back. And this is something we call active learning, which we're going to talk about more in Jan's keynote in the afternoon. How do we start with small amounts of data and then feedback from the field back into your data set and make use of that in real machine learning work? There's something else we're doing to accelerate this work as well. We produced a new reference design together with Nordic, Syntiant, and TestSolve to really show people end-to-end how to solve these types of health data algorithm problems. So accelerating human health from an entire infrastructure setup, so we show how to do this kind of clinical data collection at scale. We show how to use active learning to collect new data, reference data sets for things like ECG, PPG to HRV derivatives, so showing how the algorithms work in practice. And then finally, how to deploy it on real hardware. So this has a Nordic NRF53, multiple Syntiant NDP 101s, and then we can collect PPG, vibration, temperature, audio, all in the same form factor. So this is going to be available for all of our enterprise customers and get access to this, use it however they like. And we're going to do many more of these types of reference designs to get people started. We're not selling hardware. It's not our business, but we'll give this away to people that need it. And finally, I'm not the expert in health. I've learned a lot in the last 3 years working with customers. Later this morning, we're going to hear from Katelijn, who is the expert in this, the founder of Klue Health, that did diabetes management in a really interesting way using AI, and most recently an executive at Medtronic. We're going to have a really interesting deep dive into digital health. Now, what about the health of machines? We talked about this earlier. We saw this in robotics. It seems really interesting. But what about the rest of machines? And this gets me really excited because machines really do run our lives these days, right? We've got machinery in almost all systems that we touch. Industrial, buildings, healthcare facilities, you name it. There is machinery that's running everything that we do. How do we make sure those machines are operating efficiently? How do we run our industries more efficiently? And this is a quote from Gartner that really struck me. You know, we have some AI capabilities today, inference capabilities in some of our industrial equipment. But Gartner believes that pretty fast we're going to hit a 95% ratio, like we did in IoT when we went from 8-bit controllers to 32-bit controllers. That allowed us to do a lot more IoT in real hardware. Same thing's happening here. By 2025, 95% of industrial equipment will have not only analytics, but AI inference capabilities. Doesn't mean we're deploying there yet, because remember, if we don't generate the workloads, we don't have a market. So our job is to generate workloads with developers that fill up all this capacity and make use of it. IoT, when we designed it, had some design flaws. So I was part of the IoT, and we did some things wrong. We pushed all the analytics to the cloud. Mistake, because there's not much bandwidth from these IoT devices. So when you push all the data to the cloud, you've got this little tiny pipe, which means we sample the temperature every 10 minutes, and then we average it, and then we do other crazy things, which basically means we get like this very rough sampled data stream coming to the cloud. We don't know the context of what actually happened when this went on from any kind of trusted source. So we kind of end up with like a slow data log to kind of understand what's happening in the field. It's useful, but it's not nearly as useful if we could use all the sensor data. That's something else when we started at Gimpulse. We ran across a statistic that 99% of sensor data is discarded. We only use 1% today in IoT. How do we use the 99%? And the answer is machine learning and data. Because machine learning allows us to collect quality data sets right from the field. So the full data from the full sensor with knowledge of what's happening. Remember, we always need labeling. So expert knowledge that, okay, the machine broke at this time. Great, that's a label, we're going to use that. And then we can generate inference that runs right at the edge and it makes use of all the sensor bandwidth. There's no limit for us in how much sensor bandwidth we can use on device because it's massive reduction in data. We go from full sensor bandwidth to the machine broke. Right? That's the answer. That's very low bandwidth. We can send that over anything. Pigeons if we need to. Right? And so using this, we can translate this data to actionable insights, better efficiency, so much more in these industries. And that's what's got us excited about machinery, is that it's a direct fit for what we're doing with machine learning. Today we're announcing a new partnership in industrial that I think is going to be super, super game-changing. Together with Lexmark, we partnered to bring machine learning development very deeply into the Lexmark Optra Edge solution. And Optra Edge is a full software, hardware, AI deployment, device management solution, end-to-end, with actual physical compute devices is one of them. So this is the CX1000 quad-core ARM V8 processor. They've got versions with high-end NVIDIA GPU hardware as well. You can choose. These will be ready to go, integrated with Edge Impulse already built in a way that it can be deployed with a click of a button. You can collect data with a click of a button. We really ease the deployment of this stuff end to end. And there's an important reason for that. I showed you that value chain earlier, right? The value chain didn't stop at device OEMs. It's not that we enable machine learning for the people that make crazy, sophisticated devices like Aura. We actually have to integrate this all the way up to the enterprise level. And that's what Lexmark is doing. Lexmark is selling directly into manufacturing, logistics, healthcare, retail, for the end users. So we have to enable not only the super deep developers who are hacking up hardware, we've got to enable the end technical people, right? The folks that are in the field solving the problems. And we're doing that together with Lexmark. I'll show you a little video. One of the workloads that they've developed for factory use, so automatic quality control, testing what is in the SKUs of stuff that's coming after the manufacturing line. Did we forget a sticker? Did we forget a panel, right? Did we install something wrong? There's so many different SKUs in manufacturing these days. This is a major problem. So Lexmark's outside. You're going to hear more from a keynote soon. It's outside. Check out the demonstrations. And this is really changing the way we go all the way into the factory. But what does it take to do this? And this is just as complicated as it is in digital health. And maybe even more so because in machines, we tend to have a lack of data. So we talk to lots of German companies, and German companies are funny. They say, yeah, we make the best machine ever. Hubertus is laughing over here. We make the best machine ever. We're like, great, can we get some bad data? Some data from when your machines are breaking? They're like, no, our machines do not break. Ever, right? We're like, okay, this is going to be a bit of a problem. So we really often can only start with a little bit or even no data about what's good. We're never going to get bad data from these manufacturers. So we have to think of a new way to loop this process of creating algorithms. And this again comes back to active learning. That's why this is so important. We're able to produce anomaly detection algorithms now, like we did on the robot, with very small amounts of data, maybe just a few minutes, tens of minutes, maybe an hour of data. We start with that. We generate anomaly detection that's very simple. It just operates on good. It tells you when it's bad or different. And then we deploy that in the field and use this active learning feedback loop to collect the interesting data we've never seen before on device. Doesn't have to be connected in the internet all the time. We can do it on an SD card if we need to. But we feed that data back to the data set, and then we start generating more and more sophisticated algorithms with the engineering team. So this is a continuous process with the customer. And then again, once we're on device, we can start doing on-device calibration and learning to go tweak this for specific machines. So we can create a meta model, that's how I think of this. The meta model that's for that class of machine, we deploy it with the customer, and we tell the customer, great, when the machine's operating normally, you hit this button. We'll go collect some sample data of what normal is for this machine, tell us how long a cycle is. Is it 5 minutes, 1 minute to get through the whole thing that the machine does? And then we'll calibrate this thing for exactly what your machine is tuned to do. And I think this is going to be the solution that helps us scale in industries, across all industries, with machine learning. Again, for machine health, we produced a really interesting reference design together with Relock and Renesas. You'll be able to see this outside, for measuring all sorts of machines. And this is a piece of hardware that shows you how to make the ultimate machine health device. So we use current, motor current signature analysis included, vibration and audio in this device, together with a Renesas RA series MCU to go do this kind of active learning pipeline, do on-device calibration, and show the whole end-to-end solution. This is something, again, that will be available for getting started. If somebody needs to figure out a device or think about how to design a device, this is a great way to start. And we've got some amazing experts joining us soon on stage to talk about this. Brambles will be talking about applications for EdgeML in the supply chain. Samsung will be here talking about EdgeML in the smart home with empathy for AI. That's going to be really interesting. And then Lexmark will be talking more about the scaling of AI at the edge for the real industrial users in the afternoon. Now, it's not enough to go talk about scaling the AI workloads. We also have to think about what's happening with our silicon ecosystem. That's something we care very deeply about. Already today, we've done a lot with silicon. You probably noticed that we care deeply about scaling across all the hardware that our partners need. So we support the widest range of hardware ever in the AI industry, and we're only getting started. So if some of you are thinking like, oh my God, EdgeML is doing so much on different hardware, we're not even close to getting started yet. We're going to do this not across just the silicon, but across all the end devices, the OEM devices, the cameras, all the gadgets you can name that you can program AI in, we're going to support that hardware or find ways to support it. And silicon is only getting more interesting because it's enabling us to do more and more sophisticated things. So last year, we announced support for the Syntiant NDP100. And this was really a game changer. We used to stop with inference at kind of MCUs with MPU or with FPUs. So Cortex M4 class devices. And that's where we had to stop with sensor and audio applications. With Syntiant, we have specialized NPUs that let us go and do that all the way down at the ultra-low power level, 150 microwatts. So that was a game changer, but the industry hasn't stopped there. We're now optimizing for all the MCUs up the line. So we just announced support for Renesas RA series MCUs. With Infineon, we have support for PSoC 6 and soon the PSoC 63. With Synaptics, we've supported the first multi-core MCU that has both DSPs, NPUs, and MCU cores all working together so we can get low power with higher performance. So this lets us do things like image recognition at low power, first of its kind that we've supported. Syntiant then announced the NDP200. So this brings image recognition down to low power specialized NPU. So think about that as always on vision, right? If we wanted to understand, did somebody walk past this camera, we can use a part like this to do that and then wake up something bigger to do classification. Alif Semiconductor with us has released an entire series of ensemble products that are interesting because we're combining multi-core MCUs with multi-core MPUs, so Cortex-A, together with highly accelerated NPUs. So that's a whole family of different parts that lets us choose what we're looking for the higher end of things like video on MCUs. It's going to be really interesting with this part because it's fast enough. And finally, at the high end, we've just announced support with Renesas for the RZ series of parts. So this is highly accelerated Cortex-A. With Texas Instruments, we're working on the TD4VA, highly accelerated NPUs, GPU, multi-core ARM. So think about NVIDIA kind of class performance on very highly integrated SoCs. And then, of course, this Optra Edge type of hardware where we can have a whole range of hardware with different acceleration options that we can deploy on. So this enables us to do video applications, pose detection, behavioral analysis, and applications like that. And this seems really interesting, right? There's a lot happening here. Oh my God, we're only getting started. This is crazy, this industry, because in the last year, silicon IP has started to rise. And it's giving us a lot of new, very interesting options in what we're doing. Of course, we have the typical candidates. ARM has GPU components we can use for training machine learning. That's great. We've been already integrating NPUs from ARM and Cadence into parts like this. DSPs have already started to be used for machine learning. So we have support for the HiMax Synopsys-based Arc DSP. We're going to see a lot more DSPs used for this kind of thing. And just recently, we partnered with BrainChip to bring neuromorphic architectures into Edge Impulse for the first time. So now we have the support for specialized spiky neural networks that lets us go higher end. We can go higher end MCU, we can go into the MPU side, and we can do different types of workloads and training applications we weren't able to do before. So this gets really interesting with neuromorphic technology, maybe combined with other techniques in parallel. And like I said, we're only getting started. There's really interesting things happening here. Pollen AI is a new partner of ours, Pollen Technologies. They're doing configurable, programmable AI analog tooling. So designing chips with specialized AI processing in the analog domain on demand. So basically, you can design a workload, decide how it should work for audio, and you can tape it out and produce a chip at volume that does exactly that at low power. So this brings this kind of like super specialized AI all the way down to the very low power domain. That's mind-blowing. I don't even know what we're going to be able to do with that, but we'll find out. And then we have new, really interesting things like Think Silicon, who's here today. Think Silicon's combining very low power GPUs with NPUs at the same time. So for things like wearables with displays, we'll be able to integrate not only the graphics, but the inference capabilities all in the same form factor. This is getting interesting, and I think it's only going to get more interesting. And the reason is machine learning is developing all the time, too. We're seeing things like transformers hit this industry. And transformers are going to make our brains explode, where we have to figure out completely new architectures for dealing with the AI workloads that we're producing. So this is only getting started, and it's getting more interesting all the time. We have to help people scale workloads all the way through to the end customers. We talked about what we've done with Lexmark. We're now going to be doing that with everybody who's interested to bring machine learning down to their end customers. And this is what we call white label. Deeper integrations, putting Edge Impulse into your products and your systems, how you deploy firmware to the end devices, how you collect data. We're doing deep branded experiences. So this is an example of what the Lexmark portal for AI engineering looks like. It's very specified to how they're integrating with their end-to-end system. And then finally, this allows us to do private analytics. So what's happening with the boards that people are developing AI on specifically for one vendor. So we're here to enable everybody's ecosystem. We're not here to just have the Edge Impulse experience. This is something new that we're doing. And I want to talk about this with a special announcement. We've been working together with Arduino to bring this kind of technology to all the developers in the world. I want to welcome Massimo Banzi on stage with me. Welcome, Massimo.
Thank you.
Please go ahead and take a mic. Always amazing.
Is it on? Okay.
Amazing to have you here in
Thank you.
Mountain View with
It's great to be here.
You probably feel the same thing about the computer.
Oh, I love this place. I love this place. So I'm happy that you're organizing this event here. But I'm also happy about the fact that we now do this white label edition together. I think it's important. We use your technology. We love it. And so we're working with a lot of small and medium enterprises. And we wanted to bring these tools closer to them based on our hardware, but also based on our cloud platform. So this will be integrated into our cloud platform. So we have a special new sort of cloud platform for pro users, which is the one that's this kind of small and medium enterprises use the most. So, for example, in this special version, the people who are signed up to that, they get extra compute time. And so, yeah, we're trying to kind of, simplify this technology and bring it to a wider audience.
And I love the spin on SMEs, because that's a segment that we ourselves have trouble reaching. We can deal with individual developers or large enterprises or large enterprise partners, but it's hard for us to work with SMEs. There's lower volume, there's some kind of specialized help they need, and we're not able to provide it. So I'm really excited about this special Arduino Pro tier, where now you can give them the resources they need to go do ML. Tell me a little bit about what this looks like as an integrated experience. I know you and I and Jan, we all care about UX deeply. What does the Arduino machine learning UX look like when you go to the tools?
Well, basically, there's going to be a specialized website within our cloud that someone reaches. Essentially, they get the same functionality as your platform, but it is integrated in the overall experience of the Arduino website. And there's a number of further integration so this is kind of a pre-announcement. It's not available yet, but we are integrating the whole tools deeply into our cloud, so you can import data from the cloud into this tool. So it will become more and more integrated into the whole cloud experience that we give to customers.
And that means things like single sign-on with an Arduino account.
Totally,
yes. Deploying data to the data sets,
exactly.
Maybe deploying the firmware directly to a project. That's going to be amazing. It's extra work today that we have to do to put all this together.
But I think it's important as a tool to make it more available to a wider audience. So I'm really glad we're doing this.
Perfect.
Thank
you, Massimo, for joining us.
Thank you.
Thank you.
Bye-bye.
And finally, we have a special guest here that couldn't make it today in person. Simon Segars, the previous chief exec of ARM, longtime technologist, had to go to the UK this week, but he left us a special video welcome to Imagine.
Thanks, Zach, and hi, everyone. I'm sorry I can't be there in person, but I'm sure that Imagine will be an amazing event this year. As you've been describing, Zach, the ability to deploy sophisticated AI models on the tiniest devices sitting at the edge of the internet creates profound opportunities. At unbelievably low cost, we can now sense what is happening around us and use that to gain insight and drive decision-making in ways never previously possible. The use cases seem limitless, but crucially, this will allow us to use the Earth's precious resources in the most efficient ways possible. And that will enable us to increase both the quality and quantity of life, while in parallel, solving some of the toughest challenges facing society today. We have to feed and look after more people. We have to address health issues new and old, to rethink education and create an opportunity for everyone to participate. And we have to do all that while addressing climate change and driving down the environmental shadow cast by each of us. Now that's no small task, but I believe that an AI-enabled Internet of Things will help us do all of that, and that's where the opportunity lies. What enables all this is the innovation that is happening on so many fronts simultaneously. New semiconductor devices are emerging with amazing compute capabilities, all the time getting smaller, cheaper, more powerful, and more power efficient. Machine learning algorithms are evolving to exploit that underlying hardware in ways that create a virtuous circle of innovation. And with the deployment of 5G gaining steam, we are creating networks that can support the billions or even trillions of devices that will form this vast Internet of Things. Gone are the days of cellular networks where everything attached to them looks the same, i.e. a smartphone. 5G can support a vast range of devices with very different characteristics. Big ones that sample and stream a lot of data at high bandwidth. Small ones that perhaps just wake up once a day and only check in if some event has happened. And then everything in between. 5G enables these devices to coexist and operate in frequency bands appropriate for their power and bandwidth needs in public or private virtualized networks. It's a foundational technology. Already we see people using these capabilities in new and innovative ways. Wearable devices are starting to emerge that can tell what's going on inside your body just by monitoring the surface of your skin. This goes far beyond step counting and sleep tracking, as important as they are to our well-being, but to truly understanding your physiological state, providing an early warning system for people at risk at various issues, such as seizures, for example. These developments hold the potential to present a complete picture of your state of health to your physician, far beyond the basic instantaneous measurements of temperature, blood pressure, and weight that get taken on every visit to a GP. And as we rely more and more on machinery and electronic equipment in our daily lives, be it in the home or at work or while we're in transit, so too must we monitor and proactively maintain the infrastructure that has become so critical. We're all living through an accelerated shift to digital brought about by the pandemic, and there will undoubtedly be challenges along the way. However, this AI-enabled Internet of Things can ensure that the fabric on which we depend is reliable, safe, and secure. The kind of applications we're talking about need more, though, than just great chips and networks. They get brought to life by the imagination of developers realizing their ideas in software running on these incredible tiny computers. And that is what Edge Impulse is all about. I was drawn to Zach and Jan's vision of empowering developers, shortening the time to deploy an idea, and creating a platform that fuels innovation, very much aligned with how I've spent my career. Edge Impulse is also a community, a group of like-minded, technology-forward thinkers open to ideas and looking to make tomorrow better than yesterday and even better the day after. This event then is for you, and I hope that the collision of all this raw intellect will trigger new ideas, new thinking, and help drive everyone forwards. I can't wait to see what happens next, and thank you all for coming. Zach, back to you.
Next year, Simon's giving my speech. He's much better than I am. We have one more thing. As Simon mentioned, solving some of the world's most difficult problems is something dear to all of our hearts. We work really hard at Edge Impulse to invest in tech for good, as people, as engineers, as a company. And something we found really early on through our collaborations with Wild Labs and other conservation groups was that nature conservation is actually one of the biggest drivers of AI. There's a lot of pent-up demand to use AI to solve nature conservation problems. So for the last year, we've been investing in technology to make that happen in a much bigger way. So I'm really happy to announce a new product that we're bringing to market together with Conservation X Labs, a nonprofit based in the US that drives technology adoption into nature conservation groups around the world. And what we developed is the ultimate AI-powered camera for nature conservation, nature research, field research. Today, the researchers in this field use a Bushnell camera that costs $500 and stores images to an SD card. And then they'll camp out to the forest 6 months in to the African jungle, get this SD card in a little plastic pouch, and then trek it back out to see whether a poacher came by 6 months earlier. It's not all that useful. The industry's really struggled to bring AI in a form factor that's useful, so we thought, what the heck, why don't we work together to go solve this problem? We're smart engineers. And now we've done it. So this new camera is getting close to completion. You can see a really great build here. We'll have this out for display so everybody can see it. This camera is really unique in that we've used the latest silicon technology, the latest FOMO AI technology to bring 10-year battery life to a nature camera that sits out in the field in difficult conditions. Specialized Sony HDR sensors, so very low power image sensor for low light conditions. Fast trigger speeds, so under 500 milliseconds, industry standard for Bushnell type cameras. Full edge impulse support, not only for image classification and object detection on camera, but we're able to do machine learning on all of the sensors for triggering. So we can run machine learning for passive infrared, for vibration, and for audio. And this is all powered by Nordic silicon, by Sony silicon, by ST silicon, and developed together with our other conservation partners, Aribata, IRNAS, Q42. So we'll have more about this later, but this will be a Conservation X product. We're donating it to the nonprofit, and they'll be bringing this to market sometime next year. And finally, welcome to Imagine to the rest of today. This is for you. We've got amazing keynotes. We're going to have time for a coffee break. And the afternoon will be great networking, roundtables, lightning talks. Stick around for that. And then finally, the best keynotes come last. Jan's CTO keynote you do not want to miss. And now I want to welcome Sandeep up on stage, Vice President of IoT and Edge Solutions for Brambles. He's going to talk to us about Edge ML in the supply chain.
Thank you.
Thank you.
Oh. Good morning. Welcome to Imagine 2022. Today I'm going to talk about the Edge ML, how it is used in the supply chain logistics industry. First, I'm going to cover about my company, Brambles, give you a quick overview, who we are, what we do. Then I'm going to talk about, what are the problems in the industry, the supply chain logistics industry is facing, and how we are planning to use Edge ML. And lastly, I'm also going to cover a few other applications of where we are looking at areas of using Edge ML in our industry. So when we look at about supply chain logistics, people think about 3PL, third-party logistics firm. They think of trailers, trucks, but pallets are the least common denominator in our industry. They are moving from everything that needs to be shipped. So the interesting fact about pallets is once you see them, you will see them everywhere, and you will not unsee them. So I'm going to talk a little bit more about pallets today, and I will give you some insights about this industry, how it operates, what is the business model, some of the challenges. So nice blue stack of, I'm sorry. Grid button? Oh, sorry. Okay. Nice blue stack of pallets. So this is my industry, and that's what I was referring to. Like once you see them everywhere, and you will not unsee them. These are the least common denomination in the industry. So over to Brambles. Brambles is the worldwide leader in the pallet pooling solutions company. We specialize in the pooling of crates, containers, and pallets. And these are used to ship almost everything from heavy materials to automobile parts to produce. If you look at our business model, we ship pallets to whoever wants to move goods. Like these are manufacturers, retailers, these are producers. And they put the load, and the load moves in the supply chain. And once the load reaches the retailer, we collect the pallet back. CHEP, Commonwealth Handling Equipment Pool, is one of our most popular brands to which we ship these pallets. And Brambles has over 350 million pallets across worldwide. We have operations in 60 countries worldwide, and we have close to 800 service centers. The Brambles circular business model, which facilitates the share and reuse of our assets, makes our company very sustainable. And Barron's Magazine ranks Brambles as a worldwide leader in sustainability, and we are among the top 100 companies in the world for both sustainable companies. So I'm going to so I think pallets, as I was saying, is the invisible backbone of supply chain. There are about 5 billion pallets in the world, and I was reading an article in Bloomberg saying that if you stack them all up, you can potentially reach 2/3 to the moon. So this is this is unbelievable. I think they're close to as many humans. I think the number of 5 billion is still estimated. I believe there are more pallets than humans on Earth. So it's very interesting to see this industry. And if you can track pallets, what more can you do? What visibility you can bring to this industry? So So I'm going to talk about quickly some of the computer vision application in my industry. But before that, I want to talk more about what the problems are. Like, what are we trying to solve? What is the issues? As you can see, there are a lot of losses. There are leakages, there are breakages, there are damages. And the main reason is pallets have no IDs. They are just timber and nails. They are no serialized. I think once we ship the pallets to the first node, which is the manufacturer, we lose visibility. And that's why you see these pallets are being used for some of the applications which we are not so happy about. But you know, on the leftmost is one of the largest bonfires in Northern Ireland. It's a combination of blue pallets that belongs to CHEP or to us. And you know, they were pretty proud that that year they had like 288 pallets stacked up, and it's a world record event. But you know, this is what our challenges are in the industry. People make furniture, nice looking furniture, but we lose our pallets. And of course, there is always leakages in our industry. I think you know, since there is no way to track them, you know, people, you know, just use them for, or I would say for purpose which is not being, you know, contracted for. So, you know, there are a lot of other challenges. I think the lack of visibility in our business makes the cost of doing business with us more for our customers. What it means is, like, if I don't know where my pallets are, I would ask my customers for audits. I would ask them for declarations. Okay, what is your stock count? So all of this makes our business more like from a burden. I think it adds burden to us, to customers. So my vision is, how can we simplify this by adding visibility into our pallets? I think this will help us not only make our operations more efficient. I believe bringing visibility will also make our business models more effective. So I think let's just go to one of the things that we are working on. So one of the ideas we had is, if we can put simple barcodes on our pallets, and we can read our pallets when we are shipping to the first leg, which is the manufacturer, like from outbound perspective, we know who we are shipping our pallets to. And we can track them. And once we receive them back from the retailer, we can also see, okay, you know, the pallets are received. So I think what it does is, like, we know who we ship to, and we know when we collected them back. So once we have this information, that helps us understand our cycle time of the assets. That helps us in understanding where the damages are, in which particular vertical we are seeing a lot of these damages. That in fact helps us give more visibility to how to work with customers from pricing perspective and many more. Now, because we are getting visibility into our own asset pool, and that's one of the first things. So the effort we have here, it's publicly be announced that we are going to experiment this in a couple of countries. We are doing this in Norway and Chile. We are putting QR codes on our pallets, and we have forklifts equipped with machine vision systems. And you know, think of these like two headlights, so two cameras going into NVIDIA Jetsons, and you know, which looks for QR codes, and data goes into our cloud. So this is the system. But I think the key challenges in this system is what I want to talk about. But the key challenges is, this industry is not like, you know, similar. I think we have 800 service centers, which are all very different. We have connectivity issues. There are forklifts which are different. There are 2 times forklift. There are 3 times. There are 4 times, means like some forklifts can lift 20 pallets, some can lift 40 pallets, some can lift 60 pallets. So this lack of standardization makes this very challenging. As I was saying, you know, this, and a lot of times, like in some regions, we store pallets indoor. In some regions, we store pallets in the yard. Now, all of this combination makes it very challenging for my team, for the hardware team. How can we build a solution that is ruggedized, that is modular? How can we make something that is easily deployable, that has a very less maintenance cost? So these are some of the challenges, and that's what I'm here to talk about. Like, we are looking for technology partners if somebody can help us with these solutions. What my vision on the edge is a combination of capture, compute, and connectivity. So if we can integrate these three things into a box, I think that would help us getting more data sets around the world, I think, or around our service centers. So I'm looking for the future is to make a more integrated system. I want this to be very modular because I can place it wherever I want. I think if it is battery enabled, right now, the previous slide I showed was had the power which was drawn from the forklift. But if it is battery operated, we can put this device or this integrated system at many nodes and get the data from it. Ruggedization is very critical because, as I was saying, we have pallets which are stored in the back in our outdoor. So if there's these during loading conditions, there's rain, there is snow. So we need the vision system to be very ruggedized. And this industry is very cost sensitive. So we need to make something which is very cost efficient. I think we need to bring the overall system cost down on this. Now, in terms of some of the other applications we plan to use computer vision is in yard management. Safety is very important in our industry. It's the #1 thing. And we are looking at installing cameras beyond security cameras or CCTV cameras to gather more insights into our yard. Brambles has service centers which can go from 150,000 to 200,000. They are very busy. There is forklifts, there are trailers. We need vision system to help us or augment more security than what we have. And that's some of the things we are looking at. Traffic management, there are service centers which are in urban areas. So we want to manage our traffic of the incoming trailers. So if we have visibility into our yard, we can inform the trucks that, okay, what's the appropriate window they can come in. So that's another application of yard management or the cameras on the yards. We have pallets as I was saying, we store them in the yard. Through cameras, we want to have insights into our inventory of how many pallets we have at any given point. And of course, this application can help us from a delivery management perspective as well. The third use case that we are looking at computer vision is to augment our ADI machines which have laser. And Zach mentioned about robotics and how these machines or computer vision is augmenting. So we are also looking at how can we combine our ADI machines with vision systems. I think what helps, like once we receive the pallets, they are damaged. So we need to inspect them and send them to the appropriate sort lines. Does it need a human sort or human repair, or does it need robot? So when we combine these ADI machines with vision system, we can introduce recipe for that pallet as it goes through the robotic repair line. That's some of these things make our process very smart and also also reduce cost, because repair is one of the highest cost for us as an operating cost for us. So. Okay, a couple more applications which are very closer to my heart is on the sensor fusion. We have pallet trackers. These are cellular trackers that track the movement of pallet. Now, I think as the as I was listening to Zach and I was getting more ideas, okay, I can do a lot more with the sensor, and that's where I'm heading. How can I make use of the sensors and make this tracker more smart? I think some of the areas that where we are looking at is on motion characterization. So through motion characterization, we can get whether the pallet is on the forklift, if the pallet is on the trailer. I think all these insights are very useful in our industry. And not only for us, but for our customers. We can give these insights to our customers as well. This characterization of motion helps in cleaning our journey algorithms as well. I think what I mean by that is once the pallet tracker, the localization or the geo information we get from this is very patchy. I think it depends because they don't get GPS. So we look at many other methods of localizing the pallet. And sometimes the circular errors can be huge. So we are looking at ways like some of these through motion characterization, we can gather information whether it's indoor or outdoor, and that's what helps us in cleaning the journey algorithm as well. Some other areas are on the environmental sensing. Like if we can sense the environment, we can make the tracker more smart. Like how and when the data needs to be sent from a device, from a battery operated device. We are looking at introducing some low power edge ML models into the tracker for sensor fusion perspective. Think if my tracker can sense the noise level, combine it with other data set, it can generate more insights from our application or from what application we are trying to introduce to our customers. So these are some of the applications I wanted to touch on. I think one message I would say here is that my industry, we are looking at mostly the finished solution. We can't take the risk. You all can take the risk. So if you are working in this direction, if you are working to build products for supply chain logistics, I'm here and I would love to talk to you guys. So thank you very much. Thank you. Next is Hubertus, CTO of Balluff.
Thank you, Sandeep. Also, a warm welcome from my side, and I have the honor today to talk about an industrial perspective in machine learning on the edge. And before I get started, as he mentioned, I'm head of technology at Balluff, but who is Balluff? Who are we? 3,600 colleagues and what we are doing, and therefore a short intro of what Balluff is doing. So we are 100 years old, not me, and we are passionate about industrial automation. And we are doing sensors, we are doing network devices, industrial communication devices, and of course, we can make use of machine learning in a lot of applications. The first one I brought with me, automotive robots. Zach already talked about that example. We collaborated together with Edge Impulse, with Ready Robotics and our teams in order to get the demo up and running, and it's a vibration sensor on it. But we are also measuring the angle of the joints in such robots. So this is in the robotics industry. We support our customers in the battery assembly, which is, I would call it at the moment, a boom business. We are in energy, wind power. We do measure the variable pitch angle of the propeller blades in order to get the right setup for the right true airspeed. And we will hear about that a bit more soon. We are in the semiconductor industry, for example, measuring the edges of the wafer disks in order to have a centered one in the epitaxy process. So this is where we are. And in the industry, I think we need to tackle 3 challenges. First, we need to solve real-world problems. I think this is a term which is commonly known in the machine learning community. But we also need to decide whether to do the machine learning on the sensor, on the field, or on the edge, or in the cloud. And this is also an always ongoing discussion. And thirdly, we need to create value propositions that count for the customers, that we generate a value proposition where there is also a willingness to pay in the end for such a solution. But let's get started. Solving real-world problems. So I brought 2 examples with me, one from the milling industry, so machine tooling, and one from the automotive. But let's get started with metalworking. So in an industrial environment, like you see it on a picture, we will go into a milling machine, which you see here. And in a milling machine, there's a tool running. And the tool is running and making a job, and the question is how to detect the cutting wear. Because you would be interested in running such a tool if your tool is still okay. And of course, cutting wear, and you see here such a flank cutting in the aluminum, you would like, or you are interested in doing that in situ, so in the process. You can use optical methods, but you cannot use that in the process because you cannot simply see the edge while it is running in the aluminum. And that's the reason why we thought of, okay, how we could tackle that problem. And here you can see pictures, still optically, right? On the left top side, you see a brand new flank, which is doing good, of course. And then you see different stages of wear. And we took one of our sensors, by the way, it's the same that is mounted on the robot in the lobby. And this sensor measures the vibration data. And if you look at the vibration pattern, you can simply see, okay, what can you see? Not much with a bare eye. And this is the pattern of a new tool. And if you now look at the pattern of a worn tool, let's have the click, you see, okay, it's not that different. And this is the moment where we need to use machine learning algorithms to find out with the raw data, where is the difference? And this you can apply. And we made it that, for example, we can classify the information to train the algorithm in order to classify the vibration pattern to a dedicated worn stage. One solution. The second example I brought with me, if you look at this bodywork here in an elevator in an automotive production line, and you see the motor on the upper picture there in this white frame, it's a little piece of equipment in a whole automotive production, but if this one fails, the whole production is down. And you can imagine when, for example, at Ford, the production line is down, what is of the amount of money lost every minute. So it's important to understand what is the well-being of this piece of equipment. And there as well, we looked into the vibration data, and the upper pattern graph plot shows you the usual pattern. And you can see the different stages of this elevator. You have unloading, where the bodywork comes into the elevator. Then you have the lift section, you have the unload section, the sink section, and then it repeats. In the lower plot, you see, oh, there's an anomaly. For example, the first wave shows there is much more vibration difference. So there's something wrong. But you cannot specifically search in such a complex assembly and train the algorithm for specific to be classified cases. You need to detect anomaly. And this is an anomaly where you can say, okay, it's an alert, we should have a look on this motor. Or the second example, on the right-hand side, there is one complete sequence missing. So the bodywork was not unloaded. Also good to find that out. The second chapter is the discussion on premise versus cloud. And if you look at the pyramid of automation, you see here you can have different IoT stacks. So on the field level, you have the sensors, single piece sensors, ranging around 50 to 250 or 800 euros. Then you have the edge level, where you have these edge devices, and we already saw some cool edge devices today from Zach and the Opsha team. This is another one here shown, or let me say an IO link block for industrial protocols, typically. And you have the cloud level, where you have endless computing and processing power, endless storage, where you can do everything. But in the industry, that's not always possible. And there are differences. If we look at this picture, we're coming back to this milling example. On the left-hand side, the sketch shows this milling tool, if you can imagine. Then we have here the vibration sensor mounted, an edge device, and the cloud. That's the topology. If we can apply a machine learning algorithm on the sensor, and Zach elaborated on that one, you can make use of the raw data because you have the raw data available. You do not have to transport them through a narrowed bandwidth, tiny pipeline you called it. You have the full sensor data from a MEMS element, for example, and vibration data available. We found out that in this special use case, we can have the stage of one of this milling tool in a 99% accuracy. But if you are not willing to apply the machine learning algorithm because you need processing power, you need storage on the sensor because it makes the sensor itself expensive, more expensive, then you can also decide, okay, we go with these algorithms on edge level and having an edge device with a Linux system running with more processing power, more storage, also possible. But you have a reduction in accuracy because you do not have all the raw data available for your algorithms. And the same you can do on cloud-based. So you use the edge gateway only to collect the data from different sensors, because in some industrial applications you have tons of sensors, and you can make use of all the sensor data and then apply the data to the cloud and having there the computing power to calculate. The last chapter I want to address today is we need to create value propositions that count. And I brought one example. I talked about the wind energy with me to give you an idea which value proposition could count for such a customer. Houston, we do have a problem. I think it's not hard to imagine how costly such an unpredicted event could be. And this is exactly where you ultimately see there's a high value if you have a solution for your customer in order to prevent this unexpected downtime of such a wind energy plant. But if you want to create value propositions, you always need to start with a business model canvas. And you do not need to, in the first moment, not take so much care about the activities, resources, channels, value streams, cost structures. The first thing you always need to do is to understand the customer's problem, and in order to fit that to your value proposition. And pointing these two elements out, customer segment and value proposition, apply that one on our 3 examples we just discussed. The pitch propeller, here you can see, okay, on the right-hand side, the customer, and the customer's job is to operate these wind energy plants. And a gain creator would be if there is no failure over years, of course. And the pain, you see the tons of helicopters, and you can imagine these emergency missions are very expensive. So if you now have a value proposition applying machine learning, anomaly detection over sensor data to prevent such downtimes, of course, you have a high value. And of course, it's not an issue to apply your machine learning stuff in the cloud, having connections at gateways, all the stuff. Price is not an issue here, perhaps, or more. Second example, the bodywork. Here we have a lot of sensors in such assembly lines, and also looking into the business model canvas in these 2 topics, you see, okay, a big pain is in-line downtime, and you can apply an edge gateway in order to have anomaly detection and early warnings. And the third example we already discussed was the milling tool, also there. But what you see here, you have a machine running, and it's a real-time problem. You need to make decisions and warnings with low latency, making use of all the raw data on high resolution. So here it is perhaps wiser to apply the machine learning algorithms on the sensor to be fast in the field and real-time decision making. When we put this all together, then we see, okay, on a field level, the cost may be low, but of course you need trained algorithms deployed on a sensor. You might send your algorithm, your machine learning algorithm, into a boot camp in the cloud to make him fit for detecting and make him even better, train him even more. You can apply on edge level, but you need to invest more. Or you can have the full IoT stack running until the cloud level in order to have the full computing power. And I think the summary is that not one size fits all. That's the key takeaway for me. If we sum everything up, we need to solve real-world problems. Therefore, we need domain know-how. We need to decide on-premise versus cloud. This depends on the solution. And we need to create value propositions that count. That means we need to understand the customer's job, and we need to design our value proposition for the customer. So, summing all up, I would say, know your problem, have great partners, and build your industrial-grade solutions. Thank you. I'm available for questions during the coffee break, and now I would like to hand over to Mark, giving us some smart things.
Thank you, Hubertus. Thank you. Oh, I love that. Thank you, Hubertus. System of systems and those layers that you talked about. Hello, my name is Mark Benson. I'm so happy to be here. We have such a great lineup of speakers here today, and I'm honored to be here with you. Standing here at the Computer History Museum is a beautiful reminder of all the ways that technology has really changed the world. But for every product that has changed the world, there are many thousands that didn't, that aren't here. Products that failed or perhaps didn't reach their full potential. And there are so many reasons why a product can fail. Perhaps the feature mix wasn't quite right, or perhaps the cost didn't hit the right cost point, or perhaps the market wasn't ready, or the timing wasn't right. There are so many reasons that products can fail. And today, as we're talking about all the exciting ways that we can leverage technology to solve real problems in the world, I want to make sure that we remember that there's something that we may not be talking enough about, which is empathy. So I want to talk today about empathy. Now, we're in a tech conference talking about feelings. I hope that's okay to do that for a bit. But if the user isn't in the room when we're talking about it, what are we doing? So what is empathy? Empathy is really that ability to understand and take on the perspective of another person, or to see something from someone else's point of view. And I think we can all probably know when we've just had an interaction where someone has been treating us empathetically. We usually feel valued, we feel heard, we feel that our time is worthwhile. And by contrast, sometimes a sympathetic interaction might leave us feel like it was a cold transaction, or we might have felt pitied, or that our time actually wasn't valuable. If I have a friend that comes over to my house and they talk to me about things that are going on in their life that are very hard for them, a sympathetic response, really might be, well, at least you have a great job and you have friends. But an empathetic response makes such a big difference to say, wow, thank you for telling me that. That's really hard. I can only imagine what you're going through. Tell me more. It really does make a difference. But here's the thing about empathy, is that in order to connect with another person empathetically, we have to connect with something deep inside ourselves that knows that same feeling, or can imagine what that feeling is like. It's not just understanding and listening, it also requires introspection. Now, the same is true with product design. If we think about empathetic product design, if we're gonna really connect the products we make with the users that they're for, we have to not only understand what is going on in the context, what they're doing, what the business problem may be, but we have to connect that with something deep inside that knows what that's like. Or if we don't know, and we don't have that empathy, we need to find it. We need to find out what is the problem that the user is facing, what is that context that they have. And it's so easy to miss the mark in this. We may be distracted. We may have a new, exciting technology that we're very excited to work on and implement, but we're not remembering what the user really cares about. It's possible that there's misalignment in the organization. You may have a single product designer that has a great empathetic product idea, but if the engineering team and the developers don't also understand what's going on with the user, that project is in jeopardy of perhaps not missing the mark. And I'm sure many of you have seen all kinds of cartoons or illustrations where a product idea gets transferred through the game of telephone, and at the end, the product doesn't meet at all what the user needs. It's so important to have alignment within the team about what's going on with the user and to have that empathy. And for products that have a life use and are used far beyond when they're first installed, there's also an empathetic follow-through that's required. Or if you're building a machine that needs to learn and adapt over time, it needs to live and to breathe and understand how that context may change. And in the world of the smart home, being able to adapt to what users need, it's changing very, very quickly. At SmartThings, we have empathy as a core expectation of our leaders. So we practice empathy every day in how we manage internally at SmartThings. And it turns out to be a great leadership style as well. We also, for all new employees that work at SmartThings, we give them smart home kits and we expect them to use them. We want our employees to not only just hear about what it's like to have a smart home, but actually to feel it and to know it and know what that's like. And that's true for executives, for product managers, for legal, finance, or people who manage our offices. Everybody in the company knows what it's like and to feel what it's like to have a smart home. And it makes all the difference. So if our job in the smart home is to really get in the mind of the user and to have that kind of empathy that I'm talking about, over the last 2.5 years, what users care about has really changed. In the last 2.5 years, people are reimagining their homes. Reimagining their homes perhaps as they originally intended, as places of rest and relaxation and safety, but also more recently as places of work and exercise. We're spending a lot more time in our homes, and we're thinking about how we can improve our homes. You may have seen statistics about remodeling and people who are doing improvement jobs in their homes. It's been going through the roof over the last 2.5 years. But also, as people have been doing that, the level of interest in the smart home has really risen significantly. Today, 80% of American homes now have at least one smart device in them. That's a massive number. Now with that, the demographics have also been shifting. We're seeing, as this has grown, a higher interest from women. We're seeing a lower average household income, an increased interest from renters, and also diversity metrics that are approaching that of the general population. And within those users, 74% of them started their journey with just a single device. So if we think about a really sophisticated smart home, almost nobody starts that way. Very few people start with a master plan of the dozens or 100 devices that they might put in their home. They start with one device. And it's lights, locks, doorbells, thermostats, cameras. They start with one, then they get two, then they get four, and pretty soon interoperability between those devices becomes a significant concern. But perhaps the most astonishing statistic of all is that 50% of smart device owners started their journey in just the last 3 years. So just the last 3 years, that's essentially the start of the pandemic that has happened. So 50% of smart device users have really started that journey just very recently. So this is really exciting growth in the space, but it's really not all roses. There are significant challenges. If you've set up a smart home, there can be times that it's not as easy as you might think. Setting up a smart device can be challenging. Understanding how it interoperates or doesn't interoperate with other devices in your home is hard to understand. And for many, maintaining a smart home, a growing smart home, and solving problems over time or fixing issues that happen is new territory. And I'm sorry if this is news for you, but what consumers care about is not the technology itself. They care about what it can do for them. They care about why it matters in their lives. Users want things like peace of mind. They want to know that the house is locked and that the garage door is closed when they leave. They want their home to be convenient. They want to be able to set the thermostat from the couch. They want savings. They want to turn the lights off when no one's in the room. And they want to be entertained. They want to set the mood just right when they have a party at their house or when they're watching a movie. But one of the biggest barriers to mass market adoption of the smart home is complexity. It's the boring stuff. It's the basic stuff. It's the first step. It's the first step of setting up your first device. It's understanding interoperability, and it's maintaining that home over time. This is the biggest barrier to mass adoption. So what I want to share with you next is 3 ways that in the smart home space that empathetic innovation is happening. And the first one is with a new industry standard called Matter. Some of you have heard about this, but Matter is a smart home standard. SmartThings is proud to be a founding member of the Connectivity Standards Alliance, which is responsible for forming Matter, which is comprised of hundreds of companies that are interested in making smart home devices more interoperable. Matter will be launching this year, and we'll start seeing products come into the market late this year and early next year. Matter devices are compatible by design. If you think about as a consumer, you go to the store, you buy a device, is that going to work with devices I already have? Matter devices are compatible by design, which means if you buy a Matter device, you can have high confidence that that will work with all of your other devices that you have in your home. This leads to lower returns for retailers. It leads to less frustration for consumers. And it leads to increased freedom of choice for users, which is great. Matter was also catalyzed by user demand, so the industry really led. Sometimes you need to innovate with the product experience itself, and sometimes the entire industry needs to come together to raise the level of interoperability, and that's what's happening with Matter. And all of this enables a higher level of innovation for brands that are creating devices that need to work in the smart home. They can spend less of their time worrying about the setup and how which ecosystems that device works with, and they can instead focus their energy on innovative new features that really matter to the user. So it changes where competition happens, it changes where differentiated features happen because this interoperability layer is there. So that's the second one I want to tell you about, which is empathetic product design. Now, empathetic product design, I mentioned before what consumers want with peace of mind. Well, if the product isn't resilient or trusting or operates gracefully when the internet connection is down, that doesn't really bring very much peace of mind. The product needs to be convenient. It needs to be easy to use. For anyone who's designed a product, it is extremely easy to design a complicated product. And it's really complicated to design something that's easy to understand, natural, something that just speaks for itself. That's what users want. They want ease of use and convenience. Savings, if the device is not able to be customized or tailored or adapt and learn to the behavior within a home, you're not going to achieve the same level of savings or have it be available to as wide of an audience if it were otherwise. And entertainment, I talked about that before. With interoperability between devices and personalization, that's critical. SmartThings recently just announced a new expanded partnership with Philips Hue so that Galaxy devices can interoperate with Philips Hue to create immersive music and lighting experiences in the home, all from your Galaxy device. Our users love this. Last year, SmartThings introduced a new product. It's a new technology that's called SmartThings Edge. And SmartThings Edge is a hub architecture that runs locally in the home that allows device interactions and automations to be able to be run locally in the home, regardless of whether there's an internet connection or not. This leads to higher reliability, higher responsiveness where interactions are quick with low latency when it's right in the home, and also the personalization and customization that users have with their SmartThings system can run locally for them right in the home, nearest to where they are. Samsung last year also announced what you see in the picture here, which is a JetBot AI Plus robot vacuum cleaner. This robot vacuum cleaner has AI built in and is customizable, it adapts, it learns, and it cleans your home. Now, this product has market-leading object detection, recognition algorithms that are built into it, where it can avoid certain objects in the house or identify even breakable objects or pets and navigate around it. It also has autonomous operations, so it can do its thing on its own without manual supervision. And it also can have personalized cleaning schedules, so it can adapt and clean at the time that's right and be personalized to the home that it's in. Now, SmartThings also released around that same time the SmartThings Pet Care service. And the SmartThings Pet Care service lets you check in on your beloved pet while you're away, or trigger another device to feed your pet that's there. This is something when we talk about empathy, these are things that users really care about. You know, they don't wake up dreaming about how to onboard an IoT device or what interoperability might be there or what technology is in there. They care about their pets. They care about their cats. I don't personally like cats. We have dogs, but they care about their pets. These are things that users care about. And perhaps, you know, not the most sexy statement I will say, but this device also has pet excrement detection. So it can look for pet messes, identify them, avoid them, and avoid any sort of unnecessary spreading or secondary contamination. And it's funny when you think about it, but if we're talking about empathy, this matters. This really matters when you use a device like this. These are not the kind of user needs that you can understand passively, things that you can just look at the market data and say, oh, I think we should design a product that generally fits this market. If you don't really get into the mind of the user and what is happening in a home in the context of when a device like this is used, you may miss these sorts of things. So with a solid foundation of interoperability and great product design, this enables really what users truly care about, which is empathetic experiences. So empathetic experiences in the home, there are all kinds of things that happen. People are coming and going, they're studying, cooking, eating, sleeping, being entertained, having guests over, reading, having quiet time. All of these things happen in a home. And within the smart home, sometimes users want things that just do things for them. A robot vacuum cleaner that cleans the floor. That's great. Sometimes it's assisting, having something in the kitchen that can help with cooking, identifying new recipes, ordering groceries. Or monitoring, remotely monitoring things like safety and security around the home or with pets, entertaining, or sometimes just disappearing. Sometimes disappearing so that users can just focus on the things they care about, connecting with their kids, with friends that come over, or just having some me time. SmartThings is 10 years old this year. This is the 10-year anniversary of SmartThings. It started as a Kickstarter campaign and was acquired by Samsung 8 years ago. And since that time, SmartThings has put together empathetic experiences that really matter to users. We've done SmartThings cooking, there's SmartThings energy, SmartThings home care, SmartThings clothing care, which you can see you can schedule when the laundry will be done, for example, air care, and also pet care and more. These are things that have happened just in the last few years. Empathy in product design doesn't just happen. It requires leadership. If your organization wants different outcomes and to be thinking about empathy differently, it requires leadership. It requires you to step up and to talk about it, to put the customer in the room with every conversation that you're in, to think about not just what is the technology in front of us or what's the business conditions we're dealing with, but what is the user facing? What is the business problem that needs to be solved? That needs to be in every conversation. It requires leadership. It requires alignment. I mentioned this before with up, down, and across the organization. If there's parts of the organization that just don't understand what the user is needing, it can lead to misalignment. Having partners that also think empathetically is super important, and having technology that you can encode that empathy into the product and be able to have the product live and breathe and adapt is super important. At SmartThings, we have empathy, as I mentioned, as a core leadership principle that we expect of all of our leaders. And if they're not good at empathy, you can get better at empathy. And if you really just can't do it, there are mechanisms of empathy you can put in place that force you to get insight from people that you're leading. We also encode empathy in our product management processes. I mentioned alignment with giving smart home setups to every new employee that we have. We've instrumented empathy in how we orchestrate our community of developers within the ecosystem so that we can tap into the knowledge that they have about what's going on with users. We have empathy encoded in our processes, how we think about what consumers are saying through voice of customer data, through operational metrics. And we're also contributing to industry or to university research on empathetic AI. So there will be some work that will be published soon by Dr. Scott Nelson and Dr. Anant Mishra from the University of Minnesota in the coming months on empathetic AI, and SmartThings is honored to be part of that research. As we think about empathy, I really believe that as we look forward over the next 10 years, empathy and empathetic product design will really separate the good companies from the great companies. And the products that we will be talking about, the ones that really change the world, will be ones that had really empathy at their core. Thank you so much.
Okay, thank you so much. Great speakers. Hi, everyone. I'm Alessandro Grande, Head of Product at Edge Impulse, and I'm your host for today. I'm really excited by the first speakers that we had. Some really great announcements from Zach that we heard in the morning, and then some of our partners talking about how they really use the technology that we're building to actually add value to businesses and transform industries. And super excited. We're going to have more of that after the break. So now we're going to a 15-minute break. But before that, I just wanted to tell you a bit of what's coming up next. So we have an inspiring panel around wildlife conservation and social impact, followed by two great talks, one on digital health and the next one on industrial automation. So make sure to tune in 15 minutes. Now, coffee is ready, so let's all go get some coffee. Ladies and gentlemen, the program starts in 5 minutes. Ladies and gentlemen, 2 minutes to the start of the show. Ladies and gentlemen, 1 minute to the start of the show. Please take your seats. Welcome back. Welcome back, everyone. It was a short break, but I hope you re-energized, and we're excited for this next section. I'm really excited, actually, for this specific panel. We're having a big impact, as we discussed, but we're having a potentially even bigger impact, social impact in the world. And I'm really excited about this panel and to hear from the speakers here. So to introduce the panel, I want to call on stage Adam Benson, CXO of Edge Impulse. Welcome on stage.
Thanks, Alessandro. Hi, everyone. Good to see everybody here. I think 1/3 of the audience or so, maybe more even. So I'm Adam. I work for Edge Impulse. I'm in marketing. And before I introduce this panel, I want to let you know something about the company, that this is an impact panel and conservation panel. And it's really dear to Edge Impulse and really core to our culture. This company was founded not only on the principles of doing great things in the enterprise, solving automation problems, also about doing good in the world. And this panel is a group of people I've worked with for years on all sorts of really interesting projects. The panel will be led by Stephanie O'Donnell from Wild Labs. And I don't know why I'm losing my breath. I ran into the stage, old age. And yeah, and we're doing a lot of cool stuff, like giving a portion of our revenue to One for the Planet, these Lineards, giving income to an organization called Kids Positive for people who suffer from HIV, and all sorts of amazing things like helping build elephant trackers, camera traps for nature observability, and a lot of cool other stuff. So I'm not going to catch my breath. I'm still breathing from it. So Stephanie from Wild Labs, please come to the stage. Thank you and enjoy.
Thank you. Hi, everyone. I'm here today to introduce our panel, but before we get started, I just want to set the scene by talking a little bit about the role technology plays in conservation in our world. So every year, to celebrate World Wildlife Day, which is on March 3, we ask members of our community all around the world to take a photo of how they're using tech in the wild and share it with the hashtag Tech for Wildlife. And we get hundreds and hundreds of photos and stories about how people in our community are using technology. Everything from Blair Costello using a little robot cheetah, one of my personal favorites. She's built this to monitor predator responses in gazelle. She's also built a little monkey bot sidekick as well. And she finds that the predators run away from the cheetah bot, but not from the monkey bot. We have Andrew, who's working with critically endangered kakapo in New Zealand, and there are only 252 birds left, kakapo individuals left, and he uses a huge range of technology to monitor each and every bird and every egg that's laid, trying to bring this species back from the brink. We have Duke Marine Lab, who's working down in Antarctica using hydrophones, tags like this tag on the back of this humpback whale they've just put on, they've just attached to the whale and recorded with a drone. And they're exploring the lives of minke whales and humpback whales down in Antarctica. And we have Alyssa, who's putting tracking tags on polar bears. And in this post, she talks about the fact that you can only put a collar on a female bear because if you put the male bears, the neck is bigger than the head, so the collars just slide off. So they've had to develop ear tags, and they're now looking for less and less invasive methods of tracking animals. So they've been working on this burr tag that just attaches to their fur and drops off. And we have members in Brazil monitoring turtles and using drones and ML to try and count species and monitor the animals. We also have a lot of members starting to share how technology is not working for them and the challenging situations in which we need tech to perform. Elizabeth shows the destructive tendencies of elephants, particularly towards camera traps. Adria has shared this beautiful photo of a bat and the tiny tag that he's using to track this animal in Kenya. And Claire's shared her work, which she calls astroecology, because she's taking methods from the astronomy, not astrology. From astronomy, the radio astronomers are using to find new stars and using it to process imagery to track, to mitigate poaching and track endangered species. Now, this is just a tiny snapshot of all the projects and all the ways technology is being used in our community. And if you're curious, it exists and it's out there, and you can go and just a quick entryway, go and explore our Tech for Wildlife feed or the Tech for Wildlife hashtag on Twitter if you're curious. But one of the things we've seen, we've been running this photo challenge for 7 years now. This last week was our 7th year. And we've found it, initially we just launched it as just a celebration within our community, just trying to get everyone to talk to each other and share what they're working on, because our community is, a few years ago, was just quite disparate, and it's really hard to discover who's doing what and how are we using tech. So the photo challenge has been an amazing way to bring people together, but we've also seen it start to track trends in how tech is being used in our world. And more, one of the biggest trends we're seeing is the role that ML is playing in wildlife conservation. We've gone from a situation where we've been in, it's been incredibly difficult for us to gather data. And now that we have lower cost sensors, we're able to actually get the data about how animals are moving, what's happening in our ecosystems. The challenge now becomes, how do we process that data? How do we make sense and respond to it? And ML is playing an increasingly important role. Over on the left, you can see the Bear ID project. And I'll just mention them quickly because Ed, I can see, is sitting down here and is one of, if you're interested in how ML is being applied to identify individual bears, go chat to Ed because it's one of the coolest projects. And they've been really at the forefront of ML in conservation. But yeah, what we're seeing, this is just from this year, is like 5 years ago, there wouldn't have been a project that would have mentioned ML in their work. And this year, there were dozens. So I guess the main point is that this is something, like in all industries, machine learning is becoming increasingly important for conservationists. There's so many opportunities and so many ways in which we need help to build algorithms and get actionable insights from our data. And this is like, I'm about to bring up our panel, but I just wanted to mention first, this is backed by the data from our conservation community. We just published a State of Conservation Technology report where we asked our global community of conservationists around the world how tech is working for them and what opportunities and what challenges they're facing. And of current tools, ML computer vision was at the top of the list for what technologies our community is seeing is going to have a huge impact for conservation. I'll also note that it's quite far down the list of what is currently performing very well for us. So there's a big, big opportunity to improve applications in our world. So my main message today is that tech has a fundamental role in wildlife conservation and has done for many, many years. But there is huge opportunity, and there is a really big role for particularly the tech industry and engineers and anyone who's interested in trying to use your skills and knowledge for good and for other applications that could have a real impact to the world. There's a real role for you to play, and we need your help. One of the ways you can come and find projects and find ways of helping is to join Wild Labs, which is our global community for conservation technology. We have 6,500 members around the world, and You've just got a snapshot of just a few of the projects in our community. So yeah, I think I'm going to leave it with the really strong call to action that we need your help, and there is a role for all of you. And if you're interested in finding out what that might be, we're going to delve into it in this panel, but we'll also be hosting a roundtable later on and have space for more conversations, because a panel is only going to allow us to get very, very, just scratching the surface of our sector. So with that, I'm going to ask the rest of our panel to come and join me on the stage, and we're going to do a couple of quick introductions of what everyone's doing and then get into our discussion. All right, Fran, you're going to be, you are up first. Do you want to tell us a bit about your work?
I will. So hello, everybody. It's very nice to be here. I think for many of us, this is the first time that we've been in a socially non-distanced room and with speaking to the public in a public forum, so a little bit nervous, so excuse me. But my role is in a sustainability function at ARM, and I lead social impact and innovation, and that means connecting our business capabilities to our societal responsibilities for inclusive innovation. And if what I've just said just sounds like a bunch of words, what it means is that we're trying to extend the benefits of technology to people in areas that don't currently have tech products and services designed for them. And the way that we do this is in multiple different ways. It might be through insights, so understanding the needs of people and planet, through partnerships with social entrepreneurs, all the way up through to global players, and through developing a network and a community of social impact ecosystems. And my role is really about this that you see on the slide now, which is innovating even for the hardest to reach. So the how we do it is through emergency response. So if there's a situation that calls on business to respond, through tech for good applications. So that might be existing technologies used in a real world context right now. And then at the other end of the spectrum, it's through systems level change. So looking at root cause issues, and those situations are usually multi-stakeholder partnerships, usually longer lead times, and usually significantly harder to deal with, frankly. And we were asked to share our whys and why we respond to these kinds of issues. And I think that for me, it's that I deeply believe in the role of business in contributing to some of the solutions that some of the issues that we're seeing in the world. So I think that we need to always start with what the world needs rather than what we think the world needs or what we might want to be doing. So what the world actually needs. And so my why is inspired by some of the global frameworks that you can see on the slides in front of you. So starting on the left is the planetary boundaries concept developed by the Stockholm Resilience Centre, which shows the 9 planetary boundaries that is the safe operating limits of society. Next to that, you've got donut economics from Kate Raworth, the economist, which layers the planetary boundaries with social boundaries. So the internationally agreed social minimum standards of energy, food security, water, and so on, as set out in the Sustainable Development Goals, which is the third circle that you see there. And that is 17 interconnected global goals aimed at ending poverty, fighting inequality, and urgently addressing the climate crisis, as outlined by the UN, so agreed to by all 193 member states of the UN in 2015 as the world's largest to-do list. And the one next to that is a pyramid version of those same goals. And I think that's interesting because the thing that we need to maintain, or the thing that we need to recognize, is that businesses don't exist in a vacuum. We exist in society, we exist in an industry, we exist on a planet. And if we don't maintain our biosphere integrity, if we don't maintain our social foundations, we can't have economic success. I just got cut out, did someone disagree with me? And so I think that there's a huge role to play for the tech industry and for advanced technologies in addressing some of these biggest challenges that we're facing for people and planet. And to finish, before I pass on, is that the planet Earth is a self-regulating system. It will either just be a big rock without us, so what we do next determines whether humanity continues to exist and we maintain life on Earth. So with that, I will hand over to Kate.
Thank you, Fran. Hi, everyone. I am Kate Kallot, and I'm one of the co-founders at Mara. We are an African blockchain startup, but I'm also the president of Mara Foundation, which is a nonprofit dedicated to accelerating technology capacity building across Africa. We have big goals, big ambitions to train about 1 million developers to impact 1 billion lives over the next 5 years. Zach mentioned in his keynote that developers are key to the machine learning ecosystem. And that's especially true when you look at the machine learning ecosystem in Africa, because the AI innovation in Africa is a grassroots, a bottom-up innovation that's driven out of developers, startups. They will learn through boot camps, hackathons, congregate with each other and build solutions. So for us, this is why we have a mandate as a nonprofit to focus on training developers. Now, developers in Africa, they actually use the technology we build here and apply it to the most innovative and complicated challenges. So on the slide here, you have one of my developer relations engineers, Clinton. We were in the bush for the past 10 days, actually. We deployed a few camera traps using the OpenMV cam. Our model was trained with Edge Impulse, and the camera traps were destroyed. What you see on the green here, it's a damaged camera trap that was damaged over like less than 2 days. And next to that, you see a lion pound, a giant lion pound. And the next day when we went to pick up those camera traps, we actually saw a family of elephants. So I'm not sure whether it's lions or elephants which damaged the camera traps, but that happened. So really the way we're trying to help developers is to focus them on the right challenges. They are super innovative. They have now access to tools and opportunities, but we're really trying to help them, orient them towards building the right solutions for the right challenges. And how we do that is by exposing them. Again, we run, for the past 10 days, we were in the Masai Mara in the field. We run a hackathon for last mile payment for Maasai communities. So we exposed those developers to the communities. We got them to meet with Maasai to understand what are the challenges that they were facing. And some of those challenges, which started with last mile payment, ended up with developers innovating around human and wildlife conflicts. So there's a lot of things for these developers to learn the moment they get exposed firsthand to the problem statement. And then the why we're doing this, it's because, well, it's going to take a village for us to drive real innovation from the ground up. I moved to Nairobi earlier this year from New York City because I realized that I would not drive real innovation on the ground in Africa by sitting in my flat in New York. So that's why I took a leap of faith and decided to move to Africa and really enable those developers, connect them to the ecosystem here, give them visibilities, opportunities, the platforms, and the tools that they need to solve these challenges and build solutions for the communities around them.
Yeah, thank you. I'm Tim van Dam from SmartParks, co-founder and director. And yeah, what we do is we protect wildlife with what we say passion and technology. So I think I can speak for all of us, but it comes from a true passion to work in this industry. I don't like to call it an industry, but it is. And it comes really from passion. So for me, it comes from going to Africa for 25 years, seeing these animals and seeing the decline in wildlife. And if you look at the numbers for the past, I think 50 years, half of the mammals, fish, and birds, they all disappeared. So we're really in a bad shape. And over the years, it struck me that I need to act on this. So working in technology, at some point I said, okay, what can I do? So that was the start of SmartParks. So it's good to understand that we all work from a very passionate background. So what we do from SmartParks, we develop and deploy sensor networks, wireless sensor networks in protected areas. So we started in Africa, but more and more we also see that it's used in other continents, also closer to home where I'm coming from the Netherlands. In Europe, we are also protecting and reintroducing actually wildlife. And for us, it's all about how can we help with technology to reestablish the balance between humans and wildlife. There's a lot of conflicts going on. We can put animals in protected areas with fences around it, but at some point we have to interact again with this wildlife, because that is also an unsustainable way to do it. So how can we use technology to restore this balance? And in our vision is to literally connect with these animals through sensors. So I think this really connects to all these things that have already been said today, is that with technology we're able to get more understanding of their surroundings, how they're feeling, how they're doing. And just to give you one example, this is an elephant collar which is used to track and protect elephant. And this goes onto the neck of an elephant, which is, for that elephant, it's not much. It's very lightweight because of the technology, but it will be there for more than 5 to 8 years. So we really have to think about what can we put on this collar now, which makes it intelligent enough to provide us all information about what we need to understand from that animal. Like, is it in danger? Is it looking for water and food? Can it still survive in the area where it is? Or also to protect communities living around these wildlife. Are there any threats coming towards the farmers? So it's not only for the safety of the wildlife, it's also for the safety of the human. And just one example of the data that is already coming off our wildlife tracker. So this is a ranger edge, which is used to support rangers in the field to protect. But also, for example, this goes into the horn of a rhino to protect. So it grows out in 2 years, but this is the same data coming out of that. So it's a lot, but still it has all the same problems that we have with the industrial applications, that we have very little bandwidth because it operates on a very small battery. So we need to use ML to already understand what is going on the sensor level, and then only send the outcome over in our case, a LoRaWAN network or a satellite network. So I think for us, this whole edge impulse development is so to the core of our interest that we really want to put this technology in all these trackers and then make it available in a very nice and easy to use workflow to other conservationists working with technology. Yeah, I think that's it.
Yeah, hi everyone. My name is Sam Kelly. I head up the Sentinel AI project at Conservation X Labs. We're a nonprofit based out of Washington, D.C. We really came at this problem in that we know that tools in wildlife conservation are really important. Really important monitoring tools like what I have here, which is a Bushnell camera trap. What Zach was talking about earlier in his keynote. This is great. It's a great tool. Allows you to understand what's going out there in the wilderness, in the middle of nowhere. But it is a data logger. It just stores the data on an SD card. It doesn't allow you necessarily to take action. So you're just monitoring what's going on. It may change how you manage a park, but it doesn't allow you to intervene in time-critical scenarios. We've been working on, as you can see in the photo, a device that attaches to existing, well, I guess it's kind of a mean term, but a dumb device and makes it smart. So by going into the SD card slot, essentially we're a universal AI adapter. Just to quickly go into why we do edge-based computer vision, a huge problem in wildlife conservation is that you're collecting data from the middle of nowhere. There's a high cost of data retrieval. Processing that data is a real big pain. We have people we work with that capture 10 million photos a season and have to go through that manually. There's a lot of false positives, a lot of false triggers of a leaf blowing in the wind. And all of this really means you miss time-critical events. We really see AI being a really good tool for this, is to essentially a filter out there in the field to send back critical information. But the big problem is that everyone has a different question. Someone's looking at jaguars, and then we have people looking at elephants as well. These are some of the example projects we've been working in. We've been working in Montana with a reintroduction of a species called the swift fox. There's human-wildlife conflict considerations, so early detection methods for elephants. The third one there is working with seabirds. As sea levels start to rise, there are concerns around coastal habitats disappearing. And then finally, a lot of work around time-critical scenarios of responding to invasive species on islands which pose threats to those ecosystems. Yeah, so really excited to hand it back to Stephanie.
Tom.
Oh, Tom. Oh, sorry, just quickly, one more thing. I think there's some really interesting work to be done beyond presence. I think this is an example of a behavior algorithm we've been working on with gorillas. And I think this is just a frontier. I'll just leave it there as to pique everyone's imagination about what we could do next within the space of edge AI.
Fun. So I occupy a slightly different area of this ecosystem. My name is Tom Quigley, and I'm the managing director of a new venture capital fund called Superorganism, which focuses on investing in venture-scale startups that benefit biodiversity and prevent biodiversity loss. And so I'll start with the why on our side, which is while we really have, as you've seen, a clear need to prevent extinction and biodiversity loss on a local level, we also need to prevent it on a global level. And there are industries that drive biodiversity loss, like overexploitation of resources, habitat loss, pollution, and a number of others. And so our large why is to be able to fund the types of companies that will rapidly go to scale at the speed that we need solutions to go to scale at, and be able to address a lot of those drivers. One of the biggest whys is to be able to provide funding to the types of projects like these and like others. After many, many conversations and spending time in companies like Conservation X Labs and in the field, money is one of the #1 constraints. So our mission is to find and supercharge companies that benefit biodiversity and deliver venture scale returns. And we do this by focusing in 3 different areas that we think will be able to find venture scale companies that will provide returns for the fund, as well as being able to provide impact at scale. Our first focus area is looking at any of the industries that currently drive biodiversity loss along some of those 4 or 5 big areas globally, and invest in teams and companies that will be able to use emerging technologies and address those drivers. Our second area is the overlap of climate and biodiversity, so that we're able to invest in companies with the tailwinds that are coming through climate tech and the talent and money, and solve for both of these giant global problems, the climate crisis and the extinction crisis. And our third, and perhaps most relevant to this conversation area, is enabling technologies, which are new technologies that have venture profile, but are also putting new tools into the hands of conservationists and scientists to be able to work to protect biodiversity. The last piece that's relevant as well for the funding ecosystem is that we've pledged 10% of our ongoing carry to future conservation efforts. So when that begins to pay out, then we're going to be able to fund more things than just venture profile companies in the future.
All right, on to our panel discussion. While we're talking, we're just going to have ticking away in the background some more Tech for Wildlife projects, which are all, if you want to know about any of them, come find me and I can connect you with them. Or you can find them on Twitter and Wild Labs. But I want to pick up on something that Fran actually started with, and we have to start with what the world actually needs. And from our panelists who work very closely in the field and with field-based partners, what is it that you see the role of ML and ML on the edge? What are the biggest opportunities, and what are the needs you hear coming from the field? Tim, do you want to start?
Yeah, what we see is that there's a lot of sensors already out in the field. And obviously there's issues with connectivity at a lot of locations. So getting position from a rhino walking in a very remote area with no connectivity is already very hard. So once you have little connectivity via satellite or something like that, it's usually not a lot of bandwidth. So, their ML is already really interesting. I think that's already been discussed in industrial applications to push, the sensor outputs and the learnings from that, the inferences, to put that over that very tiny connection towards the central location where you can actually act on that data. In this case, maybe park management or anti-poaching or alert communities. So I think this is really where it can make a difference.
Tim, does that match what you're hearing?
Yeah, I think there's some really interesting, we work with a lot of large parks, right? And these are such large areas that, you're talking, many, many hours across the park. And so if you can deploy resources to better protect or manage that park through the tools, I think, it really allows them to be more effective in their job.
That's quite a specific use case, though. There's the range of applications in conservation. It's massive, park and responding to different events is one, but there's huge research and a lot of questions that people are asking, right?
Yeah, absolutely. I mean, if we just take it from the vision side, for example, because I work with trail cameras or camera traps a lot, most of it is around presence, right? So we're detecting presence on the landscape, and we're hearing more and more concerns around what maybe bleeds into more of the collar work around welfare of animals, like how are the animals doing from a health perspective? Can you detect that out there in the field? So there's some interesting kind of frontier elements to it as well.
Kate, you talked about focusing on the right challenges. How do you find the right challenges?
By talking to conservancies in the field. We've been spending quite a bit of time speaking with conservancies in the Masai Mara. As an example, one of them is the Mara Meru Cheetah Project. There are about 7,000 cheetahs left in the world. 60 of them are around the Masai Mara. And we have this researcher who is spending hours and hours every single week in the field, taking pictures, listening to cheetah songs, and then identifying each and every cheetahs just by the eye. A lot of things that machine learning and data science can help simplify and streamline and gain her a lot of hours of work automatically. So it's all about spending the time with her, understanding their challenges, what they're facing, and sometimes it's not the most complicated technology which will solve those little challenges. It's really things that we've built over the past couple of years. They just need the access to it and to be aware of it.
And make it user-friendly as well.
Yeah.
I think if we know this technology is here and we all work with it, but if the distance between people in the field, we say, using it on a daily basis, it's still pretty big. Huge. So for example, if you make a very nice tool chain with all these capabilities in there, easier to use in the field, I think there's much to gain still. So.
I think one of the things that came back through our state of conservation tech research was the biggest challenges, and we asked it of developers of technology, but also field users. And both sides, money was right up the top in multiple perspectives, like seed funding through to maintenance. But actually what came through most strongly from field users was not actually that there were performance issues, but it's actually capacity building and training and actually using the tools that we have and making them user-friendly and getting to the point where they can actually be useful and having impact for conservation. Is that part of what you're doing with your work, Kate?
It is, and we are enabling developers to do this capacity building with conservancies on the ground, because us building the technology here are not going to go talk to a small conservancy in the Masai Mara and teach them how to use our tech. We need to use developers who are on the ground, can also iterate and customize the tech for these conservancies to deploy it and teach them how to use it. So Clinton has been spending also a lot of time in the Masai Mara with the Cheetah Conservancy, one of the assistants that is a little bit more technology literate, and teaching him about AI and machine learning for conservation. It's been really beautiful to watch.
We should actually have a chat after this, because we've been, with the support of ARM, we have a 6-month Women in Conservation Tech program running in Kenya and moving around to East Africa. And we're coming from the other side where we're training conservationists and women, early career women conservation in technology. So I feel like there could be a nice link together. Anyway, that's a side thing. Speaking of Edge ML specifically, what do you think's blocking the adoption, the further adoption of it beyond? What do you think's blocking the further adoption of it? Tim, you look like you. Oh, sorry, not Tim. Sam, you look like you have something.
Yeah, I think it's twofold. One, it's still a scary word to a lot of people. I think we just have to admit that as soon as you say AI to a lot of people, it's kind of something that's mysterious or maybe can't be explained. We also see a lot of concern around false negatives specifically in the space. So that meaning like you're going to miss an event that was really important. That's actually much more of a concern than the false positives in a lot of ways. The other thing is that, as I mentioned earlier, is that everyone has a different question. So there's lots of models that have to be generated for specific use cases. And I think that you can't have essentially one model to rule them all. You're going to have to make specific project models.
One of the concerns we hear, especially about EdgeML, is a lot of conservationists like to hoard data and view acoustic and camera trapping data as biological records. And even if we don't have the capacity to pull information out of it right now, in 10 years or 50 years, it might be really, really important. Like, how do you overcome that and look at the usability of it?
Create confidence. Just getting into it, using it, making it transparent, so that people also, okay, I'm losing like high resolution data, but I get back, for example, with collars or wildlife trackers, that it will last for 8 years and not for 1 year. I mean, that's a difference. And then they're more reluctant to say, okay, then I'm willing to give away a bit of high resolution data and I trust what is coming out of the model. But I think this will take a while to get into that stage.
Fran, I wanted to bring you into the conversation. Hi. Speaking from the private sector perspective, we've worked together a long time and had a really great relationship with ARM and how you approach working in impact. Can you speak to why should the private sector be involved and invested in impact? What's the reason from your perspective?
Some of those global frameworks I mentioned earlier is the why we need to, but I think there's so many shifts happening in the computing market that have been mirrored by shifts for people and planet. We're living in unprecedented times, the word of the decade. Resource constraints across the world, whether it's energy security, whether it's food insecurity, whether it's water insecurity, all these things are foundational to happy and healthy lives on the planet. You can't have sustainable business on an unsustainable planet, and that's sort of the mantra that I live by. But from the perspective of being in the private sector, there's huge changes in the expectations of business, whether that's coming from governments, whether that's coming from consumers, or whether it's coming from employees. Lots of people don't want to work for companies that aren't contributing actively to solutions that are that they're seeing in the world around them. So I think there's many different reasons why the private sector should and can care, whether it's ethical, environmental, or economic. And I describe it as being a smart, good, and right thing to do from all those different perspectives. But on top of that, I think there's a way of doing it. So leading with humility. If you're going to be involved as an organization of a certain size, recognize your place. So if you're not the organization with the expertise, delegate that expertise. Don't helicopter in and think that you're going to solve every problem everywhere with technology, because controversially, I deeply believe that technology is not neutral, technology design is not equal, and technology is not always the answer. But when it is, it can be transformative, as you've heard from my fellow panelists here.
Tom?
I just want to add one aspect to that as well, which is that biodiversity loss at a global level is an extreme risk to lives, livelihoods, economies. And it's finally starting to come into the more popular vernacular within climate and other areas that are raising in profile now. There was a study done maybe last year that said that out of all global GDP, 55% of industry is moderately or heavily reliant on nature and the services that it provides. So think about the type of embedded risk there is in catastrophic biodiversity loss in a planet where 25% of all species are at risk of extinction, gone. So it becomes a little bit less of like, oh, why should we feel like we want to be involved, and more of, we have to be involved.
Yeah. We've talked a bit about kind of the challenges on a project level, but we can only meet the moment if we scale up significantly, and like the tech sector has a huge role to play in that. Tom, do you want to talk to what you're hearing from and why you're kind of the bridge between the different sectors? What's your perspective in how we scale up and how we actually achieve impact and like shift the trajectory?
I think that there's impact that has to happen, like I said before, on local and global scales, and we're pretty deficit right now in terms of our global impact for biodiversity loss. But there are real areas that are appearing which are very, very interesting, particularly for AI and machine learning applications, and particularly for edge as well. So one of the areas that's starting to open up that looks like it's going to be a market that will sustain a lot of growth for prevention of biodiversity loss is nature-based solutions within carbon markets, where there's forests or agroforestry or other natural capital solutions. They have a need to be able to measure the amount of carbon that they're generating year on year, and that is all sensor data that can be incredibly useful to conservationists and to scientists as well. And so if you're looking at things like above canopy LiDAR with drones, below canopy LiDAR measurements, wildfire monitoring is a particular area within edge ML that if you need to have a rapid response very quickly, then these are the types of sensors that are particularly interesting. And then within nature-based solutions as well, you're seeing a small premium start to appear for biodiversity monitoring. And so where are we finding nature-based solutions with higher biodiversity that are worth more in those markets? And in those, now we're looking at tools like environmental DNA sensors, passive acoustic recorders, and obviously camera and video traps. Now the increased deployment of those is going to lead to a massive new amount of data. How do we manage that data? How do we understand and pull out insights? How do we sift through the massive amount of false negatives or false positives to pull out the real signal? And we're going to continue to see new types of data come on stream in Earth observation, in genetics over the next 10 years, I'd say. So being able to look at things like hyperspectral imaging from space, synthetic aperture radar, and increasing of full Earth 3D imaging, that amount of data needs to be able to be processed. We're going to need to be able to do things with it. It's going to unlock totally new possibilities of how we can protect the planet using technology.
And just to add to that, in just thinking of Zach's bucket of money on the slide earlier on, there's a $12 trillion commercial opportunity in unlocking the global goals, $2.1 trillion of that for the tech sector. So even if the motivation is to preserve life on land, whatever it might be, there is a necessity to transition to a just and sustainable economy, of which the future businesses, the future successful businesses, are going to have to be getting on board. So I think there's many different opportunities and reasons why organizations need to be thinking about that Tom's just described.
And last note about companies like Edge Impulse, we're going to see a massive amount of data, and AI is an incredible tool to be able to pull learnings and actionable insights and out of that data. But not everyone, we can't expect everyone to be a data scientist. We can't expect everyone to be an AI developer. And so where there's that layer of taking the signal or taking the noise and turning it into signal and being able, there's a massive opportunity in there. And that's something that we see companies like Edge Impulse doing incredibly well, and think there's a great opportunity, market opportunity in there as well.
I think one of the things that stood out for me was from Zach's talk. It was the idea that it takes a village. And Kate, you also mentioned it in your talk that it takes a village, and we talk about it a lot. And I guess the message I'm hearing coming from you guys as well is that everyone has a role to play. And I think as conservationists, we're so used to trying to do everything ourselves and just trying to find a way to teach ourselves data science or become ML. But actually, the impact that we can have growing the team and finding collaborations and different ways for people to slot in and different technologies to slot in is huge, and is where the impact is going to come from. So as we're heading towards the end of this session, I'd love to hear from okay, we have to build the team. How do we do that well? Fran, from your experience working with big teams, what have you learned along the way of how to collaborate effectively with conservation, and how to find projects and partnerships that will lead to impact?
Yeah, I think it's a lot of the different things that we've talked about, so the capacity building element, the working with the right types of partners. Don't think that you can do everything. We don't do that as an industry. It's an ecosystem for a reason. We need each other. It's the same in any sort of big challenge that you're facing. So I think co-creating with the user some of the principles for digital development, so it applies beyond conservation, but on any kind of impact project. Use the systems that you have, but make sure that you're working with the problem holders and make sure that the right people are in the room when you're trying to design a solution, when you're thinking of how to apply it, and approach it with humility, that not everyone's going to be the right person for every single role. Yeah. But you can identify your own sphere of influence, whether it's personal or professional. What unique capabilities do you have as a business, as an organization? Is it your people? Is it your money? Is it your network? And share them freely.
Tim and Sam, both coming from like the tech background, how do you find, what advice could you give about finding projects to, if you've heard this panel or just got excited, what advice would you give individual engineers and developers about finding their way into conservation?
Well, I think most important is the passion. So you need to be driven by, what gives you passion? Like, where do you want to put your energy in? I mean, that's the most important thing because it's very hard work, I guess. As conservation is very under-resourced in general, that's well known. So everything you do is like extra hard because there is always like barriers that are not in normal industry, I would say. So I think that's the most important thing. You have to follow your passion. Okay, there's really something I want to put my energy in and go for, and then try to help the project wherever you can.
Sam and Kate?
I would say it's mostly about finding people or a safe space for you to innovate and create. I mean, there are a lot of entities who are trying to bring you the problem statements, trying to matchmake you with the problem owners, and bring you exposure and awareness. Find these and go get the tools and the platforms that you need to build the solutions and apply them in the right way. And again, it's going to take a village. It's a whole ecosystem ranging from the policymakers to who make sure that there is a framework for those developers to innovate, the private sector, the big tech companies who are building those tools and those platforms for developers to build solutions, all the way down to the devs who are applying it in the field and can be in contact with local conservancies or other problem owners. So we have to move that whole ecosystem together, and we all have to work together in the same direction if we want to really drive innovation on the ground.
Yeah. And I would just say, like, if you're trying to get into the space, start local. You know, like it's really you find places around that have some kind of need, and if you can address that need, I think you'll find yourself kind of getting into this community and see how your skill sets that you bring from your industry could really apply in this space.
So I'm aware we're coming to the end, so I'd love to give everyone the chance to final thoughts, what makes you feel optimistic, or if anyone could do anything coming out of this, what would you ask of them? Who wants to start? Tim, do you want to start?
Well, we're always looking for help from anybody also in this audience, like support in skills, but also in resources, of course, because we are running an organization that is very resource limited. We are all, but support is always needed, so please find us.
Sam?
Yeah, and I think just the fact that we're having this conversation at an event like this shows that I think there is hope in a lot of ways that, this problem is important to a wider range of people. So I'm pretty excited to chat with all of you with all your, skill sets I'm sure I don't even know you have.
One of the things that gives me the most energy is seeing the amount of talent. There's a massive mobilization of people that are coming in with skills and expertise from many other industries to focus on problems in climate, to focus on problems in biodiversity, unlike I have seen before at all in my career. So it feels like there's a sea change in the last 2 years of the amount of interest and people that are setting up businesses and technology efforts to work on this. And it is amazing, and we absolutely need those people, and it is empowering for people like all of us who've been working on these problems for our entire careers.
I guess for me, again, we're a non-profit, so support is number one for capacity building. And I'm not just talking about monetary support, I'm also talking about in-kind support. I'm about to go back with some hardware that's not accessible easily in Africa for some of these devs. So if you have some, I'll be happy to take it. I'm here until the end of the week. And then more than this, I would love for you to keep in mind to lower the barrier to entry to technology. Not just building for your ecosystem around you, but think about the ones who are actually applying that technology in the field. And I think this is an important takeaway for audience here today.
Kate said what I wanted to say, so come and find us in the round table.
Well, what a perfect way to end that. Thank you to all of my fellow panelists. If you would like to come and have further conversations with us, find us at lunch or come to our impact panel, or just come look for things on Wild Labs. There is a role for everyone to play here, and a wealth of partnerships and data and really interesting challenges that you could be working on as well. So come have a chat to us. Thank you so much, everyone.
Pleasure.
And now, welcome on stage Katelijn, HealthTech entrepreneur and founder and former CEO of Klue.
Good morning, everyone, and thank you, Edge Impulse, for having me today. I'm delighted to be here. And thank you to the organizing team for putting together such a broad and diverse, yet very to-the-point lineup of speakers. So thank you. And I love this event. I love it because it's unique on how it brings together disruptive and progressive and creative business thinking with deep and thoughtful cutting-edge technology innovation and conversations. Just a quick few words on my background. I started my career in semiconductor, first as an engineering intern at CERN, the largest European laboratory for particle physics, where I was fortunate and had the opportunity to collaborate on the design of the readout electronics of the Large Hadron Collider project, which was one of the most ambitious and most high-profile scientific projects at that time. From there, I shifted a bit and got into mixed-signal circuit design for my PhD work at Stanford. A to D conversion and data conversion was very popular at that time because on one hand, we had the promise of Moore's law, which was projecting exponential growth and progress, but on the other hand, that only applied to the digitized world, and the world around us, as we all know, is still analog. So all kinds of digitization efforts at that time were getting a lot of attention. But now, with the creation of so much digital data, we had created ourselves a new problem. Wireless connectivity, or connectivity more in general, became a challenge. And so in 2004, my husband and I started a semiconductor company in the wireless connectivity space. Osmo Devices was a semiconductor company. We invented and we commercialized ultra-low power, Wi-Fi-based wireless personal area network connectivity for low power battery operated devices. Think mice, keyboards, headphones, remote controls, and then later IoT devices. We standardized the technology within Wi-Fi Alliance as part of the Wi-Fi Direct certification standard. And in late 2012, Atmel, which is now part of Microchip, acquired us as a part of their IoT strategy. And after the acquisition, I changed gear yet again, and I decided to dedicate my time and my energy to an area and a space that I'm personally very passionate about, and where I also felt it would allow me to make a direct and deep human impact. And so that's how I ended up in the digital health space. And in 2016, I started Klue. Klue was a software and AI company. We developed hand gesture recognition technology that allowed us to automatically, so without any user intervention, detect when and how much and how fast and how often someone was eating or drinking from analyzing their hand gestures. So from analyzing the motion sensor data in off-the-shelf wearables like the Apple Watch. Now, capturing and tracking eating behaviors is a critical missing piece in diabetes therapy. And that's how, at the end of 2019, we decided to join forces with Medtronic in a strategic acquisition. Why am I telling you all this? I'm not just showing this slide to tell you my personal journey. I show this slide because it's also representative of a bigger and important trend across the tech industry. For the past couple of decades, we've seen a shift of value capture being pushed up the stack, away from the underlying hardware and components and into the software and the applications. And when it comes to healthcare specifically, we've now entered into an era where the challenges, but also the opportunities, will be in turning the data streams, the abundant streams of digital data that we have, in actionable and meaningful insights for a more patient-friendly, a more personalized, and a more efficacious healthcare delivery system. So value capture is moving up the stack, but there's good news for us here today. It is also moving down to the edge. And I know we have a nice representation from Semiconductor here. So what does this mean for your silicon roadmap? I believe it means two things. We need to understand the use cases. We need to understand at a very deep level the needs of the end user. Understand the use case and own it. And then translate that into building what I like to refer to as empathetic silicon. Silicon that is truly attuned to the needs, to the user needs of these high human impact use cases. And secondly, lean into the application. Invest in software modules and SDKs and tools, but also invest in generating those actionable insights locally so that it's easier for developers to bring the solutions to market, and your silicon and your software offering is really end-to-end aligned with the end user in mind. So now let's talk healthcare. It's an incredibly exciting time to be in healthcare. For the first time, we have a computer on the body. We've had sensors, lots of them, and a computer in the car for many years. They give us data, the data gave us insights, and those insights gave us protection, they gave us safety, they gave us comfort, and they gave us convenience. Yet when it comes to our own health, for the past 200,000 years, or pretty much since the start of humanity, we've been flying blind. Now that is changing, and it's changing fast. Today, we don't only have Apple Watches and Fitbits, but we're starting to see a whole slew of devices in, on, and around the body that are giving us critical health information and that are tracking pretty much every element of our physiology, our behaviors, and even our mental health. We have rings that capture our sleep quality. We have minimally invasives, and as we heard earlier today, even non-invasive devices that can accurately track our blood sugar levels. We have smart pills that can monitor internally the internal reactions with medicine and soon may replace colonoscopies or endoscopies. We have tattoos and smart clothing that can track our vital signs. And we even have invisibles, ambient sensing, like reflections of Wi-Fi signals that can track the progression of Parkinson's disease, or AI-enabled voice analysis that can detect lung infections, neurological disorders, or mental health issues. Think not only about the data, but more importantly, think about the insights we can get from this new category of devices, thanks to the innovation and the progress of machine learning at the edge. And some of these devices are still in research or development. But increasingly, we're seeing these devices coming to market as medical devices, medical-grade devices that have proven their clinical relevance and have withstood the test of regulatory approvals. And those technological breakthroughs, powered by machine learning at the edge, and in many cases accelerated by the pandemic, have now unlocked a fundamental paradigm shift in healthcare. Finally, we're starting to see us moving away from the traditional healthcare model, which is really a sick care model, to the delivery of true healthcare. Healthcare that tracks us 24/7, wherever we are and whatever we're doing. Healthcare that detects something is off way before we feel symptoms or get sick. And healthcare that is deeply attuned to our individual needs. The future of healthcare is real-time and all the time. It is proactive and it's fundamentally personalized. And that future is happening now. So that was also our vision at Klue. Once you have sensors and a computer on the wrist, there is so much more you can do. At Klue, we felt that the wrist was being underutilized. Nobody was looking at the wrist as a generator of data. But what if the wrist can give you insights, valuable insights about your behaviors? What if your wrist can give you that information automatically without requiring any user input? And what if your wrist can give you that information in real time as the behavior is developing? Well, as we found out, it can. So at Klue, we developed a fine motor AI technology, and we discovered that it is indeed possible to extract some very unique, very actionable, and very valuable insights about our doings, all from data generated by the wrist. And as I mentioned before, we started with eating and drinking. We developed a gesture sensing software that allows us to automatically detect when and how much and how often and how fast a user is eating or drinking, all from analyzing the motion sensor data in off-the-shelf wearables. And since the processing was happening locally and in real time, we were able to interact with the user in the moment as the behaviors were developing. Whether that interaction was a gentle nudge to slow down when you were eating faster than usual, or a reminder to stay hydrated throughout the day, or if you were someone living with diabetes, to remind you to take your insulin when you were starting your meal. Now imagine that this same meal signaling technology gets integrated into an artificial pancreas system to turn it into a fully autonomous and personalized closed-loop system that knows when to dose and how much to dose without requiring any inputs from the patient. So the patient can just go about their lives and just eat when they want to eat. Now that is truly game changer for diabetes therapy. That was the vision behind Klue, but it was also that shared vision that led us to join forces with Medtronic in 2019. When people say digital health, they oftentimes think mobile app. I think that's a misnomer. Digital health, to me, has 4 critical components. It starts with the sensors. The sensors need to be reliable, they need to be accurate, and preferably they need to be very low power. The sensors give us data, but not just any kind of data. The sensors give us objective data, something we can never get from self-reporting. But it's not until we apply math and machine learning and AI that we actually get the insights and can turn those data streams into a meaningful digital biomarker. And then finally, we have to integrate that digital biomarker or those digital biomarkers seamlessly into clinical pathways. And that 4th step, unfortunately, is oftentimes the most difficult. And it's where we see most companies struggle or stumble. It's difficult because it requires multidisciplinary collaboration. we as technologists have to sit down and listen and work with the other stakeholders, the clinical experts, the providers, the payers, the regulatory systems and regulatory agencies, and finally, last but not least, the patient. But it's not until we bring those 4 factors together that we have all the attributes necessary to launch a successful digital health solution. And let me share a couple of factors that I personally have found helpful in building a successful digital health company. First, and this has been mentioned by others before, solve a real problem. Start with the problem, start with the unmet need, understand your problem statement, and work your way backwards. Start with a problem, then think what insights do I need to be able to solve that problem. Once you know the insights, think what data streams would I be able to use to actually create these insights? And then finally, what is the hardware, what are the sensors I need to be able to get those data? We started Klue with a very strong and deep and personal connection with the pain point of meal management in diabetes therapy. That was our North Star throughout the whole journey of Klue. Secondly, keep it simple. So often we see engineers and even business leaders feel an urge to solve all problems with AI. They're using AI like a hammer looking for nails. Certain problems, and a lot of problems, need complex neural networks, AI, and machine learning to solve the problem. And we've seen many of these great examples here. But there's other problems that actually can just as well be solved with simple math or rules-based logic. So I always encourage you to think carefully, and as you're deciding on your method, be very intentional and thoughtful. Show that it works. And with that, I'm not talking about that the hardware is performing to spec or that your code is running bug-free. Show that it works clinically. Provide the evidence base. Invest in actually demonstrating that what you're building is having the human impact it was intended for. This can be challenging at times, but don't be afraid to look for partners. We at Klue had a terrific partnership with Stanford School of Medicine, and together we were able to demonstrate that our solution could deliver significant reduction in hemoglobin A1C. And that brings me to my final point, collaborate. The human body is extremely complex. Healthcare and the healthcare ecosystem is even more complex. So don't try to go it alone. We're still operating too much in silos. Identify what your core competency is. Excel at it, be the best at it, but then seek partners to help fill out the missing pieces of the puzzle. We haven't talked much about regulatory yet, and it is an important piece of bringing a digital health solution to market. Regulatory pathways can be complex, they can be intimidating, but it's something every digital health company at some point in their life cycle will have to go through. At a 10,000-foot level, it comes down to 2 basic questions. Is my product used for a medical purpose? If so, you'll likely have to go through some kind of a regulatory pathway. And the second question, can a malfunction of my product cause harm to the individual? This is a more subtle question. And depending on the degree of harm it can cause, you'll find yourself in a different classification. The class 1 devices pose the least risk to the individual, and therefore the process is pretty lightweight, it's pretty easy, it's pretty fast. Class 3 devices, on the other hand, like the artificial pancreas system that I was talking about just earlier, impose a much higher risk to the patients, in some cases even death. And so naturally, those will be subject to more stringent and a harder bar from a regulatory approval standpoint. In general wellness and low-risk applications are typically not actively regulated. This is one of the reasons why we've seen such a proliferation of consumer health applications in the past few years. That has been great, it has been needed. Unfortunately, some of these applications have failed to pass the clinical relevance test. And so that has been backfiring a little bit on the reputation of the industry. As you're developing solutions, especially if they involve software, it will be important to understand the difference between, am I developing a mobile medical application, or am I developing software as a medical device? This largely depends on the platform on which you'll be rolling out the software to the patients. And finally, the regulatory pathways are a work in progress. The FDA, the agency, is still trying to figure out what the right way is to regulate these AI-enabled devices, which have very different characteristics from what they're used to for the many, many years that came before. There is some resources, some good resources available on the website. The FDA is also extremely approachable, and I would definitely encourage everybody who is developing a medical-grade solution to reach out to the FDA and help them help you, or ask them to help you with this regulatory pathway. A lot has been said already today about the benefits of Edge ML in many, many applications. I will summarize it that for digital health, Edge ML brings peace of mind. And to say it with a patient voice, I need my therapy to work without interruption and with no delays. I am worried that my personal health information will be stolen or lost. So privacy and keeping certain information local can be really, really important. And finally, I don't want to have to think about having to charge my devices. I would like to leave you today with two thoughts. First one is to dare to think exponentially. Things are changing, and they're changing fast. We won't experience 100 years of progress in the 21st century. It will be more like 20,000 years of progress at today's rate. And finally, I would like to leave you with a quote from Dr. Sinclair from his book, Lifespan, Why We Age and Why We Don't Have to. By the way, a book I would recommend to everybody in the audience interested in health to read. Prolonged vitality, meaning not just more years of life, but more active, healthy, and happy ones is coming. It is coming sooner than most people expect. By the turn of the next century, 120 years of age might not be an outlier, but an expectation. So much so that we won't even call it longevity. We will simply call it life. Many of us in the audience today will have the opportunity to blow the 120 candles on their birthday cake and see their great-great-grandchildren grow up. But it will require all of us to think bold and act bold, while at the same time being responsible and thoughtful in the conversations around societal and ethical issues that this innovation will undoubtedly provoke. Thank you.
Welcome on stage, Ben Gibbs, founder and CEO of Ready Robotics.
Good morning, everyone. I'm here to talk to you about robotics and machine learning in manufacturing. Now, before we talk about where we're going, I think it's important to set the stage and talk about where we've come from. And really, over the last 250 years, we've experienced 3 industrial revolutions. In the span of about a dozen generations, we've gone from a pastoral, agriculturally focused lifestyle to one dominated by machines and automation. The first industrial revolution saw the advent of what are called machine tools and the ability to start to mass produce certain types of goods. In fact, one of the goods that came out of that first industrial revolution is this, the humble screw. Now, you may be asking yourself why, in a talk about machine learning and robotics, I'm actually talking about screws, but this actually embodies an important theme that I'll be returning to throughout my talk. This screw and the ability to easily mass produce the standardized screw is what laid the foundation for the second industrial revolution, best embodied by the assembly line of Henry Ford, which in turn paved the way for the third industrial revolution that is celebrated in the very building that we find ourselves in today, the digital revolution, computers. And that's the theme that I'm going to be talking about throughout this, this presentation here, is the idea that standardization and usability lay the foundation for what comes next. And by the way, the United States has been central to all of these revolutions over the last dozen generations. And I know that there's a lot of hand-wringing out there about how we don't make anything in this country anymore, and everything's been outsourced overseas. But the truth of the matter is, the United States today is still, in fact, a manufacturing powerhouse. We make over $2.2 trillion worth of goods on an annual basis, employing nearly 13 million people scattered across over 300,000 factories. And the types of things that we're able to produce here are powered by technology. In fact, the United States invented the first robot. And around the same time that we were able to produce the first mass-producible robot, we were able to also start mass-producing computers. But these are two technologies that have had very, very divergent adoption curves. The very first robot was actually deployed into a General Motors factory in Trenton, New Jersey in 1961. Again, roughly around the same time that we started to mass produce computers. Today, there are hundreds of computers in this very room, in this building. Yet there is precisely one robot in this building. And that's a robot that our company brought here as a demo. So where are all the robots? How come there are only 40,000 robots sold per year in the United States and 400,000 globally, a number that is less than the number of iPhones that Apple sells in a day? To really understand why there's been such a divergence between these two technologies, we're going to take a little bit of a trip back through time. We're going to go back to the 1980s. Because it's the 1980s that really saw the inflection point for computers and the beginning of that divergence. I'm going to talk about for a moment how robots are programmed in the 1980s and how they're programmed today. They're actually programmed through a device called a teach pendant. And that teach pendant looks like this. It's got dozens of buttons. It's got a small LCD screen. Kind of looks like an oversized graphing calculator from the 1980s. And using that teach pendant, you're programming in a language that is unique to that vendor. So if you're programming on a Yaskawa robot, you're programming in a language called Inform. If you're programming on a FANUC robot, it's a language called Carol. ABB uses Rapid. Kawasaki uses AS. I could sit here and I could rattle off dozens of these different languages. It's a highly fragmented landscape, and it's one that doesn't really pay attention to the importance of usability. In fact, the last leap forward in usability when it comes to robots actually happened in 2005, nearly 2 decades ago now. And that was from a company called Universal Robots that makes the teach pendant that you see on the left there. And that was actually a great leap forward in robotics, and it demonstrated to the industry the importance of usability. So usability and standardization. Usability being something that the computer industry really realized helped drive massive growth and adoption. In the 1980s, at that inflection point, what happened? Well, there was the advent of spreadsheet software, first with VisiCalc, later with Excel. And that spreadsheet software was really the first example of a no-code programming interface for computers. It is an interface that enabled accountants and financial professionals to be able to leverage the tremendous power of computers without needing to write a single line of code. And that really helped drive that mass adoption by empowering them to do this type of complex computation, again, in a no-code environment. So that's where we've come from. Now let's talk about where we're going. Here at Ready Robotics, Perhaps unsurprisingly, given the theme of my talk, we're focused on two things. We're focused on standardization and usability. At Ready Robotics, we make a suite of end-user-facing productivity apps that enable people in the manufacturing environment to very easily use robots from a variety of leading vendors and use it the exact same way. So using our platform, Forge OS, and the productivity apps that run on top of it, you can program Fanics and Yaskawas and ABBs, Kawasaki's, all the exact same way. And this is something that is tremendously important to help move the industry forward, because there's actually a massive problem in manufacturing today, and that's what's called the manufacturing skills gap. There are over 800,000 unfilled jobs in manufacturing today, tasks that ultimately could be filled by robotic automation if it was easier to deploy them. And this is something, obviously, that we are very, very focused on, is the idea of making it easier for end users, making it easier, like this guy up on this slide here, who is a very intelligent guy, very hardworking, very mechanically adept, knows his way around these type of big, complicated machines. But what he doesn't know how to do is program. And so his ability to be effective in the industry is stymied by unnecessary complexity and fragmentation. So everyone is talking about the coming fourth industrial revolution. And what I'm here to say is that that is going to be built on what was basically ushering in all of the other revolutions: usability and standardization. But it's not just about making it easy for the end users to do this. What we've created is about making it easy for developers as well. So our end user-facing productivity apps, those are built on top of our Forge OS platform. It's really a common set of APIs that enable developers to hook up their products, their new technologies, and hook them up in such a way that it can now scale across the entire robotics industry, something that was not possible before. Before Forge OS, what you had to do is you had to sit there and you had to write interfaces for every single robot brand, and there are dozens of them out there. It takes a lot of time. Imagine, as a software developer, if you had to sit there and every single PC OEM was running their own operating system. It would be incredibly challenging to scale things effectively. So using this common set of APIs, we now enable developers to deploy their tools and their solutions in an easy way, in a usable way for end users to be able to effectively use. In some instances, this means working with one of our partners like NVIDIA, where in the NVIDIA Omniverse, you can now program simulations of industrial robots using Forge OS and these productivity apps, and then take those programs that you've written in simulation and seamlessly deploy them out into the real world to run on those type of robots without having to change a single thing. But it's not just about pushing stuff from computers out into the real world. It's about being able to easily capture data from the real world and bring that back into the digital world. And this is where we're going to talk a little bit about the importance of machine learning and the importance of edge ML. Because here's the thing. A lot of these factories, they're not in urban centers with easy access to fat broadband pipes. They're in far-flung parts of the country, far-flung parts of the world where they don't have high-speed internet connections, which means they can't do ML up in the cloud. They need the ability to do this locally on the edge in an easy way so that they can focus on what they're good at, which is solving complicated problems in a manufacturing environment, oftentimes with mechanical solutions, but oftentimes in ways that need to be able to leverage software and ML. And so together with Edge Impulse, that's what we've created. There's a demo, I think, that was seen earlier today. We got a robot out there today that actually shows this type of anomaly detection and how easy it is to set up. It's actually out there running on a UR cobot. But what's nice about it is because it's running on top of Forge OS, you can take that same solution and deploy it onto the hundreds of other robot models that we support without changing a single line of code. And this is incredibly important because while in manufacturing, we make a lot of stuff, I actually believe we don't make nearly enough stuff. In the OECD countries out there, there are over 400 million people involved in manufacturing today. And collectively, that's a workforce that produces a lot of goods, but so much goods that frankly, less than 1% of the world can live the way that we do. So imagine for a moment if we wanted to raise the standard of living for 20% of the world. So 20% of the world could live the way that we do. To do that the way that we do it today would mean that you would need to involve every single human being on the planet in manufacturing. If you wanted to raise the standard of living up so that 100% of the world enjoyed it, it would be impossible doing the way it is today. So this is why it's so critically important that we have a standardized platform and easy-to-use tools that empower manufacturing experts to solve the complicated problems that they face on a daily basis. And the robotics industry is poised for massive growth. As I said earlier, there are about 400,000 robots sold per year. But if you look at the adoption curve for PCs, that places the robotics industry roughly in the early 1980s, which means that there is tremendous opportunity for growth. But there are complicated problems that need to be solved by end users, by manufacturing experts, by developers. And this is why I am a firm believer, a deep believer, that to really solve these type of complicated problems takes a village. It takes a village coming together. You know, Ready has a part of the solution. Edge Impulse has a part of the solution. Balluff, one of our partners, has part of the solution. And really coming together, we can provide the tools to the manufacturing experts out there so that they're able to leverage machine learning and robotics and automation and all sorts of other solutions to solve the extremely complicated problems that they wrestle with every single day. And by coming together like that, coming together like a village, we can usher in the fourth industrial revolution. We can usher in a new era of intelligent robotics powered by ML that can raise the standard of living for everyone out there, that can usher in a new era where humans are less at risk in manufacturing environments, where supply chains are more resilient because you can more effectively make things locally, where we can raise the standard of living for everyone out there. So I'm standing up on the stage today to say, please, come join us, and together, let's make the world a better place. Thank you.
Thank you, everyone. We will be breaking for lunch now. We will put up a schedule on the screen so you can see the rest of the schedule for the rest of the day. We will return from lunch at 1:10. Please return at 1:10. Thank you.
Ladies and gentlemen, 1 minute and we begin the show. Welcome, everyone. We're starting again, and we have Mallik Moturi, Chief Business Officer at Syntiant.
Hi, everybody. So, I'm the Chief Business Officer at Syntiant. My name is Mallik Moturi. Today, I'm here to talk about and actually discuss the topic of why we need neural native processors and what are neural native processors. I'll be kind of hone in on that a little bit, and why they're really necessary for enabling these deep learning on the edge. Okay, and I will also at the end talk about how, because of these neural processors or neural decision processors we call them, we are able to enable we enabled 20 million devices with our chip in the last less than 2 years, and how, along with Edge Impulse, we have been able to enable more than 1,000 customers with many, many thousands of projects, and all in the last year with Edge Impulse. So this is my topic and what I want to talk about. So the focus of Syntiant. So why do we do what we do? And what do we do, right? So why do we do? So what we started off looking at was, if you look at the keyboard, it's an interface that humans used in the 80s, and even today we all use it. but it's still about 150 million units a year are sold with keyboard. If you look at the mouse, in the 90s, it grew the number by, to about half a billion users and units per year. And now we see that with the enablement in the late 2000s, mid 2000s, with Apple, the touch really enabled another 3x increase in the user interface with about 1.5 billion units per year. And what we believe is the next phase or the next interface is going to be this natural interface where you're going to bring all these kind of sensors of motion, smell, temperature, those kind of sensors, and bring them into a natural interface where humans can interact with, along with audio, acoustic events, and speech, and voice, and vision, right? So these are all sensors. These are all the real world things, and how do you bring those into the digital domain? So that's the natural interface, which will be, I think, much more something in the tens of billions of units. So that's what, why we do what we do. And what do? We bring deep learning to the edge with these purpose-built neural decision processors. So let me talk a little bit, give you a story about how we got into this and what are the requirements. So we spoke with customers when we started the company saying, what do you need? So we spent a lot of time with some hearing aid companies, mobile phone companies. They said, well, first of all, some of them would say, oh, privacy is a big deal. I cannot send anything to the cloud. I want all of this processing to happen right on device. Other one would say, or they would say, it has to be, very quick. The interface is it cannot be slow, or high reliability. And these are things you heard, but there's one thing which we heard across the board was it has to be energy efficient while doing all these kind of processing today, which we are sending it to the cloud. So if we are doing speech recognition or doing some audio sensing, that cannot go to the cloud. It has to happen. Processing has to happen on device. So energy efficiency was important. So all the success depends on bringing all this together. So what is driving deep learning on the edge? There's a big market. And as I said, we sold 20 million chips or different domains. But it's only scratching the tip of the iceberg. If you look at the amount of opportunities where you need these rich and robust natural interfaces across from mobile to consumer to enterprise, every use case, I'm receiving all kinds of customer interest for all our product line. We have now we are into the second generation, moving into vision. But I'm getting interest from them across all of this in areas that I even did not imagine in the past. What's enabling this, what is driving this, is also the tools and infrastructure. I said all of this is moving from the cloud to the edge, but at the same time, the infrastructure of the cloud, the amount of GPU and the availability of that infrastructure is enabling it. And the tools like what Edge Impulse has built for AutoML are really enabling it because it really helps to democratize the ability to use AI. So we have this TinyML board that I'll talk about in a bit, which is Edge Impulse enabled, and we get to see thousands of customers using it every day. So MLPerf and the other areas, these consortiums like TinyML ML Commons, the TinyML Foundation, which have really done a great job at boosting this thing, including the benchmarks that they're creating, that we are also executive sponsors, and we promote all these things, right? So let's now just get a little bit lower into what are the challenges that we see in deep learning on the edge. So this is really the key points here are, to build these kind of, bring it down from the cloud to the edge. Unlike data centers, these edge devices have very limited access to power, and operation is all very low power battery operated devices, power constraint. And then in the cloud, you have immense amount of memory and computational horsepower, but you have limited, if you went to do the same way you did compute using a CPU on device, then how do you access that amount of compute, right? And then size. All these devices, like for example, I mentioned about hearing aids or phones or mobile devices, these cannot be, these have to be very small. And that means not only that, when we talk to the customer, they would say, these things are important, but also the cost has to be low. So that means the size has to be pretty small. So we need a new type of processor. We cannot build this immense processing power required in the edge, which would move that stuff into this edge device using same amount of processing that you have in the cloud. So we needed a new type of processor. And that's what we ended up building. And here's a simple kind of analogy of why power constraint is such a critical piece. So if you look at an example of the incandescent bulb, right? It's extremely high energy, it's not amount of power required, it's energy inefficient. But, and then you burn a lot of energy and you run it for if you want to run it all the time, like in the cloud. On the same way, the LED, you can leave it on all the time, and there is really, the example is here is, you can be, almost like, almost no power, or you can, it's just very, very little power compared to the, you can even harvest energy from the environment and power LED. But at the same time, deep learning requires an immense amount of processing for instance of time when you're doing inference. We're not doing training, we're just doing inference. And that is like example here is a camera flash bulb going off. So instantly it has to go off, at the same time consume very low power. So if you can reduce the amount of time that you actually you run this energy, then you have a solution. So now I want to give you the key here is I'm kind of giving you the formula of why we were successful in building our devices. So many of you electrical engineers are very familiar with this equation of how power is half CV energy is half CV squared and multiplied by frequency. And then, and then more in the device physics, you'll know there's a static power consumption. So you added, if you look at these 5 variables on this formula, these 5 variables, including reducing the switching frequency, that can be achieved by very clever design, or total capacity, and gives you a quadruple, it gives you a quadratic saving in power. So you can run, if you want to run it at low frequency. You want to reduce the capacitance. If you have a good designer, you can design it such that you have a low capacitance. And then the supply voltage with process, you can work with low voltage nodes and reduce. So all these are good, but there's one secret factor that you need to manage, which is the activity factor. If you look at the activity factor, that's actually our favorite thing that we handle, but where it actually determines how many bits are toggling, how much data is actually moving. So if you can compute at memory, or very close to the memory, you do not need to move the data around from one outside memory or internally or externally. So then you can actually reduce the activity. On top of that, if you can take a neural network and segment it into different parts. I told you there's a neural, natively neural, and move it around so you can actually run the network in different domains while you're doing different workloads. And so turn most of it off so it reduces the activity. So this is the secret for optimizing and keeping the power consumption low, just like in an efficient LED, but just reducing the activity factor and then increasing the power, increasing the efficiency of the chip. So this is a key formula that we use. And this actually, the result of this, I told you there were 3 areas. One was power, the other was memory and compute. It actually kind of solves a lot of those issues. So we solved the issue with bringing the memory and the compute close together. Very high efficiency multiply and accumulate, which is a key for deep learning. And that one we get to 80% utilization because of the architecture, our custom architecture for doing this. This is the secret of what neural decision processes have. The other is the natively we process the network. So You do not need another intermediary compiler to go from TensorFlow, for example, to our device. You can go directly on it. And then we have this tightly coupled memory and multiply and accumulate. These are all, so the dividends it gives us is huge. If, for example, compared to an A53 or an A55, for that matter, at a gigahertz, you will have at 1% of the energy and running it at a low frequency. All of these things I was talking to you about earlier actually helps us. So we get an advantage of being able, just to give you a big picture, 6 milliwatts, we can do an image which analyze what is in the image compared to what an A53 would take about a watt of power. So other thing that we get out of this kind of very close collaboration, close design principles, using these design principles are the size. Size also, we can build a large network, which is probably one of the largest in this power and this size, and we can do all of those neural network-based sensor interfaces, vision, audio, image concurrently and with very high efficiency in a small footprint. Like our NDP-115 neural decision, NDP-115 is about 2 by 2 square millimeters, and the NDP-120 is about 3 by 2.5. So it allows us to build these efficient small footprint devices. So what does this actually mean for customers? As I said, we have shipped millions of devices. So that actually the first thing that our customers loved was the size, the power, and the cost. And that allowed us to ship a large number of customers. Then before Syntiant, you were more like tens of milliwatts to do the same function. So for example, speech recognition would be about 10 milliwatts even on a low-end MCU. With our last year, and then we will build devices and boards, and so what NDP 101 enabled last year, we, along with Edge Impulse, launched the Syntiant Core 1 based TinyML board. It was smaller, lower power, and more efficient than anything before that. So last year we launched it, and within the last 6 months, we have seen thousands of users jump on the board and lots of use cases that they have, projects that they launched on the Edge Impulse platform. So that was last year. So this year, we are launching, not yet publicly announced, but there is another device, another even smaller, and with the next gen Syntiant Core 2 that we are launching very shortly, which will have, additionally, we will be processing image as well as speech and sensors. So this is what we are doing, and this is pushing the envelope thanks to the collaboration with Edge Impulse, with us building these next and better and better neural decision processors. So in summary, deep learning on the edge has many advantages. We have to find the killer app and, of course, grow the volume of number of chips that we can sell as we are a semiconductor supplier. But we also are looking at how it helps and empowers a large customer base to users to use it. And, but it comes with its own challenges because we build the neural processor. At Syntiant, we have dedicated to kind of keep pushing that envelope with the Syntiant Core 1, Core 2, and the Syntiant Core 3 coming in the next year. So that's my end of my talk. Thank you so much.
Hi. Good afternoon, everyone. My name is Mitsuo Baba. I'm a Senior Director of Renesas Electronics. The purpose of my presentation today is to talk about our AI MPU. Our AI MPU is now ready for AI application that enable social implementation. This is Renesas RZ family. I'm very glad to be here. Let's get started. there is a change in market dynamics. Intelligence moving from cloud to IoT edge and endpoint. So investment is embedded computing at IoT edge and endpoint is now growing. Please take a look at the graph on the right. We estimate the AI MPU market will expand rapidly like this. CAGR is about 40%. Here is just a big business opportunity many people are interested in, isn't it? And as you all know, there are many AI applications, sensors, and sound, and voice, and HMI human-machine interface, and image and vision. Many AI deployments on embedded MPU, MCU have just started. For example, of common use cases, failure prediction, and object recognition, vision AI. All implementation is accelerating rapidly in the all market. And one more thing, AI applications continued to expand. Until now, from object machine-centric to, from now in future, to human behavior-centric, such as a pose estimation application. AI applications are evolving toward a higher performance. And diversification of AI will accelerate it further. Higher performance and diversification. So, in the future, it's certain these three trends in the embedded AI, diversified application and higher performance, the new AI models, and human interaction as a new service will further accelerate. So there are three key requirements for deploying AI applications. Three requirements are flexibility and power efficiency and real-time operation. All three of these are necessary, but power efficiency is the most important and difficult requirement. Okay, this slide explains why power efficiency is important. Heat, based on the power consumption, is a challenge for embedded AI. Power consumption can be expressed like this as AI operations multiplied by power efficiency. When power efficiency is low, power consumption, heat goes hot. Dissipation system must be needed. Installation cost is high and fan noises occur. This is the barrier of a social implementation. When power efficiency is high, power consumption, heat stays cool, so no need heat dissipation system. AI application can be installed in various systems in all markets. No need dissipation and the cost and size can be reduced. So again, heat issue is the toughest challenge from POC to the social implementation. Power efficiency is the most important requirement. Yes. Thank you for waiting. Renesas embedded MPU solution RGB series is ready now. Today, I'd like to introduce Renesas embedded AI MPU solution that solves all three requirements. Flexibility is okay, and the power efficiency is okay, real-time operation, okay. And our solution also maximizes your competitiveness in the innovation. Our MPU, AI MPU is the RGB series. Before explaining RGB in detail, let me briefly introduce the entire Renesas' broad and scalable product portfolio. This slide shows. We can propose a full system solution that combines the multiple products. Not only MCU, MPU, and SoC, but also analog, power, sensor, and connectivity. Okay, let's move on to MPU, RZ family. Here is the overview of RZ family. From target applications aspect, we have 5 series. HMI application, RZA is for RTOS, and RZZ is for Linux system. And for industrial networking, RZN, and real-time control application, RZT. And AI application, RZV series. Let me give you features of RZB series from next slide. This slide shows the RZB series product lineup. Currently, there are 2 products, RZV2M and RZV2L. But a new product will be announced soon, tomorrow. Please check it out, tomorrow, new products. And we are also developing a next generation product for their more high performance AI, such as the robotics market. And RZV2L has a unique features pin compatible with RZG2L HMI products. This pin compatibility enables customer product expansion easily to improve UX, user experience. Okay. This slide shows a block diagram of RZV2L. DLP and ARM CPUs are in the core, and there are various interfaces that connect to the real physical space. In addition to the camera, of course cameras can be connected, it's possible to handle various sensor information as a multimodal AI application. Okay, these are new AI applications I talked about first as a high-performance AI application, new applications. Please look at the performance of Renesas' AI MPUs. These are not catalog spec, but the actual AI performance on our AI MPU RZB series. Again, RZB products are now available. Human behavior-centric port estimation with mulch people, and also abnormal, dangerous behavior detection, also available. The differentiating performances of these demos are based on our core technology. AI accelerator, DRP-AI. DRP means a dynamically reconfigurable processor, DRP. This is a Renesas' in-house AI accelerator. We have over 20 years of experience in this technology. DRP-AI provides flexibility while not sacrificing performance or power efficiency. And DRP-AI is one of the software-defined hardware. So can design easily as a software manner. And with implement Oniki's standard interface. Please visit the Renesas website for a detailed explanation of our DRP-AI technology. Okay, now we are ready. Easy to get. You can get real board solutions easily now. Renesas evaluation board kit can be gotten here, left side, and AppNet Raspberry Pi form factor board also available in here, is here. And more solutions are also available on the Renesas website. Please check these out soon. And E2E, end-to-end ecosystem, is also ready. It's just easy to use, from AI training data collection to deployment on MPU products, AI development tool, platform, or pre-trained AI models, something provided from RZ partner ecosystem solution. Yeah. Edge Impulse Studio is here. With industry standard interface ONNX, Onyx, end-to-end ecosystem connect seamlessly to back-end tool. Back-end solution is provided by Renesas. We provide 2 demos in March 2022. About the Vision AI application with AI MPU, RZ with L, 50 objects, 160 frames per second, and only 3 watt power consumption in system level. Please visit Renesas booth and get in touch with our out-of-the-box solutions now. Okay, I'd like to summarize what I have said today. Renesas RGB MPU provides flexibility, power efficiency, and real-time operation. Renesas end-to-end AI solutions are ready to enable social implementation, easy to get and easy to use. RZ MPU contribute to your innovation at the edge and endpoint for various applications in all diversified markets. Please visit Renesas booth for in-person deep dives with our experts. Stay tuned on our RZ MPU products. Thank you very much.
Good afternoon, everyone. I'm Omar Oreifej, Director of Computer Vision and Machine Learning at Synaptics. I'll be talking about computer vision techniques for reducing the data collection pain. Synaptics is a semiconductor company. We have multiple products with integrated NPUs. My team in particular focuses on designing solutions for low-power AI at the edge with applications for home, workplace, industrial, mobile, and auto. And we've recently developed CNN models for our latest low-power SoC that's called the Katana. On the right, the top right, you can see the architecture for Katana, and most important part is the NPU, where our CNN models will execute. On the bottom, you can see 4 models that we designed for Katana. The first one from the left is the overhead person detection. Here, there's a camera mounted on top of a door and capturing images of people while they enter and exit the room. And the neural network model will consume the images and detect the people in them. And this is really used for people counting applications. The second model here is a meter reading model. It's basically based on a camera that's mounted in front of a meter and capturing images of the digits. And the model will consume these images and will detect the location of the digits and will recognize them. So this is really useful for converting an old, outdated, non-smart meter into a smart meter with the connectivity. The third application here is the fallen person detection. Here, the camera is mounted on top of a ceiling and capturing these pictures, and the neural network model is classifying every frame to decide whether there is a fallen person in it or not. So this is really useful for ambient assisted living applications. And finally, here the face detection. Here, the neural network model is detecting the faces up to 7 meters, and this model is really useful for smart home applications. And so in designing these models, so many components need to come together in order to produce a successful CNN models. And I'll be talking about the data component, which is one of the major components. We know that we need thousands of representative examples to produce a successful CNN models. Why? Because the network needs to learn how to generalize to many conditions, backgrounds, scenarios, people, ethnicities, and so on. And well, you can use public databases for that. You can say, oh, I'll go use COCO database or ImageNet and so on. And you can do augmentation and domain adaptation. But that works well for standard computer vision problems. And once you are talking about a specific application, you'll find that they are limited. So for example, for the overhead person detection problem, we said, OK, let's use COCO database. But then you quickly find out, well, there are no overhead images in COCO database. And it's not using our target camera. Our target camera is a cheap, low-power, well, noisy camera. And the images in COCO cover a large spectrum, but very few examples may fit this problem. And so you quickly will realize that, well, we need to collect and annotate. I'm sure you guys are all familiar with that, and that takes a long time and effort. And this talk will highlight some simple techniques that we applied in our neural network development journey to reduce the data collection effort significantly. So I'll go over 4 of them. One is called background blending. So for the overhead person detection application, well, we needed a lot of images of people in a diversity of backgrounds and conditions. So in order to facilitate that, we blended a small amount of annotated images with a large amount of background images, because background images are easy to acquire. And so this is an example. So on the left side, you have an input image. On the right side is a target background image. So our goal is to blend the person with this background. And so simply we take the annotation that we made for that frame, and we create a blending mask, which is centered on that box. and fades out as you move away from the center of the box. And then we just blend the input image and the target background image, and we get an image that looks reasonable. It feels like the person is now in that new environment, the target background image. So with this simple approach, we improved the generalization of the method significantly, actually, and now it works outside of Synaptics offices where all of the training data was collected. All right, so I'll move to the next technique, which is body segmentation. So for the fallen person detection application, we needed images of fallen person, again, in a diverse backgrounds and locations. And so instead of asking people to actually fall on the floor, we asked them to lay on the wall, lay back on the wall, and we segmented the body of the person automatically and produced synthetic fall images. So on the left side here, you can see the original image. This is actually myself leaning against the wall. And we can automatically, with a neural network model that's trained offline, to do the segmentation. And then we cut out the person and place him in any background, desired background that we would like. So that's the third image here, the final synthetic fall image. The last image is a real fall image, so you can see that they are very similar. And so with this approach, we were able to produce a large amount of fall data without actually falling. The third approach is annotation transfer. So in the meter reading application that I mentioned on the first slide, well, we need a large amount of images of meters and corresponding annotations with the digits, 1, 2, 3, and their locations in the image. And in order to facilitate that, we designed an approach that is allowed us to only annotate a reference frame and transfer all the annotations from the reference frame to all of the other frames. So I'll go in the details of that. So initially, you take the meter physically, and you place it on a synthetic background that's rich in texture. And the reason you want a background that's rich in texture is that later we'll be detecting what's called the interest points or feature points, if you're familiar with classical computer vision. And we picked this nice picture, but you can basically design any background that you like. If you want something with synthetic interest points, that works too. And then we send a random digit sequence to the meter, and then take the camera and move it around in different poses and distances, and save that video and the digit sequence as a label for this video. Now, next we need to annotate the digits in the video. Basically, we need to find the locations of these digits and their label in each frame of that video. So how do we do that? We pick a reference frame from the video and actually annotate it with the digits shown in blue here, and a mask, which is shown in red. All right, this mask determines the region of the digits, so we'll use that later. And then we compute interest points. If you're familiar with SIFT, for example, you can use that, or any other interest points. We compute interest points on the reference image in all of the target frames, right? And based on these we match these interest points between the reference image and every frame. And based on the matching result, the matching is done with a RANSAC algorithm. Based on the matching, you can compute a homography transformation, which you can apply to warp all of the interest points from the reference image to the annotated image. So we can then warp the annotations from the reference frame to the target frame, as well as the mask. And then we can use the mask to remove this synthetic background that we applied and add any desired background that would be representative for your application. So with this approach, the entire data collection and annotation was reduced to a few minutes. Of course, that's after writing the code to do the transfer. All right, so the final approach that I'm going to talk about is called camera mapping. So here in the face detection application, we needed to detect faces using a low-resolution camera, and the appearance of this target camera is different from the regular RGB images that you find in public databases. And so instead of collecting training data from the target camera, we decided that we can process the publicly available images to map them to characteristics that make them similar to the target camera. And so these are the operations that we apply. We control the aspect ratio, change the images to grayscale, we change the tone mapping, we add lens distortion, and change the resolution, the sharpness, the noise, and we change the dynamic range. And so this is, on the left side here, you can see an example image from wider face data set, which you can use for training face detection. And then after applying our processing, we get the image on the right. So you can see, for example, the lines, the straight lines on the track are now curved because of the lens distortion model that we apply. So if you use the public data sets directly for doing that facial recognition detection, you will get 73% average precision, but when we apply our technique, we improve that to 79%. In conclusion, we presented techniques that greatly reduced the data collection effort and resources. They enabled us to develop accurate neural network models with short amount of time and deploy them on Katana. And as a next step, we are exploring more advanced synthetic data generation methods. Thank you.
All right. My name is Henrik Flodell. I'm Director of Marketing at Alif Semiconductor. And my talk today is essentially asking myself a question. And I'm going to start the talk by answering the question, just so that we can jump right to the end, because that's usually the exciting part. The question is, can machine learning be fast and low power at the same time? And the answer is yes. You can actually pick two in this equation, which I'm going to show you kind of how we achieve. And some of the things that I'm going to talk about you've heard mentioned in some of the talks that were before me. But just before I get into it, since we are reasonably new, Alif Semiconductor is a semiconductor supplier, general purpose microcontrollers. You can think of us in the same way that you think about other companies where you go and buy your MCUs, MPUs, those kind of things today. The thing that we do a little bit different is that we have really worked very hard from the ground up to try to make our devices very intelligent and very densely packed with functions that we know that the designers of embedded systems will need in their systems. So instead of just providing a core and some peripherals, we want to put as much as that as possible of that into the silicon that our customers get from us, just to help them design their products faster. Essentially how we do this is that we provide processors that enable a very scalable continuum of performance that goes all the way down to single core microcontrollers, highly optimized for ultra low power consumption, and scales up from there to multi-core devices that combine MCU cores and MPU cores on the same die. So you can run real-time tasks in parallel with embedded Linux in the same chip. We have spent a lot of time and effort on engineering our silicon architecture to enable long battery life for applications. Everything that we do is kind of designed on a foundation of ultra-low power type processing, and we carry that with us as we move up the performance continuum that I mentioned with the scalability. So there is ultra-low power to be had at each of the performance points that our devices cover. We know that microcontrollers tend to be used in connected applications today, and they are also used in a lot of contexts where the data that they process need to be kept secure. So we have also integrated some very strong security from the ground up, again, in our devices. In fact, we integrate a complete secure element implementation in our systems to protect the data on the device, the data in flight if it's participating on a network, and to provide security services for the code that is running on the various MCU and MPU cores. We integrate a lot of functionality besides the processing in our devices as well in terms of peripherals, integrated memories, both RAM as well as non-volatile memory. We've taken the approach that we want to try to include as much of this as possible in the device itself so that users of Alif technology don't have to go outside our SoC to put their system together. And we have based our silicon architecture on manufacturing technology that allows us to create very small packages, even though we do integrate all of this functionality. And the final thing that we did when we sat down and kind of looked at what we wanted to achieve was to try to look, 2 years, 3 years, 5 years from now, how are the developers going to want to solve their problems? And when we went and talked to customers, they told us that we find machine learning fascinating as a topic for a number of different reasons. The two main ones was either I'm solving problems in a certain way today, and I believe if I had access to efficient machine learning in a microcontroller, I could improve the efficiency of the way that I do this in my current product. And the other one was, I had this idea for a product that doesn't yet exist, but I can't find a device that allows me to do the machine learning that I would have to employ in order to solve the problem. So that was something that we really wanted to integrate as well. And we realized that if we are able to integrate this, if we're able to cover also the machine learning aspect, we actually improve the scalability because we can offload the machine learning processing to accelerators that can handle that. So we get even better scalability. We can improve the battery life because as soon as the machine learning processing is done, we can go back to sleep and the device won't be consuming power anymore. And also in terms of the security, if we can keep the data on the device, we improve the privacy for the system in general. So we've created a lineup, and I'm not going to go through the full specs of what we're doing. We're at the expo. You can come visit us so we can talk about it. But we have a lineup of devices, like I said, at scale from single-core MCUs to dual-core MCUs. And we have something that we call a fusion processor where we combine MCU cores and MPU cores, triple-core devices and quad-core devices where you have 2 MPU cores operating symmetrically, and then 2 real-time cores in the system as well for those kind of tasks. We use ARM-based technology. We've tried to, as much as possible, keep the IP that we're using on the application side of our devices, let's call it standardized, right? So that people, when they pick up an Alif device, they know what they get. It fits into their standard workflow. They can use their standard tools to work with it. And it also helps improve the scalability because this is kind of well-known quantities. People are very familiar with ARM-based architecture today. We did the same on the machine learning side. We've taken the Ethos U55 micro MPU acceleration units from ARM. We actually have multiple Ethos U55s in our system, depending on where on the performance continuum you land. And they scale all the way up to 256 max per second in terms of operation. And then on the MPU side, we employ these A32 cores that can go all the way up to 800 megahertz. So it's an amazing amount of power, just compute power, in a very, very small package. The size of the largest device in this series, the E7, is about 6 by 7 millimeters, and it goes down from there. What we're doing, so to kind of get back to the topic at hand, to combine machine learning and low power consumption, we set up an architecture for our system where we have essentially divided the device into domains and operating regions. And these smart domains that we've created are separated depending on which functions that each domain perform. The domains can be independently controlled, switched on and off, and we also have some IP in the device that we have designed that can help developers essentially power down a domain when it's not being used by any code that is running in the system. So it kind of autonomously handles that. And then in terms of the regions, you see here in the graph, there's kind of three main bands of regions. There's an always-on region. You will always find that in a microcontroller. Whenever you put it in the very lowest power mode, some things need to be active so you can wake it back up again. What we did that is a little bit unique is instead of having that A-on region and then go to the next step, which is now everything comes back on, we implemented a dedicated high-efficiency region in our devices, which is a separate compute environment with a separate machine learning accelerator, a separate microcontroller core that can be kept awake, but is instantiated using the most efficient silicon processes that we can employ. So you essentially have, we call it the sniffing engine, something that can sense the environment around the device and operate with machine learning capabilities, if so chosen, but maybe a lower fidelity model, something that is not as compute intensive as if you were to, say, be able to detect a specific person. It can detect that it's a humanoid shape that is approaching. So you can have this high efficiency region operate, and it can sense the environment around the device. And when it detects something that crosses a threshold and triggers a need to do a more in-depth analysis of what is going on, it can wake up a high performance region that contains essentially the rest of the system that will be able to go in, do that in-depth classification, and come up with a very detailed result, and then take an action if that is warranted, depending on what the situation is. We started collaborating with Edge Impulse about a year ago now. It was just around the time of the last Imagine conference. And once we had worked with them long enough to get full support for our devices into the Edge Impulse environment, we started running some benchmarks because we've seen some really impressive data kind of on models that we've designed, that some of our software partners have designed on our silicon. And we just wanted to compare with some of the tutorials in the Edge Impulse system with what you see when you run that on the Ensemble silicon. So for these two graphs here, we're using the responding to your voice tutorial that is in the Edge Impulse framework, and we've kind of indexed the results to what we saw when we ran this tutorial on the high-performance MCU core with its ethos accelerator. We indexed that to 1, and then all the other numbers you see is how many times more it took to run it on those platforms. So high-efficiency core 2.8, so it's slower, but comparatively not by much. The thing that is kind of standing out to me is the fact that we're 115 times faster than a Raspberry Pi 4, and that's a beast of a device, right, compared to an MCU. Same thing with adding sites to sensors. So this is kind of the vision use cases, and it was always difficult for microcontrollers to go down to vision. Voice, kind of okay, depending on what it is that you're doing. Vibration, yeah, they can handle that. But vision becomes difficult in MCUs. When we run this tutorial on our high-performance core, we can go up to above 700 frames per second of throughput. The high-efficiency core is slower, but again, the Raspberry Pi 4, significantly slower than both. So we really have been able to architect a system that can take machine learning and execute that at a tremendous pace, and then we have the microcontroller cores to do all the other tasks of the application available. So essentially answering the question, yes, it is very fast, and with that speed comes power efficiency, because this is kind of a comparison of a demo. We actually have this demo in the expo. This is MobileNet V2 running on our Ensemble device, CPU bound and accelerated. So you see the inference time when we're running it on the CPU core alone, it's about 2 frames per second when we're doing image inferencing. Doing audio inferencing, it's faster, but it's still a lot slower than when we turn the M55 on. So we dropped the inference time from 624 milliseconds down to 8. And because we can finish it that much faster when we have the U55 on, even though in that moment the power consumption is higher because you have 2 things running in at the same time, the energy that is consumed by the operation drops by a factor of 75, right? You go from 228 to 3 millijoules in the system, and that means in the long run, you save a tremendous amount of power. We've done a whole bunch of these kind of math exercises and use cases for various applications. This is for a peel and stick type camera for kind of a home alarm system that has a duty cycle where it needs to sense what's going on around the camera for some interval. And then every once in a while, something will happen that will require our system to wake up the high performance core to do more advanced processing. And for this duty cycle here, and I mean, all the duty cycles are different, right? But in this one, you see that we can take the power consumption over a 24-hour period down from 240 milliamps down to 9. So 27x longer battery life. That's pretty good for a very integrated microcontroller system. We have demos in the expo to show you this. We have more information about the lineup of our microcontrollers, what they can do. I'd love to talk to you about what you would like to do with a device like this. There's also more information on our website, alifsami.com. Come visit us. Thank you.
Hi, everybody. My name is Armagan Ibrahimi, and I am a solutions engineer from Sony. I'm here today to present Espressense. Espressense is a microcontroller, and basically, I'm going to focus more on what is Espressense, what feature it has, how you can develop with it, and then at the end, I'm going to tell you how we are partnered with Edge Impulse, and it helps us with the AI. So to just give you an idea what's going to be covered in this presentation, I'm going to talk about the Espressense microcontroller, so you will learn about the spec, features, and everything, development, as I mentioned. And then I have two new components that we recently added to Espressense family. One of them is the LTE board, that's the connectivity. The other one is the HDR camera. So this is going to, let's start with the Espressense microcontroller. I usually use this page in most of my webinars. If you have listened to any of my webinars, you have seen this. But every time I say something different. So let's start with this. Espressense has 6 ARM cores, and that is a M4F, 156 megahertz of clock. Espressense has high-resolution audio, and also it has GPS integrated in it. It doesn't need antenna. It's already there. And also, I told you it has how many cores? It has 6 cores, but it's very low power. You can develop your application, leave it in the wild for 6 months on a dime-sized battery. If you need to know how to do that, let me know. I send you the instructions and the whole project, how to do it. So if you look at the table that I have here, it gives you a little bit more detail and a spec about Espressense. I told you about the ARM Cortex, but we have the SRAM is only 1.5 megabyte, and then you have access to digital IOs, GPIO, SPI, I2S, I2C, and UART, PWM, and all of this. And if you need to access the analog input, we have 6 channels, that is 3.3 volts. And let's talk about audio. I told you this is high-resolution audio. High-resolution audio means in the factories, you want to listen to your machine and see what's happening. This is your solution. So audio gives you 8-channel digital and then 4-channel analog. GNSS, Global Navigation Satellite System, is available on Espressense. So any kind of application for transportation, logistic, drones. So, and at the end, we have the camera interface. I show a better picture, but it's very easy to attach the camera. You have an SD card for external memory, and then access to I2S. Before I move on to the next slide, so this is very low power, and also you have 6 cores. So think about applications that it needs a lot of processing, like image. Now we see a lot of projects, good projects that we are doing, that it needs that many processors. So ExpressSense is suitable for that kind of applications. Now, briefly, I'm going to touch on this because I know a lot of skilled and talented people are here. Some of us are expert in AI, like Edge Impulse, and then some, they know the MCU. Some of us, we are looking for solution for IoT. So I'm just trying to cover just the base for development for ExpressSense. Here you see three different colors. This is the three different sections. So the bottom section is your hardware. As you see, we have the 6 cores, and then we have the SRAM, and then each of those DMA and others that you need to have at the hardware section. And then if you look at the middle section, that middle section is your OS. What we are using for ExpressSense is a microcontroller. We are using Nutex for ExpressSense. And then on top of that, we go to a little bit high level. We are supporting Arduino libraries. We work with Google, so we have, for the previous, we have TensorFlow supported in the ExpressSense SDK. And also we have Edge Impulse, we have CircuitPython support, and other third parties for ExpressSense. So this is briefly to tell you how you can get a feeling of development with ExpressSense. Now I would like to show you the boards, the components, to get then you see what is the size, and if you have application with a specific needs, then you get a better idea. The one that you see in the middle, I don't know how to point to that, but okay, that is our main board. That is the brain. Everything is happening. That's the 6 cores that we are talking about. To support that, we have the extension board. You see on the top page on the left side of me, I think it's going to be right side. And then we have the camera board. So this is the ExpressSense kit. This is a production board. This is what you can put in your device and send it out there. And then you have the extension board to make the prototyping faster, and it gives you some access to put other Arduino, for example, boards on it. And also the camera, as you see, camera is very easy to attach it to ExpressSense. Let's go down. Look at the HDR camera and LTE. These are the 2 new components that we added to ExpressSense family. IoT, we need connectivity. Well, there are other solutions. You can put a Wi-Fi on ExpressSense, but we specifically built this extension board for ExpressSense. So when I say extension board, the one that I talked about before, so that one has more access, like more channels for audio, or you get more access. But here you get connectivity plus all of those. So based on your application, you can use this extension board. I will give you a very brief overview of the characteristic of the LTE board. The camera, the new camera is HDR camera. And this one has the better features for example, night vision, which I'm going to give you briefly the spec of that also. What I like to talk about is mainboard. Mainboard has 2 chips on it, 65602 and 65247. Each of this has a specific function. For example, if you want to do camera interface is in 65602. Why I talk about this? I mean, okay, because this is the board, this is the production board, and you can use this, but this 2 chip has been already used in smart headphones, smart Xperia headphones from Sony. So these are the chips that has been used already. And if, for us, we cannot support the volume less than 100K. So if you get to some applications, you are building some devices that it goes in that direction, I can help you, then we can provide you the chip. But here, this is the board, and it's not that big. You can create your applications for that. Here, this is another flexibility or another advantage that ExpressSense has, is an open source software. So it can accelerate your innovation. You can access the schematics. Everything is provided on our website, by the way. And you can create whatever you want. If you want to go in that level, you have the possibility. You can create your application and take advantage of this open source software as well. Let me show you another page that is very easy to develop with ExpressSense. So you can do fast prototyping. I know, you don't need to do soldering most of the time. You can just put a presence board in the middle. You can put your sensor on top or connectivity Wi-Fi on top. And then we have the extension boards, as you see in this picture down. So we have LTE, we have the extension board, and also we have a portable player extension board that you can use. So then you just stack this on top of each other, and you get the data, you have the edge impulse, you create your model, and then you are not happy with your sensor. Just take it out, put another one. No soldering required here. So that is another thing that it makes prototyping really fast. I know IoT market is going really fast. Sometimes by the time we want to create something, the market is ahead of us. So you can take advantage of this fast prototyping and create your applications and be on top of your game for the market. Now let me just go. I have the spec for my LTE and HDR. Then I can wrap up this basically this talk. For LTE board, we are partnered with Truephone and Soracom, and they are supporting our LTE board. If you need to see like what are the specification of our board, this is for the LTE board, we have a LTE Cat M1, and we are supporting narrowband IoT. And the size I'm presenting, I have a booth. If you come to the floor, I can show you the actual board. You can play with it, you can look at it. But for the application that you use is pretty good. So it's 45 millimeter by 50. And so you can have access to digital input and also other like the bands and other information. I just keep this for a little bit just for you guys to take a look and get familiar with our LTE board. So after this, I'm going to talk about our camera. The camera, I told you this is a new component for Espressence family. Is using the image sensor ISX019 from Sony. The advantages of this camera to the old one is this is a HDR camera. It uses the same, interface, so it's a CMOS 8-bit parallel. And I think basically the resolution is 128 by 96, about like 1.23 megapixel. And the size is pretty good, 28 millimeter by 28. And the other good thing about this, which is related to IoT applications, is outdoor. So you want to create something, put it in an agriculture field, or you want to put it outside watching a yard, or temperature is important. So this camera basically gives you that outdoor possibility. Not only that, let me show you some good pictures of the features that we have. If you look at these pictures, the top one, except the last picture for macro shot, everything is when you have the HDR on. So if you look at the bottom picture, you cannot see the first one. You cannot see the sky very clearly. But when you have the HDR on, you can see the blue sky with the clouds. For the night vision, the same thing. Actually, for the other camera that we have, this is all black. But this camera, if you put the HDR on, then you have the night vision, and you can get a good picture. For example, if you are watching a field, or if it's a security camera, or those kind of applications. And then also, one of the challenges that we have with camera is sudden light transition, like when you exit from a tunnel. You see in the bottom picture, nothing is clear. You cannot see anything, right? But the top one, when the HDR is on, you can clearly see the tunnel. And also the other thing is the macro shoot. For macro shoot, you can read the boxes. So some of the applications that you need to do some tracking for packages, this could be a good solution. By the way, I know we have Sony has a lot of image sensors, but this one is, the old one was $30-something, $35, and this is a new one. It's available at Framos now, and I think it's about 70, something less than 100, and it has all these capabilities. By the way, this has been used in the conservation camera from Edge Impulse that Zach mentioned at the beginning of this Imagine event, because it's very low power and also because of all these features. So they had good engineers from Edge Impulse. They did a study and they compare, and then they selected this camera over others. So we are very proud. I like that Edge Impulse is using it for conservation. So let's wrap up about Espressence. Why Espressence is good for IoT? Usually for IoT, we need a processor, we need a bunch of sensors, we need connectivity, we need AI, right? And let's see, what do we have? Espressence has powerful processor. It has 6 processors. It means that you can do everything at the edge. Of course, you can communicate with the cloud, but all of us know you don't want to, that's going to be expensive, that's going to be only one way. So for the recent application, we try to do everything at the edge. So with 6 cores, you can do a lot with Espressence. So not only is powerful processors, it gives you this edge computation possibility that you can use. And also is very power efficient. Most of the application is in the middle of somewhere that we can't charge them, we cannot plug them in the wall. So Espressence is very power efficient. Why is it power efficient? I had a full webinar about this. Basically, you can play with the sleep. You can put the part of the chip in the sleep and do other stuff if it's not needed. So you can control that, and it's very power efficient. On top of that, you have the board. You have access to camera. Camera is very easy to connect. We have a slot for that. We have high resolution audio. We have to take advantage of this in machinery. We have some applications that they put this in a tree, in trunk of tree, to listen to bugs. You know, because of the what's happening with the environment, things are changing, moving. Somewhere that we had the snow, we don't have it anymore, like Sweden. So basically, the insects are moving, and one of the problems that we have nowadays is our forests are getting attacked by different insects. And so one of the applications was like taking advantage of the high resolution audio. And then the GPS is drone. So you want to have we have a project that we are working with one of the universities for research, and they are sending drones to these canopies in the forest, that places that we cannot reach, like we don't even see. And they collect the data, and then they bring it down. So those places, they need to find a location. They need something that is very low power. They need to listen to all kinds of insects. They need to take pictures. So this is something that Espressence can help IoT applications that's suitable for Espressence. On top of that, I think when we have the LTE, you may use LoRa or Wi-Fi or others, but having an LTE board with audio out or have a SD card and all of those, it can give you the possibility to create, to target applications for IoT that you can, in your area, you have LTE access. At the end, I'm very, very happy that we are partnered with Edge Impulse. Why? Because we are not, maybe you are, but I'm not a data scientist. And that is a very complicated field, and I don't know if even if there's always something that in that field that you may not know. You may be expert in microcontrollers, or you have a very good vision to create an IoT applications, but but you can, so now with this partnership with Edge Impulse, you can create your model. How? You can collect the data, you can just do the test and do the training, and then also you can deploy that on Espressence. And 5 minutes, 7 minutes, that's nothing. So, and then all the new features like FOMO is also supported on Espressence. Sorry, I'm going over time. Okay. At the end, thank you so much for coming, listening to my presentation. Please come to my booth, and if you have any question, reach out, and I'd be more than happy to work with you if you need partner, if you have ideas, or if you are interested to learn more, let me know. I have very good webinars, so if you want to start with CircuitPython, NotX, whatever, let me know. I can share that with you. These are some of the information that you can connect with us and contact us. Again, thank you so much, Edge Impulse, for giving me this opportunity to talk about Espressence and this great event. Thank you so much.
Hello, everyone. My name is Isaac Sanchez. I am the Senior Partner Program Manager for Silicon Labs. In a minute, I'll go ahead and introduce our latest part, the MG24, and how we're driving machine learning with partners like Edge Impulse. I'm very excited to be here at Imagine 2022. It's my first time. I'm also very enthusiastic about the amount of machine learning enthusiasts here that are trying to grow this market space with us. So Silicon Labs, we're relatively new to machine learning. So for those who don't know us, we are a $1 billion pure-play IoT fabless semiconductor company. We focus on wireless solutions delivered through our silicon and software platforms by offering multiple protocol solutions as well as advanced security and integrated AI ML at the edge. We're trying to drive that further. As a pure-play IoT company, Silicon Labs has spent the last decade adding key technologies to grow and enable IoT at the very edge, such as low-power MCU architectures to have longer battery life for IoT end devices. In addition, I already mentioned we support multiple protocol solutions, but we continue to drive the adoption of new protocols such as Matter and Amazon Sidewalk. Silicon Labs also foresees the necessity for securing our IoT devices from bad actors trying to breach our deployed networks. Let's see. So Silicon Labs, we're going to continue to drive the machine learning at the very edge. In that same vein, we're trying to innovate and push the boundaries even further. So AI/ML has been available on cloud platforms for quite some time, but there are a number of factors driving machine learning to the very edge. Low latency is one. So for applications requiring sub-millisecond accuracy, machine learning is a huge benefit, and it's not something you can easily achieve when you're forced to send your data up into the cloud. Another improvement is increased privacy and security. So when you're able to keep the data locally on the device, you reduce the risk of sensitive data being breached through advanced cyber attacks. More so if you consider a fleet of wireless devices sending a bunch of sensor data, of course you're going to be able to reduce the amount of bandwidth on the network, and more importantly, reduce the cost of managing that data on a server space. In some cases, you may not even be able to, you may not be allowed to have data go to the cloud, further requiring the need for machine learning at the edge. And so Silicon Labs is going to continue to grow, and in order to enable some of those benefits, Silicon Labs released the EFR32 MG24 device. It is part of our Series 2 platform of devices. It is our highest performing EFR32 device in our portfolio, and it offers great RF operation while maintaining low transmit and receive currents, keeping it low power. It also has 1.5 megabytes of flash, as well as 256 kilobytes of RAM, making it great for Matter and other multi-protocol applications. So earlier I mentioned the importance of security and the IoT. So with this device, Silicon Labs became one of the first in our space to achieve a PSA 3 certification with our IoT security solution called Secure Vault. With Secure Vault, developers can go ahead and protect against hardware and RF attacks, while also ensuring that only certified devices are allowed to operate on their deployed networks. Of course, the MG24 includes a rich set of low-power peripherals that allows the connection of sensors, microphones, even low-resolution cameras. And of course, with these types of sensors, you can expand the amounts of AI/ML use cases you can perform. But more importantly, the MG24 is the first EFR32 device to include an integrated AI/ML accelerator, which is actually a multi-vector processor, or you might hear it called an MVP for short. And it performs multi-dimensional array operations such as addition and subtraction of floating point numbers on hardware, thus offloading the CPU from performing those computations in software. And when machine learning requires computations like this, and you're able to perform them on hardware, that translates to up to 8 times faster inferencing time and 6 times lower power consumption when compared to other Cortex-M devices. So here we have a benchmark of a Cortex-M and a Cortex-M with our hardware accelerator. You'll see some popular deep learning architectures listed here. And take, for instance, the example of the ResNet algorithm. With the hardware accelerator, you see that there's almost a quarter the amount of inferencing time. And this translates to lower power consumption because when you're able to spend less time in higher energy modes doing ML computations and more time in lower power sleep modes, the operational power required to perform ML is fractional. So if we talk about the quickest way to begin rapidly prototyping with the MG24, partners like Edge Impulse have integrated our dev kits into their workflow. So this means that IoT developers with traditional experience designing wireless connectivity, firmware, board layouts can now easily add machine learning as an additional feature to their IoT devices. And so what you see here is the XG24 dev kit. It has a number of sensors common to the AI/ML use cases, such as an IMU sensor, microphones, temperature, humidity sensors as well. And also listed is its predecessor, the Thunderboard Sense 2. However, that runs on our Series 1 platform with the MG12. And while both boards are very popular, we definitely recommend the MG24 for newer designs. One, for availability with the allocation issues, and two, for the increased performance, not to mention the hardware accelerator itself. So these boards support various amounts of tutorials out of the box with Edge Impulse, as well as some machine learning workshops that I put together myself. Most recently, we've done some workshops at Works With 2022, which is Silicon Labs' version of Imagine, in which we discuss the current use cases for IoT. But more importantly, the AI/ML hardware accelerator has been fully integrated into Edge Impulse's firmware examples. So that means that a developer using Edge Impulse can rapidly prototype a fully optimized ML model and deploy it to a dev kit. And so let's talk a little bit about what those applications are that Silicon Labs operates in. Here I've organized a couple of application categories by the potential amount of resources required to perform one. At the bottom, you'll see a suggested amount of RAM for using our SoCs, as well as the approximate amount of computations per second to perform the ML computations for that sensor data. So if we look at the sensor example, for instance, we're talking low bandwidth time series sensor applications. For example, conveyor belts have a lot of motors wanting to monitor vibration in order to detect early failures and overall monitor the health of their assembly lines. So an IMU sensor data application like that might require around 64 kilobytes of RAM and will roughly take 5 million operations per second to manage that data. Of course, with the complexity of the data increases, so does the amount of resources required. So you'll see with audio, when we get into applications like glass breakage sensors, it requires a little bit more resources. And then even more so when you get into voice recognition as well as wake word detection. I'm mostly blown away that we are at a point where we can do image processing on a Cortex M33 device with 256 kilobytes of RAM. And we're still talking low resolution images, of course, but that also opens up the applications to do object detection and image recognition at the tiny edge. And so this posed the question to us, just how resource heavy of an application can our MG24 withstand? Well, fortunately, Edge Impulse helped us answer this question with everyone's favorite acronym, FOMO, Faster Objects, More Objects. It's one of the more hilarious acronyms I've ever come across, so I personally like it. And that's what's depicted here. So with our XG24 dev kit, we were able to connect an ArduCam and start acquiring images of a crowded pathway and detect these people as objects. And using Edge Impulse Studio, we were able to build an ML model and deploy it to our dev kit. And with as few as 100 image samples, we were able to detect these people as objects and output image coordinates, as well as the probability that the objects detected at those coordinates are people. And we're outputting this via serial interface, as well as a Bluetooth low energy notification. So if we take a step back on what's happening here, by offloading the machine learning computations to the hardware accelerator, the MCU or the CPU is actually allowed to do quite a bit more. So if you come and check out our demo here, we will have the same thing running, but not only is it outputting these inferences via serial, it's also hosting a wireless connectivity stack. And if you see it, the actual SoC is hosting like a web service that outputs the video feed as well as the overlays of the coordinates. That's quite a bit for a cost-effective SoC as the MG24 to handle. And so if you go a bit further with that train of thought, ultimately you would be able to disconnect this from the cloud and, more importantly, save on the amount of data to manage that. You also increase the amount of privacy for capturing images of strangers in a pathway, detecting that they're people and counting them. It's not necessarily safe to have all of that data going across the network. But then there we have it. You'll be able to save on the economics of a full solution like this with a fleet of similar devices. So let's wrap up where that leaves Silicon Labs here at the tiny edge. We have combined machine learning with our leading wireless solutions. We are now supporting deep learning algorithms on our SoCs, and with our dev kits and third-party tools such as Edge Impulse, developers can rapidly prototype AI/ML use cases. And more importantly, with the AI/ML accelerator, when they build these models, they can push the edge. They can definitely do more to increase the complexity of the machine learning computations that they're doing, as well as optimize their tiny edge use cases to be more energy efficient. That's pretty much all I have for today, but if you guys want to know more about Silicon Labs and machine learning, you can go to scilabs.com/AI-ML. We'll also be hosting some tech talks if you want to get into the more specifics of the MG24 and see a few other demos as well. So thank you all for your time, and enjoy the rest.
Green button moves forward. Good job. Okay. So hi there. I'm Rob Telson with BrainChip, and I'm responsible for our ecosystem and partnerships. And today I'm just going to talk a little bit about BrainChip. So real quickly, BrainChip is the first company to commercialize a neuromorphic AI engine. And we've proven that in silicon in TSMC 28 nanometer. And a little bit more about our company is, we've got about 20 years of AI investment in research, and specifically thinking about it in a neuromorphic environment, with a very broad patent portfolio and centers of engineering in the US, in France, in India, and an advanced research center in Australia. What gets us excited are announcements such as this, where Mercedes chose to use neuromorphic technology in their concept vehicle, the EQXX, because they could get 5 to 10 times better power performance using BrainChip technology. And where we focus, as you heard earlier today, Zach talked a lot about in the days of IoT and trying to pump information to the cloud, is we focus on the edge, because all the data should be processed on the edge. And when we think of the edge, we actually think of the endpoint. And when we think of the endpoint, we actually think of the sensors. So when we heard some of my fellow speakers today talk, all I could think about is BrainChip, because with our technology, which we call Akida, and taking that technology in an IP format and having them design it into what they're currently offering, our AI accelerator can help them achieve not only what they're achieving today, exceeding what they're achieving today, but help them pave the way for the future. And when we think about the edge, we think about on-chip and doing all the processing on the device. And we think about it being extremely power efficient with ultra low latency. A very small memory data requirement. And most important to me is what we call one-shot learning. And this is where we start to differentiate. And I'll show you a video in a second in regards to one-shot learning. And the other thing, and you've heard some of my counterparts talk about it, it's enabling another layer of security and privacy because you're designing on the device without depending on the cloud and without having a lot of data move back and forth. So key technology foundations of Akita and our IPs, really the first thing is we're pure digital. So you'll hear neuromorphic come up and you'll hear other companies talk about analog mixed signal or analog components to their technology. Because we've designed our technology as a pure digital solution, it allows us to take current CNNs that exist today. It allows us to partner with companies like Edge Impulse. And for customers such as yourself and future customers such as yourself to take that technology that you've developed or the models that exist today and have them work directly onto Akita. And when the neuromorphic aspect of it was we combine that, we're talking about the architecture and the algorithms that go with that, we're talking about 4 key points. We're talking about at-memory computation. We're talking about event-based processing, again, focusing on events and not having to worry about non-events. But we're also talking about event-based communication within the MPUs and again, highlighting event-based learning or on-chip learning. So an example of that is, does anyone here like beer? Perfect. We need beer lovers because there's a couple of beer videos in this presentation. But a perfect example of one-shot learning is just take a look at this. What we're doing here is we're actually capturing these images of beer bottles. They don't exist in a data set. And by entering them in, we're capturing them. So we already did Corona Premier, and now we're going to do Rolling Rock. And then we're going to do another beer called Birch Beer in a second. As we go through this, and then after we do Birch Beer, we're going to do a Corona Light. And we're doing that on purpose because we want to trick Akita because the labeling between Corona Premier and Corona Light are very similar. And this is a very basic demo, but I think you'll get the picture of it in a second. So now we're going to come back in and bring each one of these bottles into play. So we bring the Rolling Rock in, and Akita immediately recognizes it. And then we bring in the Birch Beer, and Akita's going to recognize it. And then we're going to bring in Corona Premier. Akita's going to recognize it. But we bring a Corona Light in, and it's going to say, hey, this is kind of familiar to Corona Premier. So it's toggling back and forth. Well, this is how simple it is when you're doing device personalization to add a second shot, just to provide another layer of accuracy. So you provide that second layer of accuracy for Corona Light. So we're going to go back in and just make sure it's working correctly. And we go through Corona Premier, and then we're going to go through Corona Light. And you can see that it immediately recognizes the difference between the two bottles. And then we're going to come back in and we're going to blur it a little bit and see, like a human eye, as we focus, is it going to recognize, is it a Premier or is it a Light? And it's going to recognize it's a Corona Premier. Basic demo. But I want you to think about that now when we think of facial recognition, when we think of voice, when we think of vibrations, when we think of taste. Because this is where it gets fun with neuromorphic architecture. And when I talked about Mercedes earlier, here's an example of what the future of the cabin in the vehicle is going to look like. We've got 3 networks that are running simultaneously. One is going to recognize you by face, one is going to recognize you by voice, and one's going to recognize you as individuals are in the vehicle. And the future of that's also going to recognize the gender and recognize the age.
Hey, Akita. Aaron, all systems active. Hey, Akita. Todd, all systems active.
So what makes this fun is the fact that, again, Todd and Aaron, they didn't exist, right? We captured an image of them in the car. We recorded their voice, and now they're in the system, and Akita can recognize them by face, by voice, and so on. So we're going to see a lot of this in the future when it comes to device personalization, especially in the home and in industrial applications where people are working on the shop floor and in our workplace. So the Akita IP platform is really made up of 3 components, right? So you have the IP itself, And then you have our software development environment, which plugs directly into Edge Impulse Studio. So you're taking everything you've done in Edge Impulse, you're plugging it into our MetaTF, and the output of that allows you to work with those models in Akita. The second thing is, as I mentioned before, it's silicon proven in our reference SoC. And the third part are the enablement kits that we have available. So we have our design kits available as a Raspberry Pi development kit, an x86 development kit, and in PCI board format. So with all of that, you can start using BrainChip's technology today with the Edge Impulse environment. So a little bit more about Akita. What makes it really cool, because I have some more videos to show you, and one more about beer, as I mentioned before. But what we have going on here is the fact that Akita can take in, whether it be vision, voice, smell, vibration, taste, LiDAR, radar, and take that, process it through. And if it's a simple model, yeah, it's going to take it, it's going to process it standalone as an NPU. But if it's really, really complex, as you've heard some of my other counterparts talk about complex networks, we're going to do what everyone else is going to do. And we're going to offload some of that to the host CPU. So it's extremely scalable and flexible in how you use it. So let's have some fun. This is with one of our partners, Prophecy, and using their DVS camera. And what we're showing here is gesture recognition. So again, we were screwing around. We came up, we had it learn a couple of different hand signals, such as hand clap and roll the arms and air drums and air guitar. And as you can see, it's using very little power in order to do this, and it's extremely accurate. And then, one step further, for any of you guys that haven't floated by the BrainChip booth on the floor yet, please stop by, take a look. This is a vibration and regression analysis environment where we're basically using a train to highlight what we see as smart infrastructure moving forward, recognizing when there's faults or actual predictive maintenance applications, and moving forward from there. And again, we have this running here at the show. I didn't want them to bring the train set, but they were bent on bringing it to this Edge Impulse community because they thought everyone would really enjoy it. And as you can see, it's highlighting the difference between an alert, a defect, or something to that extent. The other one we have here at the show right here is with our partner Inviso, where we're doing a head pose estimation and emotion recognition. So there's a ton of different emotions on here. You can go by and you can test it out. If you can get your facial expression to show fear, about 5% of the people can get their fear face going. So please stop by and take a look at that. Last but not least, I talked about beer again, so we'll go into beer tasting. So what we're doing here, basically just having a bit of fun. And it's not just about beer, it's about taking the ability to analyze compounds and gases. And with our partner Oscar Brewing Company in San Diego, what we've done is we've taken some sensors and we're going to determine the difference between a pale ale and a stout. And as you can see, we're consuming about 6.3 milliwatts of doing this, but we're really analyzing the alcohol content, the glucose content, the sodium content, and pH. And what we're doing here is we're recognizing the stout. And it's again, fun to do it with beer because we all can relate to beer. But we're really highlighting the fact that there's a lot of things we can do here, because water purification, whether we're talking about gases in the air, different types of sensors and products that we can design in the IP to help those sensors recognize a lot of different things that are going to help us in our environment moving forward. And what I've done so far is I've highlighted voice, vision, taste, smell, and vibration, all within a lightning talk in regards to what we're doing with Akita's technology today. And that's what gets us excited at BrainChip about what we're doing. And again, highlighting the partnership between what Edge Impulse is doing and what BrainChip's doing, you bring that together, it really enables a ton of opportunities for everyone here and our future customers, mutual customers, working together and doing great things. And for those that are interested, we are here. Please stop by. And you can also take a look at us at www.brainchip.com, or feel free to email me at rtelson@brainchip.com, and we can go from there. Thank you.
Got it all warmed up for me. All right. Hi, I'm the Director of Innovation at Lexmark, named Scott Castle. I want to talk to you about a platform that we've been developing for the last couple of years, and recently partnering with Edge Impulse on really bringing more value to that platform. Lexmark may be a brand that you know, but I want to talk a little bit about Lexmark because I think it's past is prologue. It informs where you've been and where you're going. So who is Lexmark? Lexmark in a nutshell. In the 1950s, IBM established a printer manufacturing facility in Lexington, Kentucky. Typewriter manufacturing facility in Lexington, Kentucky. That facility manufactured millions and millions of Selectric typewriters, kind of a mainstay in the office environment for a half century. Lexmark moved into impact printing, into then non-impact printing, laser and inkjet technologies. Today, a large portion of our business is really around managed services. So we provide globally printing and imaging solutions to Fortune 2000 companies. We're of course based in Lexington, Kentucky. We have about 6.8 million devices active in the world today. About 1.2 million of those are part of our managed print services offering. Again, a global leader in the printing and imaging business. 9 of the 10 largest retailers are Lexmark customers, 10 of the 10 global pharmacies, 8 of the 10 global banks, and 8 of the 10 top global manufacturers. So it gives us a great place to instantiate edge technologies with our partners as a trusted IT provider. We are a technology-driven company. We inherited all these intellectual assets from IBM years ago. That's persisted to this day, where we own the polymers, we own the embedded systems, we own the optics, we own the mechanisms for building printers at scale. And these are the intellectual assets that we leverage as Lexmark to build solutions for our clients. We have a lot of in-house capability for testing and measuring, including things like self-declaration for FCC compliance, which is interesting, I think, in the context of some of the wireless communication things we've talked about. You look at the humble office printer in abstract, and I mentioned the 6.8 million printers. Each of those printers has tens, if not maybe 100 different sensors on it for measuring velocity of paper through the process, the temperature of the fuser, the color calibration. There's all kinds of sensing going on inside the mechanism to maintain quality and experience. We then connect that to our cloud, to our managed print services offering. We bring security, we bring embedded solutions, we bring a lot of other feature function, automated supplies fulfillment, digital thread technologies, digital twin technologies. That enables us to be most cost effective at managing this distributed fleet of devices. So we were kind of doing IoT and edge before it was cool. We've been doing it for about 20 years. So in my role in innovation, in the ventures organization, these are great assets to be able to bring to bear to create new solutions for our clients. Print's a fantastic business. We're outperforming the market year after year, but it is a declining business. So we're looking for growth drivers. And the growth drivers are, again, leveraging those same intellectual assets that I talked about prior. We have the Opter family of solutions, which is our edge and IoT platform. Of course, we like to view them as a continuum of delivering value across the use cases, but we can actually deliver them independently as an edge offering and as an IoT platform. In the context of this audience, I want to talk more about the edge offering and what we do. We're focused on retail, manufacturing, transportation, and healthcare, mirroring where the strength of our core business is, but also expanding into use cases that we see a lot of value in with other clients. So I used this slide a minute ago, before IoT and edge, before it was cool. What does it look like now that it is cool? So we've taken and stripped away the mechanism from our embedded systems and built a general purpose light edge gateway system for deploying artificial intelligence applications at scale for enterprises. That's really where we're focused with our platform. We bring the hardware, the firmware, the security, the operating system, break fix, continuity of supply, all of the service and support that enterprises need to be able to maintain continuity of their operations over the long term. We, of course, connect to many different commercial off-the-shelf sensing technologies to perform these purpose-built applications. The applications take the form of a Docker container. So if you can build a Docker container, you can build an application, deploy it to an enterprise at scale through our system. We put a lot of effort into really bring a consumer-like experience to the application deployment and device management pieces of things. We really wanted to be something that was easy to use for those types of clients. In addition, as I alluded to, if you can build a Docker container, you can build an app for Opera. We, of course, build these applications for purpose-built things, and we work with a number of third parties to build applications for our system. These actual use cases are things that, again, should be very familiar to this audience, things that you've seen today: heat mapping in retail, sentiment analysis, demographic analysis. The use case in the middle is the one that Zach talked about this morning, where we deployed these technologies in our own manufacturing facility in China. We had 13 different models of printer going down the manufacturing line. We needed to make sure they were built correctly with the right labels and logos and bezels and covers. This use case, it broke even in 5 months for us. And on this one manufacturing line, we identified 19 additional use cases where we could take the machine and substitute it for human visual inspection. So for us, that's just another container on the system until you run out of bandwidth. So really, really great story for us in dogfooding our technology, showing return on investment, and then extending that obviously to our manufacturing clients that are part of the Lexmark portfolio. We're developing use cases in workplace safety, patient monitoring, next generation firewall applications for unattended transactions. Aspirationally, we're working toward the smart building space. Certainly the oil and gas sector is of great interest to us, along with insurance, as a burgeoning IoT set of use cases. Zach alluded to this morning some work we've been doing with Edge Impulse over the past, I don't know, probably been close to a year, Sheena, I think, since our first introductory call. But what we call this is skills builder. So we really excel with the core Optra offering at application deployment and device management and fleet management. That's really where we excel. Skills builder is really the automation of building the Docker container that we can push to a fleet of devices. Whether that be one or whether that be 1 million devices. We'd be able to push those devices out to enterprise to do this purpose-driven job. So it's a whole scalable, automated pipeline for our Optra hardware, everything from ingesting of data to deploying at scale. We think it's unique because of the vertical integration of our hardware, software, security, very focused on delivering value, cost-effective value to operational problems like heat mapping in retail, but then using our credibility as an IT provider to make the CIO comfortable. That you have something that's secure, robust, and extensible. Graphically, kind of what I just talked about is the whole pipeline from ingesting of the data to selecting a model, training the model, testing and simulation, deploying at scale, back through the system. So we think this is a really, really unique offering. We think we can create a lot of value for our customers. We think that this delivers speed to prototype, a very seamless move from prototype into scaled production. You can really maximize the investment in your hardware. You're going to get the most out of it. And it's a continuous improvement path because you can rebuild a model, retrain a model, redeploy a model, all through the same mechanisms. So we're excited to partner with you. If you've got enterprise class problems, use cases that need a deployment mechanism, that need device management, fleet management, and leverage the Edge Impulse tools, we'd love to talk to you more about that. Thank you.
Thank you, Scott. Thank you very much. I'm good. Well, that was the end of another section. It was really exciting to see all these different use cases from partners really bringing to life this technology. I'm really excited for all this stuff that's happening. And we have a 45-minute break now, so come back at 4 p.m. PT if you're in the Bay Area. If not, if you're watching from home, 45-minute break. Everyone here, there is drinks outside. And please bring back drinks because we have to do a big cheers all together afterwards. So see you in a bit. The show is about to start in 5 minutes. The show is about to start in 2 minutes. Please take your seats. Welcome back, everyone. We're starting in 1 minute. Please take your seats. Welcome back, everyone. It's been a fantastic day, and I see some happy faces in the audience, and some beers. I'm really excited. I mean, you know, we've done quite a lot already today, but there is still a few presentations to go, 3 presentations, and we actually left the best for last. So I'm really excited to welcome on stage Jan Jumboom, CTO and co-founder of Edge Impulse. Woo!
Cheers, guys. Brilliant decision not putting my tech keynote right after Zach so everyone would leave by lunch, but actually, and open the bar at 3:30, like really great from the event organizers. I'm Jan. It's been truly tremendous, not just seeing everyone here. Like I couldn't make it last year because I couldn't enter the country, unfortunately, due to COVID. So this is truly the first real event that we throw. Like how truly amazing this is. And not just the people here, right? But the community, the people watching on the live stream right now, the people who are going to watch this on YouTube. And the thing that I'm most proud of, like, I think a really big compliment that we got from some people just in the break, they said, well, we always complain that there's not enough end customers at all of these events. And now they were complaining that there were too many end customers and we need more technical content. So let's balance it out. So first of all, let's go reflect a little bit on what happened in the past 12 months. So some numbers. So this was Imagine 2021. And this is our project count. So Zach already touched upon it in his keynote. So during Imagine 2021, we had 36,000 ML projects being created on Edge Impulse, which is already an astonishing number. If you would have taught me that 3 years ago, I wouldn't have believed you. But then look at the ramp of this peak. And this whole graph is since the inception of Edge Impulse, the launch of Edge Impulse back in January 2020. We're now at 115,000 projects. It's holy shit. Holy shit. This is amazing. We have, yes, thank you. And there's 300 new projects being created every day. Truly astonishing. Over the past 12 months, we ran 229,000 hours of compute. That you might not realize like how much that is, but that translates to an AWS bill of about $600,000. We have 20 jobs running in parallel at every moment, every day. Truly insane. We have 60 million data samples that were added in the past 12 months. And then you realize as well, like collecting data is hard work. But still, we've managed, these 60,000 new projects have managed to create 60 million new data samples. So that's people actually going into the wild and actually collecting stuff from real devices. It's really insane. And our dev team, you know, we have not been sitting quietly. We have been working very hard as well. We have over 2,000 commits to master. And in the talk that we have today, I'm going to highlight a couple of the new features that we've been building over the past 12 months, and a small look forward into the new stuff that we're going to release very, very soon. So what we like to say when we go in with a new customer is that everything always starts with data. I think, in all fairness, Edge Impulse is not a machine learning startup. We help you get information from data startup. And machine learning is one of the techniques that we use to do that. But if you do data-driven engineering, so you use data to make those decisions, then having high quality and good data and representative data, that's kind of where everything starts. So what we released back in April is, I think, one of the best additions that we've made to the Edge Impulse Studio in basically since the start. And this is something that came out of the work that we did with Vijay Reddy's group at Harvard. And it's a data explorer. So it's a one-view overview of your complete data set, but not using traditional dimensionality reduction algorithms. Rather, we use a neural network to generate neural network embeddings. And those embeddings we then visualize in a 2D plot. And what that does is that it gives you a debug view of the neural network. So by just throwing your data set in here, this is common voice, we can very quickly see junk samples, stuff that is mislabeled. And in addition, what we can do is that we can very quickly label unlabeled data. And we just do that by just throwing unlabeled data in and see where it lands. Maybe it's a new cluster, maybe it falls into one of the existing clusters. And this helps so much. Like if you look at why, for example, in MLPerf, the visual wake word detection, like the maximum you can get is 89%, it's just because the data set is shit. There's all kinds of stuff in that data set that are not person. The Data Explorer has been a tremendous help in just identifying those samples and getting rid of them. So really awesome stuff. The second thing that we've shipped is data sources. So data sources allow you to integrate with your cloud provider with a single click of a button. So you have your data, your camera is feeding data to S3, click a button, will automatically get that data into your project, and then we run that as part of a pipeline. So we can run it daily, we can run transformations over that data, and we can set up new rules. So stuff like, I want to retrain my model after new data has been added. Version this. And then if my accuracy didn't drop, send me a notification, build me a binary, and send me a notification to my device management service, so you just push a new firmware update directly to your devices. The two things together, so data source and data explorer, allow you to also do some assisted labeling and active learning, what Zach already mentioned. So the data explorer uses neural network embeddings, and that gets better over time. So the more data you add, the better those embeddings become, because they start separating this data. Then if we get new data showing up, if it's in a cluster that you already know, awesome, just auto-label that as the right data. But now you can get kind of the interesting samples that come in, stuff that falls outside of a cluster or falls in the middle. That's the stuff that we allow you to label, and that reduces labeling time by 90% on projects that we've seen. And together, all of that enables active learning. So active learning is like, I'd like to say, machine learning is not a one-off, right? It's something where you continuously learn. The best customers that we have, not in terms of money, but in terms of like how much they use the product and how much value they get out of it, have nailed this down. It's a continuous process where you get data from your edge device, you collect it, you label it, you retrain your model, you verify that accuracy didn't drop, and then you deploy back. So the learnings that we've done around active learning, data explorer, data sources, transformations, etc., have all come together in our health reference design that Zach said. So this is an end-to-end design on actually showing how we deal with clinical data, how we do data collection from that, and then in the end, deploy that in on-device ML. There's a couple of really cool kind of tricks in there that we've learned from working with Aura, No Labs, and No Watch, customers in the health space. For example, if you work with multiple devices, you realize, if you think about working with a single device and how hard it is to get data from that, now try doing that from 3 devices in a clinical setting and then trying to align all of them. So we've added something called checklists. It's a super low-tech way, low-tech solution, but really useful for data Q&A engineering. So it's just stuff like, hey, do we have actually all the files? Do the time zones match? Like very simple Q&A checks. Already been a tremendous help. Like talk to Yura from Aura if you want someone to attest to that. And we've been working on some stuff around finding correlation between data. So think that you're in a sleep lab and you're sleeping with the ECG and EEG pads, on your body, and you're sleeping with an Aura ring on both of your hands. How do you know that the data you get from the ECG and EEG reading actually match the ring? So you might think, well, someone types an identifier for that person in. Okay, awesome, yeah, sure, that works. But data errors are being made. So stuff that we do now is things like correlation finding. So we try to see if, for example, on the heart rate channel or on the activity channel, do we have peaks at the same time? If not, then that's a really good indication that you're not looking at the right data. And if you don't catch this stuff early, your data set is going to be screwed. And in addition, what we can do, so you see these peaks are the same, but they don't completely align, is do stuff like time synchronization over this. Truly useful, and an absolute must if you do this stuff in a clinical setting. So we ship that. Now the second thing is like right after we say everything starts with data, is that the customer says, well, but I don't have any data, right? And it's really hard to collect. And it's not really the customer's fault or anything. It's a problem that we have in general is that there's a lot of data set asymmetry. So you typically have lots and lots of good data, like normal operation. You have a machine, and the machine mostly functions correctly. And then maybe if you're lucky, you have a few samples of incorrect data, fault data. And that fault data is typically not even just like one class. It's actually split between multiple classes, right? You have fault state 1 and fault state 2 and fault state 3. So you have even less data per class. And then very often there's also fault state that you don't even know anything about. Even harder. So how do we deal with that? So traditionally, this is one of the first things we built actually when we started at Gimpels, was to add some safety guards through anomaly detection. So what we do here is that we say, well, this is the complete potential input space that you have, all the potential inputs that can go into your model. And then we do a learned representation of just the training data. And now when we have new data coming in, we just look where this falls. So here is some data sample that fits nicely in those clusters. It doesn't mean that we've seen this training sample, but that it looks similar to the stuff that you have in your training set. So you say, okay, in this case, we haven't seen this input. This is not an anomaly. But when something falls outside of that cluster, we say, hey, this is an anomaly. Either we don't trust the neural network for the classification because this is stuff that we've never seen before, or we tag this as an anomaly and ship that off. So the way that we do that today, because this, as said, this has been in Gimpels from basically July 2019, when it was just me and Zach, and all of Gimpels ran on my laptop, is that we take your input, we run your feature extractor, so your DSP code over it, and then we run a clustering algorithm. And that's really nice because then we have clusters, and data either falls in a cluster or outside of a cluster. Clear. The downside of this is that this requires some feature engineering. So we can train this clustering algorithm, for example, on a rotating fan, on, hey, we always know, because we have our feature analyzer here, we know that for normal behavior, we see a peak at 36 hertz, and then a secondary peak at 24 hertz. So we train on that. What happens then if that peak gets lower at 36 hertz, or it changes because there's a blockade or something, then we know there's an anomaly. And that works really well if you can reason about the data that way. But for a lot of data, like audio and images, this doesn't fly, right? I can't train an anomaly detection model and say, if the pixel on row 7, column 8 is red, then there's definitely an anomaly. That's just not how image classification works. So our second version of anomaly detection is going to look like this. We still have the input. We still have DSP features. Still, like, as long as you can avoid doing anything with machine learning, great. That's one less problem to worry about. I love signal processing. But now, similar to what we do with the Data Explorer, is that we'll be using neural network embeddings, sort of a debug view of the network. So we cut your neural network off here, and then we combine it with a Gaussian mixture model. So this gives you the Gaussian distribution of normal inputs as seen by the neural network, and that's what we train our anomaly detection methods on. And this is super cool, because what this gives us is a flexible addition to any neural network, where we can convert any classifier that you have today into something that can detect anomalies, sometimes even at the same time. So you might have one network, so one amount of compute, and at the end you have a classifier head and an anomaly detection head, basically for free. And this finally solves this issue that I think everyone has seen, where you have a classifier, and the classifier can detect these 10 image classes that you've added really, really well, but then you put something in front of it that has never seen before, and now it just gives random results. So this is a really cool addition, I think, here. So I have an example of how this works. So FOMO, faster objects, more objects. The acronym came first, and works essentially like this. So it's a neural network that outputs a heat map. So every cell here essentially acts as a classifier. So this is the result. So if you train this on Jenga blocks, all of these cells will activate. And from that, we can then derive the centroid of the object or draw a box around it or whatever we want in the post-processing step. Now, as said, our new anomaly detection work is an add-on to any neural network. So what we can do with FOMO AD so FOMO for anomaly detection, is that we remove that classification head and rather attach a Gaussian mixture model at the end. And now rather than every cell is a classifier, every cell is an anomaly detector. Now what does this give you? This gives you a situation where you just need to provide normal data, so data that you expect this camera to see. We train on that, we train on patches of that. And after that you feed it through, and then we'll tell you for each cell, do we think there's an anomalous item in here, yes or no? The truly insane part is that there's almost zero overhead, right? There's just the overhead of the inference on the GMM side, but that's very, very tiny. So this runs with the same performance as FOMO today. So up to 30 frames per second on a Cortex-M7, and up to 200 frames per second on like special accelerators. And because FOMO is completely convolutional, you can also, if you have enough memory, you can throw really big images in, and we'll find even the smallest of defects, which is really cool. So here's a demo. So this is on the Ready Robotics robot arm. We shot this 2 days ago in the office. So the camera is actually on the arm at this point. And you see a view of the camera here. And the darker a cell, the less anomalous it is. So we've trained this on background image, so the blue overview that you see here and the blocks. That's normal data. And let's go run it. So it's moving around, that's fine. And now we introduce a red cube. And it just lights up. And the image state goes to anomalous. So we know that there's an anomaly, there's something in there that shouldn't be there, and we know where it is. Remove it, goes back. We add a large green object here. Immediately lights up. That is definitely an anomaly here. And we can use it for safety features too. So if Arun puts his hand there, immediate response. So up to 200 frames a second, this on embedded Linux. Flawless and only trained on 100 images. Truly insane. And we can do all the stuff that we can do to make more with less data, like transfer learning, model architectures, etc. we can do with FOMO AD. And this is not just going to come to visual data, but it's also going to come to audio data, and later also to sensor data. So first FOMO AD, probably early 2023, available, and then the rest of this stuff comes. I think super, super exciting. Then something that Zach also alluded to, which is that every device is sort of similar, but it's also different. So think of the robot arm, right? As Zach said, we had to recalibrate it because we moved it from the ground floor to the first floor, second floor, whatever you say here in the US, this floor. And that's something that you're going to see in a lot of devices, right? There's a generic anomaly detection model that will probably work for all of these models. So if someone hits it, or it grabs your finger, or tries to move a chess piece, and then have you seen that video? No. So that's your generic algorithm. But then for this specific device, there's stuff that is normal for this device that is abnormal for other devices, and the other way around. Think of it, let's say that you're normally just picking up small pieces of wood, and all of a sudden you pick up something very heavy and you have a lot more stress on your joints. Not anomalous in general, but anomalous for that machine. So how can we fix that? So we have been working on a tool called on-device calibration. And on-device calibration is something that runs completely local. So this runs on the chip itself. It can run, depending on the complexity of your model, even on MCUs. It will take in a complete anomaly detection pipeline. And then we learn in this Gaussian distribution what is normal for that specific device. So it's not a magic button. It's not a device that you put on any random machine and it will figure out anomalies. It still requires careful engineering. That's why we don't call it on-device learning, but rather on-device calibration. But after that, it's really powerful. And I have a demo for that as well. Shot this morning from my hotel room. So in here I have a device, and it's trained on our Edge Impulse 101 demo, which is the continuous gestures. So this device can recognize idle on my desk, up and down, waving, and snake. Now, for this specific device, the only thing that's normal is going to be idle and up and down. So I'm in calibration mode now. So it's getting normal data. I'm just going to show what is normal. So here, up and down is normal. And after about 70 samples, I press the button. And then we go into training mode, or calibration mode. There we go. So this ran locally on Cortex-M4. And now it's in anomaly detection mode. So as long as we do stuff that it's seen before, completely normal. But now we do something that's in the training set, but not here on the device, like waving, immediately gets flagged as an anomaly. So truly, truly, truly amazing. Like this, what we can now do with all of this is just do stuff with only normal data. We have devices that can actually accurately detect anomalies, both in audio, both in vision, and in complex sensor data, and do on-device calibration. Like, if a customer now still says to me, like, I don't have enough data, now I really don't believe them anymore. All right, so that was lots of data. Let's talk about ML models. So at Gimpels, like, we have an amazing tech team, but we're 65 people only, right? Out of 7 billion people on the earth, that's not a lot. So while we can build tons and tons of models, we can't build everything, right? Like we have really cool stuff. We have FOMO, we'll have FOMO ID, we have few-shot keyword spotting, mobile nets. If you want to modify something in a Gimpels, you say, hey, I want to do something a little bit different. Cool, we have an expert mode for that. You click the button, you get, Keras API. But there's a lot more. There's a lot more stuff outside of the world, right? The world is much bigger than just what we can build internally. So there's novel architectures, YOLO v5, efficient net. Maybe you want to do some custom transfer learning because you're Conservation X Labs and you want to have a cool transfer learning model for your customers. Maybe you're a silicon vendor, right? And you have YOLO v5, but you actually swap out a couple of layers because that makes it run faster in your silicon. We can't do everything ourselves. Maybe you have completely novel architectures that you built internally with your data science team. So you just write that in PyTorch, Keras, or scikit-learn. And maybe you want to do experimentation, right, that you can't do in a Gimpels. We have the weights and biases folks over here. They're going to talk about this just later. Maybe you want to find the optimal number of convolutional layers in the middle of your network. Maybe you want to do some new data augmentation. Like, this is all stuff that we can't provide for you. So how are we going to fix that? Bring your own model. I couldn't, BYOM. It's a little bit less good of an acronym than FOMO, but it'll have to do. So bring your own model is live today for everyone. So this is actually a feature that we had for enterprise customers for a while. We've opened it up for every developer now. So it's a complete toolkit to take any model, whether it's trained in PyTorch, Keras, scikit-learn, TensorFlow, and we have examples of YOLO v5 and EfficientNet as part of this as well, and bring them into a Gimpels, and it'll show up exactly like any other model in a Gimpels. This is really cool, because what it allows you to do is that it allows you to have your ML engineer be a ton more productive. There's all kinds of shit in a real ML product, in a real ML pipeline, that your ML engineers don't want to deal with. Stuff like getting data from devices, time synchronizing these data, doing Q&A checks, etc. What your ML engineer would appreciate is just a clean stream of already verified data. So that's what we're going to give you, right? We're going to let your ML team add value where they add value, which is on this experimentation and modeling side. So some stuff to be released here is new CLI tooling to quickly get updated data. So just one command, bam, you have your data already in NumPy format, already nicely spread out. You just go do your ML on top of it. We now ship a new Python SDK where you can locally give us a model and we'll tell you how fast it's going to run on real hardware and give you accurate RAM and ROM numbers. And this is amazing. Like if your ML engineer is tracking something in weights and biases, you want to know the complexity and the number of ops in the model, you want to know the accuracy and the F1 score, but now you can also track how much RAM this is going to take on device. So if you're running a sweep in weights and biases, for example, and you see, hey, actually this is more than 100K of RAM, that's something I don't have on my device, awesome, I just eliminate that straight away. I don't even want to go explore models in this direction. We will handle, as we always do, compilation and deployment. Like you have heard, if you were in the lightning talks, you heard from so many silicon vendors that built truly amazing new silicon, new accelerators, new NPUs, GPU combinations. All of that is supported in a Gimpels. We'll handle that deployment step for you. So if you're an ML engineer, you say, hey, cool, I want to deploy to a super wide ecosystem of devices. Awesome. Push it to a Gimpels. We'll handle all of that for you. And we'll host the pipelines for you. And that is interesting because who likes to get a text on Slack saying, hey, we have some new data. Can you retrain this model for me? Right? Really annoying. But we just host it in a pipeline. You push it once. And this comes with the whole retrain pipeline as well. So there's new data, we'll retrain it for you, we'll host these models, we'll make sure that no dependencies break, and then you can deploy. So completely integrated in all the stuff that we do. All right, so that was the 3 main topics. Then there's a couple of new releases that I want to touch upon. And all of these are live today. So our EOM compiler, so it's our neural network compiler for MCU-level devices. We've been porting a whole bunch of new kernels here, and that's because we are supporting Bring Your Own Model. And there's a lot of stuff, a lot of kernels, a lot of operators, etc., that are in here that are not supported right now in TensorFlow from microcontrollers. So, for example, because we now add scikit-learn support, and thus classical ML algorithms that you can port easily, there's a ton of operations happening in there that are not happening in typical neural networks. So silicon vendors have not ported that. What we have done is that we now implement software kernels for all of those. These are in our SDK. And silicon vendors can now come in and provide hardware-accelerated kernels for this stuff. So you can do hardware acceleration on classical ML algorithms as well. As part of that, we also are working on one of the coolest technologies that I have ever seen, which is called JAX. And JAX is, in essence, it's a Python to graph compiler. And from that graph, you can then go through a compilation step to TensorFlow Lite. And from TensorFlow Lite, through EOM, we can go to source code. So what this gives you is that you can write Python code, vectorized Python code, and we'll handle the complete compilation step to run this efficiently on embedded systems. So we've been implementing this as part of our work to enable scikit-learn, but we're going to go one step further, and that is that we're going to allow you to write signal processing code in the same way. So you write a signal processing block, you do your FFTs, you do your matrix multiplications, you do your filter banks. You write it in Python once. We'll handle the compilation, we'll handle the hardware optimization, we'll handle the quantization, and get that running on device for everyone. I'm going to go talk more about this on Friday at 9:15 a.m. Pacific. Then we're going to go into a demo. But all of this is live, so if you go to Bring Your Own Model and you click on the scikit-learn example, you'll see exactly how we've done that. And in addition, we shipped the latest release, which actually uses between 5 and 8K less flash. So that's really great for smaller models. So especially if you think about something like the gesture model that we had just now, that used to take 40 kilobytes with TensorFlow Lite Micro, 20K with EON, and now it takes about 13. So even down a lot more. The second thing is that we have just released, and I think Matthijs, I don't know, I can't see him because of all the lights. So there's Matthijs, the chief architect of the EON Tuner. We've released a new version of the EON Tuner, our AutoML pipeline. So the EON Tuner finds the best model within the constraints of your device. So we are hardware aware. So you want to run this on, hardware from silicon provider A. You have 26 kilobytes of RAM available still, and you have a hard latency target of 100 milliseconds. Awesome. We'll go find the best model within that search space. Previously, we had sort of recipes. So you said, I want to do a keyword spotting model, and we'll go through all of our keyword spotting algorithms. Now you can do search space customization. So you say, hey, actually the dropout layer at the end of my keyword spotting model, I don't really know what it's going to be, but anywhere between 0.1 and 0.4. OK, just type that in, and we'll figure it out for you. In addition, to support Bring Your Own Model, we'll also support new custom DSP and custom ML blocks. So if you have something you want to test out, for a long time, one of the demo applications that we had in Gimples was one to distinguish Matthijs' cats. And he has 4 cats. 2 of them look super alike, and 2 others also look super alike. So with MobileNet v2, one of the default architectures, we only managed to get to 92% accuracy in the test set. But Matthijs brought in, through Bring Your Own Model, all of the efficient net models, ran the EON Tuner over it, and we managed to get to 98.9% accuracy through that automatically. Like super, super cool. So this is available today. There are some limitations for free users, but enterprise users have full freedom in modifying that and full search space customization. So even if you want to run 1,000 different models through here, awesome. Just set that up, click the button, and we'll make sure to run that for you. The last thing here is performance calibration. So what would it, if I have 95% accuracy in my test set, is that enough for me to deploy this in a performance critical situation? Like, I don't know, right? Because this doesn't tell me anything. Your test set is already really highly curated right? You probably cut off stuff that looks sounds very similar to stuff that you have. So performance calibration gives you honest insight in what the performance of your model is. And it does that by allowing you to upload a really long, in this case we launched it for audio first, but a really long audio sample, let's say a day, right, 24 hours, annotated with, for example, the keywords that you want to detect or the audible events that you want to detect. We'll run your model over that complete day of data, and then we'll plot you the false activation rate and the false reject rate. So how often did the model spuriously activate, and how many times did it miss an event? Now then we actually have about 200 different post-processing parameters, like maybe a noise gate here, maybe some suppression on the signal. And we plot all of these choices into the graph that you see there. And you can choose what is more important. Maybe for your application, false activation rate is really crucial, right? So you want to lower that. And OK, yeah, then it's going to reject a couple of things. Maybe you want to balance it out. So all of this you actually see, including a complete understanding of post-processing impact. And this is available for free for everyone on every audio project. Just click the performance calibration button in the dashboard. So yeah, recap of 27 seconds on the clock. Truly, what a year. Like I think I speak for Zach as well, and for Dan and Matthijs, who were our first 2 employees, that we never imagined when we launched publicly in January 2020 that we'd have over 100,000 projects, 200 people in the room in California at a conference, so many amazing partners, so many customer stories actually here to share with you. Truly, truly amazing. Second, for you, some homework. Start thinking about your active learning strategy, right? And we can help. We have lots of experience doing that. And for us, the focus for 2023 is going to be around data, anomaly detection, and extensibility. And up to 1 million, want to go to 1 million developers. So with that, thank you all. To our friends from Weights and Biases. Woo!
Thank you very much. I'm Sean Gardner with Weights and Biases. Hopefully, well, I moved to the first slide already. I lead partnerships here. I also lead a lot of our go-to-market. When I saw I was last, or almost last, presenting today, I was going to make the joke of, you know, I'm the only one standing between you and the bar. But I see that's not a joke I can make today, which is great. So I like this conference already. So who is Weights and Biases? I can't go back on these slides now, but you know, we call ourselves a developer-first MLOps platform. We really make the best developer tools for machine learning. So many of you might have heard of Weights and Biases. Your team might have used it. But you know, what we're seeing in the market is that ML is transforming almost every industry, and we work with thousands of different ML teams. You know, we see the likes of John Deere using computer vision to build fully autonomous tractors, to do precision spraying of herbicide. Microsoft, in their health ventures, is doing some amazing work around disease prediction. And even in sort of more blue chip industries, you know, companies like RBC, up in Toronto are using reinforcement learning to do automated order execution. So, you know, we're seeing thousands and thousands of use cases, and we're living in just an incredible time. I mean, if you've been following what's been happening with like DALL-E 2 or Stability and all of these large language models, I mean, we just live in an incredible time, and it's just going to drive so much change. You know, a bit of background on Weights and Biases. We started the company 6 years ago. We've raised a couple $100 million in funding. And we really started the company to, you know, help machine learning practitioners with a set of very useful developer tools to be able to build largely deep learning applications. And Lucas and Chris had started Figure 8 before. We have a lot of angel investors, people who wanted to invest in the company from some of the leading companies doing ML, and we built a great team. And you know, the problem that we solve, and the problem that we sought out to solve, is if you look at developing software, you know, there's a pretty tried and tested workflow to be able to develop software. You use Figma, you use GitHub, Jira, et cetera. When you're building ML or when you're teaching machines to write software, there isn't that workflow. And it takes a very different workflow, right? Because you're using data to be able to train models, do representation, and then get those models into production and then constantly retrain them. And so with weights and biases, when we released the first product, and anybody here can go and download and use the product, we really started in experiment tracking and optimizing models. And now we've sort of broadened out onto the data management side and also onto the production side. And we have 400,000 folks today who have signed up and use weights and biases. We give it for free to anybody in universities and research teams. And we have a lot of enterprise customers, which we can talk about as well, and they love the platform. So every day, we see many of these companies, come in and start to use our platform. And, what they do with the platform is really collaborate around machine learning, because there's a lot of data that you want to track and metrics, and then you want to be able to share those metrics. And so we have a significant number of customers. We have a lot of folks in the AV space. I think 4 of the top 5 auto companies are using W&B. And then, a lot of companies who aren't necessarily ones you would count as sort of tech companies, right? Folks in retail, folks in banking, et cetera. So one of the things we sort of pride ourselves on is, how interoperable we are. We're really an API layer that can be deployed in any cloud. We have our own multi-tenant cloud. And we plug into all of the different sort of frameworks. So if you go to Weights and Biases website and you go to our community and you start to use the platform, we have pre-done integrations with all of these frameworks: PyTorch, Keras, TensorFlow, JAX. And I didn't prepare this presentation following Jan's presentation, but I think he mentioned every one of those frameworks. We're cloud agnostic and we're hardware agnostic. You can also deploy us in a container on-prem. So we fit into your environment. We fit into sort of the surface area of that environment. And we help your ML teams build better ML. And we're super excited about being able to partner with Edge Impulse. This is sort of where we fit in, and I think Jan showed a very similar diagram. But when your teams are developing models, when they want to collaborate around ML, using weights and biases allows them, one, to be able to track everything that they're doing, to be able to optimize those models, and to be able to get a ton of visibility into what they're doing. One of the most amazing stories, we had a customer, it's one of the top race teams. So if anybody watches Drive to Survive, I'm not going to reveal their name. They started using weights and biases, and they wanted to virtualize sensors on their cars and to be able to win the championship that's going on right now. And they found things that, with all of the ML tools that they're using, they couldn't find just because of the granularity of data. There's a lot of that getting spit off the car, coming into weights and biases that they can go and use. So, they started using it. They ended up buying a license, being able to deploy it, and now they've deployed these models, into production. And so, we're super excited. A lot of our customers are pushing these models to edge devices, to vehicles, et cetera. And we're just becoming that fundamental tool chain. And we're really excited about putting this in the hands of Edge Impulse customers. To get up and running, and I'm going to invite my colleague Karan up to give you an overview of what we've developed. We'll also give you a link to that report. But literally with a couple lines of code, you can get started with what we're doing. And start to track all of the ML that you're doing and collaborate around it. So with that, I'll hand it over to Karan to show you what we're up to.
Awesome. Yeah, thanks, Sean. So today, this won't be like a live demo, given the setup. I'll definitely share a link to the report. But what I'll be doing is highlighting some key areas and features that weights and biases provides. And then once you follow that report that I'll share at the end of this presentation, you can see and play around with the platform. It also has some links to getting started. But in terms of, I would say, key concepts and key areas, like how weights and biases fits in.
So I would just like to reiterate like this slide. You just saw it like a couple of minutes before. And even Jan described this slide. This would be like the continuous learning loop. So where weights and biases fits in is like we are a lightweight integration, like where we would sit on top of your machine learning workflows. So what we will do is we'll help you track all of the things that you're doing, like something which is quite tedious for a machine learning engineer. So we'll abstract all of that for you and save time. So you can focus on the real work that you're tasked to do, which is like getting the best models out and like worrying less about how to maintain all of those things, like document stuff. And all of that is done like by just a simple integration. So now, like when it comes to connecting edge impulse to weights and biases, right? So let's say if you have any edge device that you would want to build, like, that you're gathering data from, and you would want to build a machine learning model. Like this is, I would say, like a basic setup. It's a very simple, I would say, like installation. So you definitely need like both of these accounts. So that way you can have your own API keys to like pull data as well as push data. And the report that I'll share has like these set up in detail. So you can like follow along, like you can parallelly work on your own projects. But for the purpose of this demo, the project that we will be working on was the bird sound classification dataset. So this dataset is already in Edge Impulse. So if you would want, you can use this boilerplate dataset. But it can be pretty much any dataset that you gather from like different edge devices that you want. For this specific dataset, this is for an audio file. This is just like a very basic dataset trying to classify the birds based on their sounds. So what we did was, in the previous slides, the steps that I showed, we just used that and pushed that data from Edge Impulse into weights and biases tables. So when I talk about tables, it's just like a pandas data frame. But now it also has support for all of those rich media types. So things like images, like audio files, video files, 3D data, like molecular data, like pretty much anything that you would want. You can just have one view, like wherein you can have your structured data along with that unstructured data. And this is just a screenshot, but if you go on that report, you can actually play and listen to each of those audio files. So that way, like, I think this goes more towards explainable AI. So once you have your model that's training in, you can visualize, like hear those sample audio files, see what the ground truth is, see what your model is predicting, and then try to understand, is it behaving in a certain way that you expect? Like if not, you can now drill down and see like why and where is it that the model, like where you can improve on that model. But yeah, going back to this data set, you can see there are some examples of sound files. Like for some birds, like there's a snippet of a house sparrow here. At the same time, we also have some noise in this data set. So it's, I would say, like a classic data set wherein like you need to work on feature engineering, make sure your model's not getting biased because there's a noise introduced. At the same time, when it comes to sound, it can be broken into multiple features. And there can be like so many different features. You would need to make sure your model incorporates the best set of feature so that it does not get confused with the other underlying features, which might decrease the training accuracy or might result in like a completely random output when you're trying or testing it out on an unseen data set. So in order to do that, when it comes to different features for audio files, so what we did was performed hyperparameter tuning. I think that's the best or the classic way, where you can easily filter out the different sets or the different combinations and see which works best or not. In this case, we performed hyperparameter optimization like on weights and biases, which is called as sweeps. So what sweeps does is it has the ability to ingest that huge volume of data. So let's say if you have a super big set of hyperparameters, you can easily ingest that, like run your model on top of it. And it's basically a two-step process. So the first step is just like with pretty much any hyperparameter optimization model, you would define a config file. A config file includes things like your the boilerplate machine learning framework that you're training on. At the same time, the different kinds of search strategies that you want. So do you want to consider like a random search? Do you want like a grid search or any method that you would want to choose? And then you can define the bunch of different hyperparameters that you want to optimize or get the best combination of. So like you can define categorical values. So for things like your optimizers, when you can have different optimizers, you can have categories that you can define. Or let's say for some of those numerical values, you can also define in a range. Like one example would be learning rate. You can just define like the minimum and the maximum range that you would want to be considered for this hyperparameter optimization. And you can see in this diagram here, all of that config file is stored in that central sweep server like within the weights and biases platform. Once you're good with that, I think that's when you get into the next step is while you're running in those agents. Agents is basically, I would say, a single experiment that you can run. And it will take a combination based on the search strategy that you have defined. And what you can do is you can run multiple agents in parallel. So that would basically make sure your process is achieving those results much, much faster. And as and when these agents are running in real time, you can see a visualization or output of these agents. And this will look something like this. This can be quite confusing and overwhelming at first, but this is what we call as the parallel coordinates plot. And the basic interpretation of this plot is like all the vertical axes that you see, so things like the dropout, the activation, like all those different vertical axes are the hyperparameters that you have initially defined as a part of the config file. And then the rightmost column would be your end goal that you're trying to target or that you're trying to optimize. In our case, we are shooting for a validation accuracy. So naturally, the highest value of validation accuracy corresponds to a better performing model. So now once I know what this graph means, what I can do is I can easily filter out on these graphs. So let's say I'm only interested in the parameters that result in the best performing model. So what I can do is I can easily create a filter on just my validation accuracy. And now this becomes a game changer. This would save like all the time that we have seen like machine learning practitioners have spreadsheets. Like you'll look at those spreadsheets, try to see which I'm sure like would take plenty of time, like even more than a day or few days. This would be like within few minutes, you can make some very clear observations. Some of that is you can see like my Gaussian unit and my ReLU activation function seems to perform like outperform the other ones. Or similarly, I can see my G-flops is associated with my kernel size, which would make sense. So what I can do is using some of these observations in my subsequent hyperparameter tuning or in my subsequent sweeps, I can just narrow down that range. So let's say in my second iteration, I can only choose to have just the range that I see in here. So similarly, when I'm iterating on this, I can eventually narrow down my search and get to that best set of hyperparameters, which I know would result in the best performing model. So this is how you can easily achieve optimum results with weights and biases sweeps. So that's just one way of how you can perform hyperparameter optimization. Along with that, while you're training in, like machine learning is an iterative, it's always iterative because you're constantly trying to improve and improve as and when the new data sets is coming in, the models become, you need to train them so they correspond to the newer data that's coming in. So at the same time, while you're tracking in experiments, you can create a bunch of different dashboards within weights and biases. Like one such snippet is this particular line graph, wherein you can compare, I think this is comparing validation precision, but pretty much anything that you want. So it gives you better explainability as well as interpretability on what's happening in your machine learning workflows. So let's take this particular example. Here you can see for one particular line, I see there is a sharp dip. So what I can now do is I see there's something that's not working, or probably there's something that's going bad at that particular step. I think it's step number 30. So now what I would want to do is traverse back and see where in my entire project lifecycle can I improve to make sure my accuracy or my precision is always getting better and I can keep improving. You can only do that if you have a lineage or if you have some place where you have stored all of that data. And that is something weights and biases artifacts is helped to design. So what weights and biases artifacts does is, it's basically, I would say, that system of records where you can store pretty much anything that you would want for machine learning. So this is like a GitHub, but it's not just for code. It can be like for code, it can be for your data sets, any kinds of data sets, as well as for your models itself. So what artifacts will do you is it'll automatically version all of those different components that you would want to keep a track of. At the same time, it'll give you that lineage view. So the graph that you're seeing on the right, it's basically giving you that lineage view, which shows you all the different steps involved in your machine learning project. So let's say going back to the previous diagram, wherein I see something is not working well, like my model's not performing well, I can traverse back through this graph, and now I can pinpoint to that exact set of operations and narrow down like the final result or the final cause. Like, is it because I don't have enough data sets? If that's the case, I can go back and collect some more data set. Like, do I need to change my machine learning training framework, or what that result may be? So with that, I would say lineage view, you can easily trace back and get to that root cause. And anytime like there is anything, so let's say there is a bad data set that's introduced, you can again go back to that exact version of that code. Because as you're iterating, you end up creating like multiple different versions. And over a period of time, like when it comes to reproducibility, it becomes very difficult to track. Like, was it version 10 of my code that I used? Like, was it the version 100? And it basically takes a lot of time. Like, probably we have seen some customers, it has taken weeks for them because it wasn't well documented. But now I think with this lineage view, it's just like one click, you can just trace back and recreate that exact steps, and then make some changes or optimize or do whatever that you would want to create like better performing models. So these are just, I would say, like a quick snippet of some of the features that Weights and Biases offers today. So what you can do is going back to that continuous learning cycle while you're training in your models. So let's say you pull that data from Edge Impulse. You can keep training, keep iterating on that. You can have like Weights and Biases sit on top of this, like track all of those metrics, give you that results. And then once you're good with a certain model that you would want to eventually push to production or push to that edge device, you can go back to that loop, like test out that model, and then push it back to that edge device that you want. And this continuous cycle can, it is a constant cyclic cycle that you can constantly keep a track of. And as I mentioned before, I think this QR code is a link to that report, which basically walks through all the steps that I talked in very much detail. So let's say, like, if you would want to just recreate this bird sound classification project, you can just follow along the steps, or like for your own project, you can just follow this particular report. It also has links to some getting started code. So feel free to give this a try and like reach out to us if you have any questions or if you need any help with anything. As Sean mentioned before, like Weights and Biases is like free to use for like academics and research work. So anytime you would want to give it a try, I think this report can help you, and it has all the documentation links. So with that, thank you so much for having us, and yeah, hope you have a great day.
And welcome on stage, Chris Anderson, COO and Head of Product at Kitty Hawk.
Hello. I get to make the I'm the only thing between you and drinks joke. Thank you. The cue up on that. Actually, I'm CTO of Kitty Hawk, but that is not as impressive now that we've actually just closed the company. So we're a Larry Page effort, and those of you who are in Silicon Valley know that getting shut down by Larry Page is kind of a rite of passage. We all have to do it several times. This is my first. Well, there will probably be more. These are the various things that we've made over the years. Things, single-person ultralights, things that transition, things that have tilt rotors. Largely create a lot of the it's called eVTOL, electric vertical takeoff and landing industry, and just up the street in Palo Alto, and it's like a right out of a Pixar film. It's an incredible laboratory of cool stuff, and yes, we shut down the projects every few years, and we keep starting up new projects. So what I'm going to talk to you about a little bit today is how we use machine learning in them. We didn't for many years. For many years, the notion was that there would be a pilot. It'd be relatively traditional. The reason it had to be relatively traditional is that aircraft have to be certified by the FAA to be allowed to fly, and the FAA doesn't like machine learning for reasons I'll talk about in a moment. But basically, they don't like novelty. They like things that have flown before, and you know, that tends to steer the industry back to conventional aerospace thinking. Meanwhile, Larry Page, and you know, as you might imagine, comes from the internet generation. You know, Google data centers, and you know, wants to truly transform. So the question is, how do we bring machine learning into the process in a way that is both innovative and also safe? And so we start with the edge, as you know, is very appropriate for here. So these are some of the ways. So when you have an autonomous aircraft that is like an air taxi, the traditional way of thinking about this is that there's a pilot, and it takes off at a vertiport, which is like a heliport, and it flies to another vertiport. And you know, so how do you get from point A to point B? And the answer is what they call multimodal. You have to sort of drive to the vertiport, airplane to vertiport, and then drive from the vertiport to where you want to go. And it's like not necessarily faster and not necessarily cheaper. And so our notion was, well, this should just land in, you know, where you are. It should be like Lyft or Uber in the air, and we should land anywhere. You know, it's about the size of an SUV, and it should land anywhere an SUV should go. So how do you do that? And the answer is that our sister company, Waymo, the self-driving car company, has the same problem. How do you pick up and drop off people in a random area? And the answer is you pre-survey the area to find places that are likely to be a good place to pick up and drop off. And then as you approach that area, you have to confirm that it is still, you know, a clear place, that no one's double parked or there isn't a baby carriage or something like that. We have to do the same thing in the air. And so what we do is we pre-survey the sites as having likely clear, it's a park here or it's a parking lot there. And then, but as we get close, we have to confirm that it's still clear. And what's worse is that with eVTOL aircraft, there's this helicopter phase and then an airplane phase and then a helicopter phase. And in the helicopter phase, it uses a huge amount of energy. These are all electric powered, and energy is really the thing we have in short supply. And in the airplane phase, it's very efficient. And so what you want is you want to stay on the wing as long as possible before you commit to a hover. So basically, we want to be able to, as we're approaching the green zone, we want to be able to kind of discern, as we're going very fast at like 1,000 feet, you know, assign a probability to the site actually being clear. And that probability increases as we get closer and closer until at some point the probability is high enough that we can commit to the hover. And then we have to keep looking as we come down to make sure that it really is clear. So obviously the way we did this was machine learning. This was trained on mostly synthetic data, which is like a lot of video game data. And you know, increasingly we brought in real world data. And it was running on a Raspberry Pi. So there you have it. It's using a Luxonics camera. It's a monocular camera with a global shutter. It's got a smart chip. It's got a Myriad X chip in it. So that's doing some of the work with basically a Raspberry Pi 4, which is pretty cool that you can do that. And it worked. It worked great. So we obviously tried it at large volume and sort of drone size. And had we not been shut down last week, we would have been trying it full size relatively soon, but we'll get back to that, and we'll start doing it. So that's one way we use machine learning. And obviously, we need to train with more data sets, and we need to bring things like stereo cameras so we can have depth, and we need to start integrating multimodal, like LiDAR and radar into it as well, and that's all part of our machine learning pipeline. Another way we're doing is that, remember, we have no pilot. I know this sounds crazy, but if you go to San Francisco right now and get a taxi after, like, I think 10 o'clock, you could get a Cruise or a Waymo taxi, which is completely driverless. You get in the back of the car and it just takes you from point A to point B. So that's a thing. We want to do the same thing with air taxis. So you basically pull out your app, you say, I want to go to, you know, Half Moon Bay or whatever. And then, you know, 5 minutes later, this airplane kind of comes out of the sky, lands in front of you. You get in. There's no pilot. It's just you in a seat. It takes off and takes you to Half Moon Bay, and you get out. So what this means is we don't have traditional stuff like we can't file flight plans, and we don't have air traffic control, et cetera. We basically have to take all the objective functions that determine how you fly from point A to point B, and compress them all into a topology. So they start with things like shortest distance. Then we have to consider things like wind, regulatory constraints about different classes of airspace, other vehicles, which is called deconfliction. We have to consider passenger comfort. We have to consider noise. Some localities may not want noise overhead. We have to consider where you're going next, when you might have to recharge. And all these factors we reduce into topologies. We basically sort of assign them all. We sort of consider them like contours on a map. We assign them all different weights. We then compress them all into one big topology, and then we just gradient descent our way through it. This is, in robotics, this is called path planning or motion planning. The difference between path planning and motion planning, by the way, is that path planning is basically going, here's the path I'm going to follow. Motion planning also has to take into consideration the physical limits of the vehicle, like our turn radius. If we're in airplane mode, we can't just turn on a dime. We have to sort of go around in a big circle. We might have certain structural limits to the vehicle. There could be wind and weather constraints as well. In airplane mode, we have a big turning radius. In helicopter mode, we have a very tight turning radius. We can just sort of basically literally hover in place. So all those things turn into a very complex path, and the way to do it is standard old gradient descent. But unlike traditional robotics, where you might do that, but you would do it before you left, and you would then have a path, and you would execute the path. We knew we need to do it in real time. And so basically, the environment is a state, the aircraft is a state, and the environment is constantly streaming functions at us. And we reduce those functions into a topology. We then differentiate, get a gradient, and we basically just follow this gradient as it changes from point A to point B. This has like never been done before. This is exactly what a robot would do, but it's never been done in aerospace before, and the FAA has no idea what to make of it. Another thing we do is, as we tune it, as we create the controls for the vehicle, the way you would, let's say you're flying you're a pilot flying an airplane, you'd get to the airplane, you try, wiggle the wings a little left and right, nose front and back, et cetera, and kind of get a feel for it, the moments, the inertia. How does it feel? And the good thing is the software can do the same thing. And so this is basically a sort of a gradient descent as well, where the aircraft takes off and then does these sort of wiggle things. And as it starts to feel, okay, I commanded this thrust and I got this movement. Okay, so I need to command more thrust to get that movement. And then the difference between the demanded and achieved is once that blue line, which is the P term in a PID controller for the nerds. Once that blue line gets to the top, you know that it's like tuned. And then you do that for all your other functions, including navigation and everything else. And so it teaches itself how to fly, which is pretty cool. But the problem is that the FAA has banned all of this. So they banned it because the FAA is primarily concerned about safety. And what they want to know is that the aircraft is deterministic, which is to say we can predict what it will do. And they accommodate the notion of a non-deterministic function. That non-deterministic function is called a human being. A pilot is non-deterministic. And a pilot can crash into a mountain if they so choose, but the airplane should not do that on its own. You should have absolute predictability about what the airplane will do. So the problem with machine learning is that from their perspective, it's a black box. It's non-deterministic, it's probabilistic, it's stochastic. And the FAA is like, we have no idea how to qualify that. How do you prove to us that it'll work? And we don't have a good, there's basically two answers to this. The first answer is that, okay, fine. We're going to keep machine learning out there in kind of the pilot side. So think about the airplane. The airplane has to, the first job of the airplane is to fly. And the second job of the airplane is to get from point A to point B. So the flying part, don't fall out of the sky, that's deterministic. And the fly from point A to point B is basically what a pilot does, and that's probabilistic. So we stick the machine learning stuff all out and we take the pilot out of the seat, we put machine learning in the seat, and it sort of resembles a model that the FAA is pretty familiar with. They're like, okay, that'll work. However, you've got to make sure that when the machine learning says something stupid, that the deterministic side doesn't do it. And so you have to have what's called this runtime assurance layer, a super hardened interface between the machine learning side and the classic control theory side that will sort of block bad stuff. The problem is, and those of you who have ever gotten into this, is that any interface that's smart enough to know what is sort of, crazy, has to be basically as smart as the machine learning function itself. So let's say that the machine learning function is saying, hey, fly into that mountain. Well, the interface needs to know the mountain exists, right? So now the interface has to have like a sense of topology. And let's say that it's not a mountain, but now there's like a construction crane that wasn't there yesterday, but it's there today. The machine learning algorithm doesn't know about it, it says fly there. The interface needs to be at least as smart as the machine learning algorithm. And so now you have this weird sort of metaphysical problem where your sort of policing function has to be smarter than your actor function, if you will, which means that maybe it's a machine learning function itself, which means it's non-deterministic, and then the FAA's head just. So we have not figured out how to solve this. So the good news is that everybody understands that aviation is held back by this. And autonomous cars have machine learning functions. Why shouldn't aircraft? We have to solve this. And so there's a proposal, not a proposal, there's a commitment by the FAA to do what's called performance-based certification. So the old certification was every component has to be proven deterministic, it has to work. And you stick a bunch of certified components together and you get a certified system. The performance-based model is like, we're not going to look under the hood. It is what it is. If you can show us that it can fly 1 million hours without an accident, that's good enough for us. So all we need to do is fly 1 million hours without an accident, and we're there. So aside from the fact that we were shut down last week, we're on track. We'll restart, and we'll get there. But that's really the function, is that somebody's going to have to be a billionaire, is going to have to go out there and fly machine learning so many hours and bring this big old hunk of data proving that it works before any regulator will allow it. So it is it's not a technical problem. It is almost really it's almost a kind of a courage and funding problem. And that's why it's going to take a billionaire or two to do it. Okay, so that's my day job. I also have a hobby that is somewhat related, which is that so my whole aviation world started with drones, and I started a community called DIY Drones, and that turned into a community, a development community, and that turned into something called Drone Code in the Linux Foundation. And that is the core of most drones that aren't Chinese today are running our software. But weirdly, that's a kind of a solved problem. Drones just work. You can buy them in Walmart. Whereas self-driving cars, which you would think would be easier, are actually harder for two reasons. The reason drones are so easy to solve is that actually staying in the air, like not falling over, was kind of hard, and that involves gyros and accelerometers and things like that. But just getting from point A to B, that's just GPS. I've made it more complicated with gradient descent, but really it's just GPS. But with cars, first of all, our cars are being raced indoors, so there's no GPS, so we have to use cameras, other sensors. And secondly, with the airplanes, you can be off by a few meters, doesn't matter. With the cars, you got to stay on the track. So you need much more precision. So we have to do computer vision at high speed with high precision, which is actually something that nobody else is solving. The Cruises and the Waymos and the Teslas, et cetera, are largely solving a safety problem, but they're not solving a speed problem. The history of automotive innovation has always been racing, except for in self-driving cars. So we decided that much as like DIY Drones was about bringing kind of Raspberry Pi or Arduino like innovation to aviation, this is about bringing Raspberry Pi and cheap cameras and open source machine learning to automotive. And it looks like a toy. These are like small vehicles. They're about yay big. They cost under $400. And we operated first in things like this, like in warehouses with tracks that are spray painted by my children. And they're basically they're designed to be as cheap as possible. They're end-to-end neural networks, which is to say that you have a camera and a Raspberry Pi and you have a model. And typically, there's a couple of different methods which I'll get into, but often it was using what's called behavioral cloning, which is basically drive the car around manually around the track, and then the neural network correlates what the camera saw with the commands you gave, and then that's your data set. You send it up to the cloud, you run through Keras, and you end up with a model, and then it just runs the model And so it just runs the inference layer. It doesn't do training on board, it does training off board, but runs the inference layer with a Raspberry Pi on board. And they're very simple, and they work great. And we use the stuff you would recognize, TensorFlow, Python, and Raspberry Pi. Sometimes we take them and make them a little bit bigger. This is a go-kart size of it. This one is, that is actually Carl Bass, the former CEO of Autodesk. And that he made that car with his son. And our main thing was to basically take the steering wheel, put a big old servo on it, and which made it was impossible for a human to drive it. And now he's a crash test dummy with one red button between him and disaster. He was actually actively the CEO of a publicly traded company at this point, and I'm sure that his board would not have been happy had they known that he wasn't even wearing a helmet. Anyway, he survived. The car did not, but he did. And that's about as far as we took that size. Amazon decided to emulate this, and they created something called the Deep Racer, which is using their reinforcement learning methods, RoboMaker, et cetera. Interestingly, it doesn't work at all. It basically, this whole experience with Deep Racer convinced us that reinforcement learning is a terrible idea in the real world. So the way Deep Racer works is that you have a simulator, you use reinforcement learning, you have objective functions, you have cost functions, you've got goals and penalties and all this kind of stuff. Works great in the simulator. Bring it into the real world, never works. It's like shadows and lighting, and the problem is the sim to real gap. That the real world is always different. The simulator was always the same. The simulator had perfect information. The real world has imperfect information. You can train rapidly in the simulator. It takes forever to train in the real world. So that didn't work. This is about as good as it got, and which is not great. And then we decided to use some other techniques. This is a nice one. This one is here, let me see if I can get this going. This one is what's called cone slam, and this is actually looking at these cones on the track and localizing itself based on that. That's a particle filter on the top, and it sort of assigns probability. What's interesting is that after cone slam worked, we started screwing around with them a little bit, and so we had a small child place a random cone somewhere on the track. The small child is assigned as the random cone generator. And so then the racers got clever enough, so they said, okay, smart guy, we're not going to look at the cones anymore. Now we're going to look at the lights on the ceiling, which is a fingerprint that'll tell you where you are and never moves. And so now it's light slam, and we don't know how to mess with that because the light's too high to reach. So this is the way that the racers and the track masters compete to make things hard. This is basically just a comparison of how this looks compared to a traditional autonomous car. And basically, we try to do everything a Waymo does, but like a lot cheaper. So we have radar, we have LiDAR, we have encoders, we have cameras, we have GPS, we have everything they have, except for ours costs, there's a limit of $400. And you can actually do a lot with this stuff. I wouldn't get in it, but at 1/10 scale, it works fine. Then we decided to really build out the simulator well. And so we took a track from, there's a company called SparkFun that sells electronics in Boulder. And they famously had a race called the Autonomous Vehicle Challenge for many years. Anyway, they canceled it, but we've had it live on in simulation. And so we built a simulator, and now every month we oscillate between virtual races, which are all done in simulation, where the people run their code at home, but that the cars are simulated and the cameras are simulated. And then we do real ones, alternating between indoors and outdoors. And then these are a little bit of the different approaches. I mentioned behavioral cloning and reinforcement learning. Sometimes we also use just traditional computer vision, and then outside we can use GPS and other forms of beacons. And I'm running out of time, so I'm going to zip through this one. Basically, here's what's going on. That deep learning was doing really well, except for the computer vision team got ahead. And they got ahead by using the techniques, by using localization, by, again, looking up at the lights or looking down on the cones or using GPS. If you know where you are on the track and where the curves are coming, where the other racers are, you're always going to do better than if you don't. So localization always wins, but it's a little cheaty. You know, you need to know something about the track. You need to have some sense of where you are. What's interesting is that we blew past, this stops 2 years ago, we blew past humans. It was incredibly easy to beat humans. The reason being that we actually forced the humans to wear first-person view goggles and to drive based on the same camera view that the cars had. And it's really hard, because you're like right down here. And it's really hard to see the track. And so the humans, it was not hard to beat the humans. And we're going so fast. We're basically doing scale speeds of 250 miles an hour. I've already talked about the breakthrough technologies, but basically this is the golden age of this stuff. The computer vision cameras are fantastic. The open source software, the Raspberry Pi is perfectly good. You know, the interfaces, the servo interfaces and the various sensors that are available, everything's awesome. And so, you know, this is the perfect time to be starting this kind of thing. And, on your mark. Here we go. This is go. And this is an example of 2 cars now racing head-to-head in our simulator. These two, we do this, I mentioned, every other month. This is me emceeing it. And they're getting pretty good. At this point, this is a reinforcement learning car versus a behavioral cloning car. And now they follow the track fine, and now they're getting into some actual tactics. So they get points for going over the hoop. They get over the jump. They get points for going the hoop. They get points for going through the barrels. There's a pedestrian here, which is a pedestrian that randomly crosses, etc. And so it's really cool and free and open, and you don't even have to wait for our event. You can just run it the server locally. And finally, I just wanted to end up at the point, which is that the only real efforts to do this in the big guys are things like Robo Race, which cost $1 million and just got killed. The big guys just don't want to do this because the big cars cost too much, the crashes are too expensive, it's too embarrassing, and it's just a gap there where the only racing is being done at small scale by people like us, and it is crazy that the speed, the aggressive driving side of the equation is being done by a bunch of hobbyists online, and you could say, well, that's irresponsible, and yet. What is the biggest peril with self-driving cars is that they're going to slow us down. They're going to be the most conservative drivers on the road. We're already seeing some examples of this. What you want is you want safety through nimbleness, not safety through slowness. And so we are like the only people who are exploring truly nimble, meaning the community broadly, truly nimble, aggressive, safe driving, as opposed to just going slow. So, this is not pretty. This is what happened when Robo Race started off. This is $1 million car created by the biggest companies in the world. By the way, our cars crash all the time too, but our cars are created by 12-year-olds for like pennies. So, with that, speaking of crashes, at the end of every race, we have the demolition derby where all cars must race, and it looks like this. What's cool is you're going to see it hit a boy again, a third time. Anyway, it's good fun, and I'll just finish up with actually, I'll go back one. Oh, I don't have a reverse slide. I guess that's a lesson to me. You cannot go backwards. There you go. Thank you. You can buy things off the shelf. They're fun. They're a great way to get started. And this Saturday at Circuit Launch in Oakland, we're going to be having a race in person with a Brazilian barbecue. It's free. And come join us. All details are here. Thank you very much.
And welcome on stage Zach Shelby and Yan Yamboom for the closing.
Thanks, everybody. It has been an amazing Imagine 2022. Thank you, Chris, for the absolutely inspiring presentation. I love the Silicon Valley attitude. Yeah, we made a self-flying car, taxi. It got shut down, and we're just going to do it again because this is what we do. This is exactly the attitude. And I love the self-driving race cars that developers and makers and hackers are the ones building the coolest technology on the planet.
And so an interesting fact, Matthijs built something like this actually using Edge Impulse about 2 years ago. So if you search for self-driving car Edge Impulse, you'll find something that you can actually build and model in the studio and do something similar.
I think we need to send him Saturday to compete in the do-it-yourself. We'll have a new category, the Edge Impulse category for self-driving racers.
Now the important stuff. We're organizing a happy hour reception. Not here, but in the Emerald Hour. Emerald Hour? Yeah, in the hotel next door.
The Shashi Hotel, just 1 block away.
I checked it. It's 220 meters in European distances and like 8 stones or something in US distance.
Anyways, be there at B Square. We had an amazing after party last year. We won't tell all the stories. You had to be there to know, but amazing after party. Please come by. We've got great snacks, great drinks. They have one of the best old-fashioned menus in town. So please join us for the after party to hang out. My takeaway from today was, wow, what an amazing day. Amazing keynote speakers. You probably noticed I was the edge of my seat the entire day. Like, wow, all these applications, more applications, even more end customer use cases. How are we ever going to do all of this? I'm thinking like 20 years, 30 years of ML engineering might get through it. So we've got our job cut out. We've got our job cut out as an ecosystem to go solve all these amazing problems. And that's what we're here for. That's what we came to do. On your way out, please remember your gift bags. We've got gift bags for everybody coming to the event today. Please remember your gift bag, and we will see you soon in an AI universe to come. Thank you.
Thanks all. Right. That's